Hello, hi, namaskar everyone. My name is Deependra and I welcome you all in this one shot where we'll be discussing the chapter Sequence and Series completely and thoroughly. This is one of those chapters which is considered to be a very simple and easy chapter because the concepts are really straightforward. You learn them, you apply them, and you can score some really good marks from this particular chapter. In 2024, 30 questions were asked, and in 2025, 24 questions were asked from this particular chapter. Arithmetic progression, geometric progression, and summation of series is one of those prominent topics from where they ask questions from this particular chapter. And this is not just another ordinary one shot where we are just simply covering things. We are rather going to cover everything from this particular chapter from scratch to JEE mains and advanced level. So all the concepts, all the learnings will be discussed along with a lot of concepts, nuances, and with a lot of short techniques and previous year's questions. So with this video, we are starting this particular part, and along with this one shot video which we are providing to you at absolutely no cost, the DPPs and these notes are also provided to you at free of cost. The notes and the DPPs are available on our PW app, link to which is already given in the description. So without further ado, it's the time that we get started. I hope you can access all the material on our PW app, from where a lot of aspirants are already preparing for different competitive exams and getting success. So first of all, let us understand what all we'll be discussing in this one shot of sequence and series. We'll begin with arithmetic progression. This is one of those topics from where the maximum number of questions are asked by JEE mains. Then we'll talk about GP, which is the third most important. Then what is the second most important, sir? I'll come to that, don't worry about it. Then we'll talk about HPN means, arithmetic mean, geometric mean, and harmonic mean, the inequality, the relationship from which questions based on maximum and minimum value of an expression are asked, which is this part basically. And then we'll talk about AGP, and then we'll come to different summation of series techniques. For example, telescoping sum, which is called VN method as well, or we'll talk about the method of difference and a lot of other different techniques to solve questions. Second most important topic is this only, summation of series. So a lot of different category of series or sequences you're given, and then you're asked to add or subtract them as per the need of the question. So that is what we'll do. So AP, then summation, and then GP. These are the three most important topics. I'm not saying that these are having no relevance or significance. Inequalities, harmonic progression, or means, they have their own significance. Questions are there on these topics as well, and you need to understand, even if a question comes from means and if it gives you +4 marks with such an easy concept, you should learn it with utmost integrity and sincerity. With that, let us move to the next part where we'll start discussing the basic concepts of this particular chapter with a lot of illustrations and previous year's questions. If I were to explain you what is an AP in a very simple language, in a very straightforward language, I'll tell you that arithmetic progression is basically a sequence where you have the first term, and to this first term, you basically add a fixed number, a fixed value, a fixed common difference, and then you get the second term. Mind you, students, once you have attained the second term, to this second term, the common difference is added, and that's how you attain the next term. So if you pay attention, then I can very clearly see a lot of things. For example, here, the difference between consecutive terms, that is first and second term, second and third term, third and fourth term, that difference remains constant. What is that difference? That difference here in this case is D. How? A plus D minus A will be D. A plus 2D minus A plus D will be D. And why should it not be D? Because we have attained the next term by adding D to the previous term. So the common difference is going to be D. So if that is the kind of a sequence we are dealing with, where the common difference remains constant, it remains same, then such sequence is called an arithmetic progression. I hope this part is very well understood by you all. Basically, we are getting the next term by adding a fixed value to the previous term. That is the definition we are following. Now, the next part says that how do we generalize a term? So here we had the first term as A. In the second term, we had A plus D. In the third term, we had A plus 2D. In the fourth term, we'll have A plus 3D. So do you not think if I were to write the nth term, it will be A plus n minus 1D, because the nth term has the coefficient of D as n minus 1. The third term has the coefficient of D as 2. The first term had 1D, sorry, the second term had 1D. The first term had 0 into D. So n minus 1D will be there with the nth term. That's how you can generalize the nth term. I hope simple it was. Now, if AP is basically what you're able to understand, then I'll say if I'm having the kth term and I'm having the k minus 1th term. So two consecutive terms I'm having, kth term and k minus 1th term. And if the difference remains constant, the difference between two consecutive terms, kth term and k minus 1th term, any two random consecutive terms if I take, and if I take their difference and if it is found to be a constant value for all the terms, if pairwise taken consecutively, then and if this common difference is found to be independent of k, so that there it should be a fixed value. It should not be dependent on k. It should not have any dependency on any other variable. It should be a fixed value, as we have already discussed. If that kind of scenario is found for all the values of k, then I say that such progression or sequence is called an arithmetic progression. Did you all get that? Which means second term minus first term, third term minus second term, and so on. All these differences will remain same, which is D, the common difference, for such a scenario where you are dealing with an arithmetic progression. I hope this part is self-explanatory. Nothing much is needed to be said or done in this case. Now, there are certain properties which you should remember related to an arithmetic progression. Some observations I wish to make you understand. What is the first observation that you must learn or understand? Which is, if A, let's say, is said to be the first term and we call D to be the common difference, then we all know that first term will be A, the second term will be A plus D, the third term will be A plus 2D, and so on. If I look at the pattern, if I observe the pattern, I'll be able to conclude that the nth term is going to be A plus n minus 1D. I hope there is no confusion on this particular part, where I am clearly mentioning that this n is a natural number, which is helping us in understanding that which index of that number or position of that particular sequence is. For example, if this is the third number in that sequence, then it will be A plus 3 minus 1D, which is A plus 2D. If I were to ask you the seventh number, seventh term in that sequence, you would say A plus 7 minus 1D, which will be A plus 6D. That part I hope is very much clear to all the participants here. Now, let us move ahead to the next part. If we add the common difference to any term of an AP, we get the next following term. That's exactly what AP does. That's exactly what AP is. So to any term, if the common difference is added, you get the next term. So that is the property of the AP, or rather I'll say this is what AP is. So AP is bound to follow this particular conclusion. Now, and similarly, if I subtract the common difference from any term, I'll get the preceding term. That is also what is going to happen. Always remember this as a conclusion, or rather you will get used to this particular conclusion. There is something very interesting. The common difference of an AP can be positive, zero, negative, or imaginary. This all depends. So I can have a complex sequence where, let's say, I'm adding iota. So it could be 2 plus iota, then 2 plus 2 iota, then 2 plus 3 iota, then 2 plus 4 iota. As we can see that in that case, the common difference is iota, imaginary. Sir, what if the common difference is 0? Can you help me with that? If the common difference is 0, the sequence is going to be a constant AP. What do you mean by that? See, let's say if I'm having the common difference to be 0, let's say the first term is 3 and the common difference is 0. So 3 plus 0 will give me 3, 3 plus 0 will give me 3, and so on. So if the common difference is 0, this is still called an AP. Or in a later turn, where you'll realize this can be said a GP as well. But as of now, let us call it an AP. For GP, the common ratio must never be 1. So if you're calling it to be an AP, GP, or HP, in that case, all the elements should be same. This property we'll discuss later, don't worry about that. But as of now, I'm restricting my discussion to this part only, that if it is an AP, which is said to be a constant AP, then it will be possible when the common difference is 0. I hope there is no confusion on that. Now, let us go back to the properties we all were discussing. The next property is again a pretty simple one. It says that constant AP, the common difference of an AP is equal to 0. That's exactly what we have discussed. So some very basic observations I have discussed related to an arithmetic progression, which I'm sure you all must be aware of. If you were not, you must have realized these observations through this particular discussion. Now, let us move ahead. Let us move further with some more observations. Another observation. If you are dealing with an increasing AP, what do you mean by increasing AP? So if let's say I take an AP where I'm having 3 plus 2, 5, 5 plus 2, 7, 7 plus 2, 9, 9 plus 2, 11. I can see that the terms are increasing. So when will I have an increasing AP? If the common difference of the AP is greater than 0. Of course, it can be understood that whenever the common difference is positive, so whenever you are adding this common difference, which is a positive value, you will keep getting larger or greater value than the preceding term. That's exactly what I'm trying to convey when I'm saying that if you are having a positive common difference, you will get an increasing AP, which means terms will constantly keep on increasing. But when it comes to mentioning or talking about a decreasing AP, what does it mean? It means that the common difference of AP will be less than 0. Did you get that part, students? What I'm trying to make you understand is, I hope you can see it very clearly. Let's say the common difference is minus 3 and the first term is, let's say, 7. I hope nothing should concern you here. Let's say the first term is 7. The common difference is minus 3. So 7 minus 3 will be 4. 4 minus 3 will be 1. 1 minus 3 will be minus 2, and so on. So I hope you can see it very clearly. If the common difference was negative, less than 0, then the terms kept on decreasing gradually. And that's exactly what happens when you're having a negative common difference. So for a negative common difference, the terms will keep on decreasing. Which means you will have a decreasing AP. I hope this part is also very well understood by you all. What do you mean by imaginary AP? Well, if the common difference is imaginary, sir, what does it mean? It simply means a very simple phenomena which you all must understand is that, let's say if the first term is 2, let's say the common difference is iota. So the next term will be 2 plus iota. What will be the next term? The next term will be 2 plus iota, which will be 2 plus 2 iota. Then the next term will be 2 plus 2 iota plus iota, which is 2 plus 3 iota. As you all can notice and understand that here in this particular AP, the common difference, if noticed properly, is basically iota. So if you are dealing with an AP where if the common difference is iota, I'll say that yes, in this particular case, the AP is said to be an imaginary AP. Did you all get that part? So if you ever encounter an imaginary AP, don't get confused that such thing doesn't exist. Such thing does exist, and with the conclusion that the common difference should be iota or any imaginary number, 3 iota, 2 plus 3 iota, anything like that. Now, let us talk about the next conclusion which you should remember. For example, let's say I'm given an expression. I'm given a generalized nth term. For example, let's take any example. If I were to give you an expression, let's say, where I'm saying that Tn is given by, let's say, 3n plus 2. So this is how I'm writing Tn. So what do you mean by Tn? So by putting different values of n, I can find the different terms of this AP. How? If I put n equal to 1, I'll get the first term. So first term is going to be T1. What will be T1? 3 plus 2, that will be 5. What will be T2? T2 will be 3 into 2, 6 plus 2, that will be 8. What will be T3? T3 will be 3 into 3, 9. 9 plus 2 will be 11, and so on. But do I really need to do this? Let's say if I define Tn, the nth term, if I were to give you the generalized expression for the nth term, and by looking at that Tn only, without even finding all the terms and comparing them and then getting the result, can I, by looking at this nth term, the generalization of nth term, can I conclude whether it is an AP or not? Yes, there is a formula. How? Let's learn that particular result. The formula is very simple, students. All you need to understand is, first of all, either what you can do is you can find the first term by having the value of n as 1 and find the second term and then the third term. That is the approach. Or rather, if you are given the nth term, can you find the n minus 1th term? Yes, we can find the n minus 1th term. So how can you find the n minus 1th term? See, if you are given Tn and if I replace n by n minus 1, will I not have n minus 1th term? So if I replace n by n minus 1, I'll have 3 times n minus 1 plus 2, right? What will it be? 3n minus 3 plus 2, which will be minus 1. So the n minus 1th term turned out to be 3 times n minus 1 plus 2, which is 3n minus 3 plus 2, which is 3n minus 1. Now, what do we know? We know that if a sequence is an AP, then the consecutive terms difference should be the common difference. So if the next term minus previous term, if I were to find it out, it should be the common difference. What does it mean? It simply means that if I evaluate this thing, which thing, students? Tn minus Tn minus 1. So this should be a constant term which should be independent of any n or any sort of that expression. Let's find it out. If it is found to be a fixed value, I'll call it the common difference and I'll call it the AP. Let's check it out. So Tn is found to be 3n plus 2. Here we have this Tn plus 2 minus Tn minus 1. What is Tn minus 1? It is 3n minus 1. Now, checking it further, what do I have? I am having 3n plus 2 minus 3n. So 3n minus 3n. 3n is getting cancelled. 2 minus minus 1 is 3. Well, 3 is a constant term which can be said called the common difference, and hence I can call it an AP. Always remember, whenever you are given a linear expression in n, so if Tn is expressed as an plus b, whenever Tn is expressed as an plus b, you should remember this as a result. That this will always form an AP. I repeat, the conclusion is very simple, students. What I'm trying to make you understand is that if you are given the nth term as an plus b, so whenever you deal with the nth term as an plus b, where a and b are constants, and in this case, don't hesitate in saying if any sequence has nth term defined as an plus b, then don't hesitate in saying that this sequence will be an AP. Did you get my statement, students, very clearly? I repeat my statement. If you are having a linear expression in n, for example, 3n plus 2 or 3n minus 1 or 5n plus 6, something like that, and if the nth term is given by this general simple expression, linear expression in n, then I will not hesitate in saying that this expression, the sequence, if the sequence is formed with the help of this expression, it is going to be an AP. Always remember this. Not just that, along with this expression, you can draw a lot of conclusions. For example, we have Tn as an plus b. So can I write the common difference? The common difference will be Tn minus Tn minus 1, nth term minus n minus 1th term. It will give me the common difference. So nth term is an plus b, and n minus 1th term will be a times whole of n minus 1 plus b. So if I take that difference, I finally get a. Now what is a? As we have already discussed, if Tn minus 1 is done, and if you get a constant term, let's say a in this case, then it will be the common difference. I hope you will remember this as a result. So whenever you're given an plus b, if you are given nth term by an plus b, then always remember the coefficient of n over here will be the common difference of your sequence. That's it. For example, if I say Tn is 3n minus 1, will it be an AP? Yes. What will be the common difference? The coefficient of n, which was 3. That's it. Did you get that part? Not just that, what you also need to understand is, let's say if I'm asked the first term, of the sequence. So how do you find the first term of the sequence? So to find the first term, let's call it small a. What will be that first term? I hope I need not write it here. You must have calculated it by yourself. The first term, if Tn is given by an plus b, T1, the first term will be given by a into 1 plus b, and which is going to be nothing but a plus b. So these are the two results I am asking you to memorize. The first result is, if a sequence is denoted by an plus b, nth term is given by an plus b, in that case, coefficient of n, which is a, should be the common difference. It will be an AP first of all. The coefficient of n will be the common difference, and this sum, a plus b, will be your first term. So these are the three learnings you must have with you. Now, proceeding ahead, what additional details do we know? What extra are we aware of? Let's work on knowing that. Here, if I were to ask you to define the terms, we have already discussed a plus d, a plus 2d, a plus 3d. If from the end, if I were to define, let's say the last term is L. So the second last term, do you not think will be L minus d? Because if from the term common difference is subtracted, you get the preceding term. So from L minus d, if d is subtracted, you'll get the third last term, which will be L minus 2d. So I'm trying to give you the idea that either from the beginning or the end, the terms can be predicted. From the beginning, you add the common difference, and from the end, you subtract the common difference. Are you getting this part very clearly? So if you look at the pattern, you can generalize it. Not just that, you can generalize a lot of things. What do I mean by that? Have a look at this particular part. Can I say first and last term when added give you a plus L? Can you help me with the second and the second last term? So when I add second and the second last term, this d gets cancelled by this d and I am again left with a plus l. Let me give you one more observation. If I add third and the third last term, a plus 2d and l minus 2d, again I'll see 2d and 2d getting cancelled and then again I'll be left with a plus l. Did you notice this particular observation? The observation is very simple and crucial. It means if I add first and last term, if I add second and second last term, if I add third and the third last term, if I add fourth and the fourth last term, I'll get the same sum, which is equal a plus l, sum of the first and the last term. So what I'm trying to make you understand is equidistant terms. Let's say there is a center, there's a middle term, and from this middle term, if I take the sum of the equidistant terms, then that sum will remain constant. I hope you are getting it. First and last, second and second last, third and third last. Did you notice that observation? Although we'll discuss it as one of the properties, but since we are already having this pattern written over here, the sequence written over here, so I'm making you observe and analyze this particular property. What we are supposed to write is nth term of an AP from beginning, which now I don't think I need to mention. You all must be ready with that answer. What would it be, students? It should always be first term plus n minus 1 times the common difference. This is how you write the nth term of a sequence. I hope you must have understood that nth term of an AP is given by this particular formula. You will remember this particular result. I hope no confusion on that. But what is more interesting here is that, do you know the formula? If I were to ask you that, can you find nth term from the end? I hope there is a formula for that as well. How? See, first term from the end was L. Second term from the end was L minus D. Third term from the end was L minus 2D. So can I generalize that nth term from the end will be L minus n minus 1D? As I have already mentioned, if we are beginning from the beginning or starting and we are finding the nth term, then it is a plus n minus 1d. So if we want to look at from the end, would I not say it should be L minus n minus 1d? Because from the last term, if I want to look at, then I will be subtracting. If from the first term, if I'm looking at, then I'll be adding. So if I ask you nth term from the beginning, it would have been a plus n minus 1d. But if I'm asking you nth term from the end, you will say L minus whole of n minus 1d. Did you get this generalization right there in front of you? I hope there is no confusion on that. Now, if I move ahead, if I proceed further, the conclusion which I am trying to give you is that sum of nth term from the beginning and the sum of nth term from the end will always remain same, which is the sum of the first and the last term. I repeat this conclusion. Remember this as a result. Another very crucial property, that if you are given nth term from the beginning and nth term from the end, then their sum remains constant and this sum will always be equal to the sum of first term and the last term. Will you remember that result? I hope there is no confusion on that. And this is exactly what we are trying to convey here with this particular presentation. Now, moving ahead with the next property. Now, there are certain understandings which we have understood so far. Let us understand those remarks. First of all, I hope you must have understood the nth term or the rth term is called the general term. So if I were to ask you how to write the rth term, the conclusion will remain very simple. You will say, sir, rth term, if I wish to write, it will be a plus r minus 1 into d. So this is how we write the rth term of an AP. This is all what I'm discussing is limited to arithmetic progression only. Nothing else is being discussed here. Then next observation. If last term of an AP is Tn and the common difference is d, then terms of an AP from end are going to be Tn, Tn minus 1d, Tn minus 2d. That's exactly what we have discussed in the previous slide. The next observation is, if there is a sequence and the terms are alternatively positive and negative, then you can always say that it can never be an AP. I repeat, if there is a sequence and nothing much is said about it, all what they are giving you is that the terms are alternatively positive and negative, and one of the option reads as AP, then you will straight away discard that possibility. Because are you understanding that an AP will be either increasing or decreasing, except it is a complex AP. So if it is a real AP, if it has real terms, then terms can be compared. And if the common difference is a fixed value, then it will be either positive or negative, except it is 0. So If the common difference is either positive or negative, in that case, I'll have either the terms to be increasing or the terms to be decreasing. So how can I have one of the terms as positive, next term negative, another term positive, another term negative? No, that cannot happen. If that is happening, then the sequence is increasing, then decreasing, then increasing, then decreasing, and that cannot happen with an AP. That can happen with a GP or something else, but as of now, if I restrict my discussion to an AP, then this can never happen with an AP. So if you are seeing terms to be alternatively positive and negative, you can come up with a conclusion that this sequence can never be an AP. Did you get that part? Now, next conclusion is very important. You should remember this also as a result. I'll definitely show it to you. How did it come from? So let's say the last term is given by L, which is written as A plus N minus 1 times D. Now, this is not just a formula. It gives you two more formulae. What are those two formulae? First conclusion. If I take this A on the other side, so I'll have L minus A, and then I'll be left with N minus 1 into D on the right hand side. N minus 1, if I bring in the denominator, then it will become the common difference. So what I'm trying to make you understand here is, whenever I'm given a sequence, let's say I'm given three things. What am I given? I'm given three things. First one is the last term, first term, and the number of terms. And with these three things, I can find the common difference. What I'll do is, either I'll put those values here in this formula, or if not, I will use this calculation intuitively. What is it? I'll take the difference of the last term and the first term. So last term minus first term divided by 1 minus number of terms. If I take this ratio, which ratio I'm talking about, students? Last term minus first term divided by number of terms minus 1. Then this formula will always give me the common difference of the AP. Did you get that part? Well, it gives you one more conclusion, one more important observation, which is, I take this A on the other side. So I'm left with, if I take this A on the other side, then I'm left with L minus A, and here I'm left with N minus 1 times D. Now what I do next is, I take this D in the denominator. So then I'm left with L minus A divided by D. Then on the right hand side, I'm left with N minus 1. That 1 also I bring on the right hand side, left hand side, and on the right hand side, I'm left with N only. This is also a very important conclusion. What does it mean? Let's say in a question, if I'm given the last term, the first term, and the common difference, and I am asked to find the number of terms, what will I do? I'll again take the difference of the last term and the first term. So last term minus first term, and then I'll divide it by common difference. I'll get a value. And to that fixed integral, positive integral value, I'll add 1 to it. That will be the number of terms in that AP I'll be having. So these two formulae look two different formulae, may look like two different formulae, but they basically are derived from this original formula only. So yes, I will emphasize that if you could remember these two formulae also, invest some time in learning them, because they will help you a lot in saving a lot of time in the real examination hall. Any confusions on that? I hope you have gotten a lot of clarity on it, that how have we gotten these two formulae? So this is exactly what I'm saying here, that if you are asked the common difference of an AP, then by using this particular conclusion, that last term minus first term upon number of terms plus 1, you can directly write the common difference of an AP. All of this we are able to deduce with the help of this one single formula only. So, some people say speed is distance upon time. Then you are able to draw two more formulae, which is distance is equal to speed into time, right? And then you have time, which is distance upon speed. So these are the three variants of the same formula, but you are supposed to run all of them so that you can effectively get the answers quickly. That's exactly what I'm saying. You have this one single formula, but if its variants can be seen, then there is a formula for the number of terms. There is a formula for the common difference as well. So remember all the three variants so that you can directly get the results very quickly. Here, if you just remember these two results, you can directly apply the values quickly and get the answers. If you are asked the number of terms or if you are asked the common difference, you can directly get the answers. And that's how you end up saving a lot of time. Now, let us talk about the next thing. What is it? It says if Tn plus 1 and Tn plus 2, these are the three consecutive terms, nth term, n plus 1th term, and n plus 2th term. So these are the three consecutive terms of an AP. Now, if I'm having these three consecutive terms of an AP, do I not know, or can I not say that if I take the consecutive terms difference, if I do this thing, Tn plus 1 minus Tn, this will give me the common difference. Similarly, if I do this thing, Tn plus 2 minus Tn plus 1, this will also give me the common difference, because difference of consecutive terms, difference of another set of consecutive terms, which will be same, which will be the common difference. Now, if I bring this minus Tn plus 1 on the left hand side, and if I take this Tn on the other side, do you not think I'll get this as a result, that 2 times Tn plus 1 will be equal to 2a Tn plus Tn plus 2? What I'm trying to give you is another conclusion which you must memorize, is that if you are given 3 terms in an AP, if you are given 3 terms in an AP, A, B, C, and we are told that these are the 3 consecutive terms of an AP, which are A, B, and C, right? There should have been some space here. So these are the 3 terms A, B, and C, right? And they are in AP. Then you should always remember that double of middle term will be equal to the sum of first and the last term. First and the third term, you may say. And this holds that property, right? First and last term, second and second last term, third and third last term. So their sum remains constant. That's exactly what we are doing here. I hope you can see and notice it very clearly. With that, let us move ahead towards the next conclusion we have drawn. Let us start or keep understanding them. If I were to ask you sum of n terms of an AP, instead of discussing this particular result, what I'm directly giving you is that, let's say if I'm given a sequence or a series where terms are in AP, first term is A, second term is A plus D, third term is A plus 2D, and the last term is L. And if I reverse this entire sequence, so I'm writing L first, then L minus D, L minus 2D, and then A. If I add equation 1 with equation 2, if I add equation 1 with equation 2, what do I get? So S plus S, on the left hand side, I'll get 2S. Now what do I get? First term and last term, A plus L. Second term and second last term, A plus L. Third term and third last term, A plus L. So I am getting A plus L, A plus L, A plus L. How many times? I think n times. So I have gotten A plus L n times. If I have gotten A plus L n times, what did I have on the left hand side? On the left hand side, we have the double of sum of an AP. And on the right hand side, we have A plus L n times getting added, which can be written as n times A plus L. I hope you're getting it. And with that, if I were to write the sum of an AP, it can be written as n by 2 times A plus L, or it can also be written as n times A plus L by 2. Sir, why are you writing it twice? This is the same expression. To some people, it may look like the same expression, but if some of you are paying the attention or noticing, then they will see, yes, there is a difference. The first formula says, although this is the same expression, it will yield the same result, but the first version of this formula of the sum of n terms of an AP says that the number of terms should be halved. So if I'm given number of terms n, I'll do n by 2, and then this number I'll multiply with the sum of first term and the last term. Second version here says, second version, which I have written as s is equal to n times A plus L by 2. So I'll take the arithmetic mean of the first and last term. Now, arithmetic mean is a different concept which we haven't studied so far, but if I were to make you understand, it is simply an average. For you, at this stage, you can treat it as an average. So what I'll do is, I'll take the average of the first and the last term, which I'm now denoting by arithmetic mean. So I'll take the arithmetic mean of the first and the last term, which is A plus L by 2. And that arithmetic mean, I'll multiply with the number of terms, which is n. Through this also, I can get the sum of an AP. Is this enough? No. Can I create one more formula, one more variant, one more version? We know sum of an AP, sum of n terms of an AP is given by S is equal to number of terms divided by 2 times A plus L. What is A? What is L? L is A plus n minus 1D. So if A and L are added, A plus A will give me 2A, and then I'll get another version of this formula of sum of n terms of an AP, which is given by this variant. So remember, this also is the result, which is the formula for sum of n terms of an AP. Are you getting all these results? Are you able to understand all of these conclusions which you are bringing right there in front of you? With that, let us move to the next part where we have already derived this formula, and I'm requesting you all to remember this particular result. And now let us discuss a question through which we'll consolidate whatever we have learned so far. So we have learned what is an AP, different certain simple observations on an AP, then the sum of an AP, and a very simple observation that first and last term, second and second last term, third and third last term, when they are added, give you the same sum, which is the sum of the first and last term. Such simple observations. How do you write the nth term? If an plus b is done, and if it is expressed as tn, then it should be an AP, where a should be the common difference, a plus b will be the first term, and sum of n terms, and the three different variants of it. And how do you find the common difference and the number of terms? That all we have discussed so far. And that learning will try to club here with this particular question. So I'm giving you some time. Look at this question, read it and attempt it first, and then we'll discuss this together. I'm sure most of you must have attempted it. The reason, the algorithm, the mindset should be very simple. You should read it, apply what is given, and then you'll get the answer. Let's begin with the information we are given. So I am told that there is the number of terms in an AP is even. So there are even number of terms. First conclusion. Second, the sum of all the odd terms is 24. Okay, so there are certain odd terms and the sum of them will be 24. The sum of all even terms is 30. So if I add all the even position terms positioned at even places will be 30. And we are also told that the last term exceeds the first by 21 by 2. Okay, that is another clue we have. Then we need to find the number of terms which are integers in this AP. So this AP contains some even number of terms, and there are some integral terms in this AP. Now how many they are, that is what we need to figure out now. Let's begin with the first information we are told. What is the first information? It says there are even number of terms in an AP. So can I say that the number of terms in this AP can be treated that as 2n? Since they are even number of terms, I'm calling them 2n. N is a natural number, right? Now, the sum of all the odd terms. So let's say the first term will be an odd t1, then the next odd term will be t3, such that I'll having odd number of terms. So if the last term is 2n, which is the even position term, then can I have the last odd position term will be t2n minus 1, and sum of all these terms is given as 24. That's our first conclusion. Second conclusion, sum of all the even position terms. So all the even means what? The second term, then we'll be having the fourth term, and so on up till the last term, which will be 2nth term. This sum we are given is as 30. Okay, so these are the two expressions we are aware of. Now what I'll do is, I'll here first of all subtract the first equation from the second equation. What will I get? Can you notice? I'll be having the difference here, t2 minus t1. Then I'll be having the difference t4 minus t3, and so on and so on. So I am writing this particular expression like this. What result, what conclusion I get? Let's write that particular part. So from here, I'll have t2 minus t1. I'm clubbing this difference. Then from t4, I am subtracting t3. So t4 minus t3, and so on. When I keep on subtracting, the last difference will be t2n minus t2n minus 1. And this difference is 30 minus 24, which is 6. Do you all get that? Now, can you help me with what would be the value of t2 minus t1? We have already learned this difference of two consecutive terms of an AP. So t2 minus t1 will be the common difference. So let's say this AP has the common difference as d. So I'm considering or assuming that the common difference is d. So t2 minus t1 will be d. t4 minus t3 will also be d. t2n minus t2n minus 1, that will also be d, because t2 minus t1 d, t4 minus t3 d. So I'm getting a lot of d's. How many d's I'm getting? See, there are total 2n terms. So if out of 2n terms I'm creating pairs, will I not get n number of pairs? If there are 2n terms and if I'm creating pairs, then I'll be getting n terms. So one d from getting here, another d I'm getting from here, another d I'll get from here. So how many d's are they? They are basically n number of d's. So basically d plus d plus d plus d. So this d is getting added n number of times. So shall I not say that here on the left I'm having nd, which is turning out to be 6. That's my first conclusion. I'll keep it with myself. Now, what additionally I know from here is that the last term exceeds the first by 21 by 2. Okay, so I am given one more information that the last term and the first term have their difference 21 by 2. Okay, that's fine. I hope this is exactly what I'm given. Yes. So the difference between last term and first term is 21 by 2. That is what I'm aware of. Now, how do we write the last term? Last term is given by a plus n minus 1 into d, and the first term is a, and this difference is given as 21 by 2. I hope I need not tell you that this a and this a is cancelled, and when this d gets multiplied to this n, it becomes nd minus d is equal to 21 by 2. Now, let's get back to the conclusion we have drawn here. ND we have found as 6. So if I replace the value of ND as 6 here, so 6 minus D is equal to 21 by 2. I take D on the right hand side, 21 by 2 is brought on the left hand side. So what do I get? I'll get D is equal to 6 minus 21 by 2. From here, 6 into 2 is 12. Yes, 6 into 2 is I think 12. I hope we are going great. And then 12 minus 21 by 2. I hope I have not made any mistake here. If I look closely, this was ND, which was found to be 30 minus 24. And then the last term exceeds the first term by 21 by 2. So last term minus first term, right? So a plus n minus 1d minus a, that is 21 by 2. So here I'm having this a and this a getting cancelled. Nd minus d is 21 by 2, right? We are going great. And with that, if I just pay attention to this particular part, 21 by 2 is brought on this side, d goes on the other side. I hope there is no confusion on that. With that, I get d as 6 minus 21 by 2. Any confusions on that? So this is 12 minus 21 by 2, which should not confuse you, because I hope we are doing everything correctly, because t1 plus t3 up to t2n minus 1 is 24. t2 plus t4 up to t2n is 30. So if I take their difference t2 minus t1, why am I saying? Because there is some problem, because I am getting a negative value of d. And if I'm getting a negative value of d, if I put that negative value of d here, I'll be getting a negative value of n, which is not possible. So I think there is some data which is given inconsistently to me. So last term exceeds the first term by 21 by 2. That is also we have written correctly, L minus A. What is L? A plus n minus 1d minus A, which is 21 by 2. So here A gets cancelled by A. We are left with ND minus D, which is 21 by 2. And ND we have evaluated as 6, because 30 minus 24, and this is d n times. So what wrong are we doing here? I am not able to get that part, because 21 by 2 comes here. So 6 into 2 is 12. I think there is something wrong. Let's check that part. So let's look at this particular part and analyze what are we doing here. L minus A. Yes, now I realize. As a part of our practice, I have made a mistake here. See, what you must all have noticed is, sir, the number of terms were not n. The number of terms were 2n. And if the number of terms were 2n, do you not think here, instead of this n, you should have had a 2n? I hope you're realizing the mistake. So yes, such things you subconsciously do, and you focus, you just simply lose your focus and do such errors. So here, instead of n, it should have been 2nd. So if I write it as 2n minus 1d. I hope you're understanding why am I writing 2n, because number of terms are not n, they are 2n. So a plus 2n minus 1d, right? So here also I should have this 2. Some of you must have realized while I wrote this, and if you didn't, I hope most of you must be noticing it now. So a gets cancelled by a, then you're left with 2nd minus d, right? So d goes on the other side. I'll just write this part again. I hope you're understanding this particular mistake here. So d when goes, right, so 2nd, what is nd? Nd we have evaluated as 6. So 6 into 2 becomes 12. So we are now left with 12 minus d is equal to 21 by 2. Now I do this thing. 21 by 2 I bring on the left hand side. I take d on the right hand side. So here I'll get as d as 12 minus 21 by 2, and now I think 12 into 2 is 24. So yes, it will be a positive value. So 24 minus 21 by 2. Why am I saying that d should be positive? Because if d will be positive, n will be positive, and n represents number of terms, and hence that doubt came in my mind, right? So such things you can keep on checking with your solution, whether things are consistent or not, whether values are consistent or not. So while evaluating d, I could think of n, and n was turning out to be negative. That's where I got this idea that my solution could be wrong, and that's how you can check or keep checking whether you're calculating it correctly or not. And such silly error, as a part of our practice, we are used to of writing a plus n minus 1d. But I did not notice that the number of terms are not n, the number of terms are 2n. And that's where you commit such silly errors. I hope you must have realized the mistake. So here, 12 into 2 is 24. 24 minus 21 is 3. So here it should be 3 by 2. So common difference we are able to evaluate as 3 by 2. Now once you have evaluated the common difference, can I talk about the other things as well? Now what are those other things? Let us look at them. Okay, so the next thing which I am going to discuss is, do we know the value of ND? Yes, ND we have evaluated as 6. So if I know the value of ND, which we know as 6, right? So I know the value of ND, which is 6, and we know the value of D, which is 3 by 2. So N into 3 by 2 will give me 6. And from this, I can get the value of N as well. So here, if I simplify this, 3, 2, 6, 2 into 2 is 4. So number of terms are not 4. Again, if you commit that mistake again, N is not the number of terms. Mind you, students, N is that value of N only. Number of terms are 2N. So the number of terms should be 8. First of all, this is what you must realize and understand now at least. Now, if the number of terms are 8, common difference is 3 by 2, can we somehow work out the value of A? If I could crack the value of the first term, I may be able to understand the sequence, and I then will be able to predict the integral terms. So either let's use this or this. Let's use the first part. See, the number of terms are 8. So 4 terms will be at odd positions, and the remaining 4 terms will be at even positions. So if I'm taking the sum of 4 terms, let's say odd position terms. So odd position terms will be T1. I hope you can see it very clearly. So let me write this part here. Let me use this result here. So let's say first term will be T1, then I'll have the third term, then I'll have the fifth term, and then I'll have the seventh term. These are the 4 odd position terms which have the sum as 24. Now, there can be multiple approaches. What I'll always recommend you is that beware here. There is a catch. What is the catch? Either you use the sum of these 4 terms through an AP, but the common difference of that AP will not be D. The common difference of that AP will be 2D, because T1 and T2 have the common difference D. But if you compare here T1 and T3, they have the common difference 2D. So you use the sum of the n terms of an AP Wallah formula where you had this thing, but take care of this thing that the common difference will be 2D. Or what you may do is that you write these 4 terms. 4 terms, very simple, straightforward 4 terms I need to write. I can add them up very quickly. So first term will be, let's say, A. Third term will be A plus 2D. Fifth term will be A plus 4D. Since there are only 4 terms, I'm doing it straight away without bringing any confusion in my mind. And the seventh term will be A plus 6D. This you can do very easily with a lot of ease, because there are only 4 terms. So instead of using the sum of 4 terms formula, I'm using this particular expression. And there you need to take care of it. If you're using the sum of 4 terms, which are first, third, fifth, and seventh, then you should take care of this, that in that sequence, the common difference will be 2D. So such minute details you should be aware of. Rather, to avoid that confusion, I have written these 4 terms, because there are only 4 terms which I can write and add them up very quickly. So here, if I were to calculate, I know that here A plus A plus A plus A, which is 4 times A, and then you have 2D plus 4D, which is 6D, and 6D plus 6D is 12D. So 4A plus 12D is 24. That is what I have received here. If I take 4 common, then I'll be left with A plus 3D is equal to 6. Do I know the value of D? I think we have the value of D. What was D? D was 3 by 2. So if I put a 3 by 2 here, so that is 3 by 2. That is A plus 9 by 2. I hope there is no confusion on it, which is equal to 6. Right. Now, if I take it on the other side, what conclusion do I get? I get the value of A, which is 6 minus 9 by 2. 6 into 2 is 12. 12 minus 9 is again 3. So A also turns out to be 3 by 2. That completes our calculation. Now, even if I were to write those 8 terms, which I don't need to, I can come up with my conclusion that if the first term is 3 by 2, second term will be 3 by 2 plus 3 by 2. See, it is 1.5. 1.5 plus 1.5 will be 3. Then again, if I add 3 by 2, I'll get a fractional term. But again, if I add 3 by 2, then I'll get an integral term. Basically, you're having 1.5. If you don't get this part, you are having 1.5 as the first term. So second term will be 3. The next term will be 4.5. The next term will be 4.5 plus 1.5, which is going to be 6, and so on. So can you not see the pattern? If I'm having 8 terms in my sequence, these even position terms will be the integral terms, and these odd position terms will be the fractional terms. So what were we asked? We were asked how many integral terms are there in this AP. I'll say out of 8 terms, half of the terms, that is the 4 terms, these 4 terms, even position terms will be the integral terms. Did you get that part? There could have been a simpler approach to it, simple observation to it, but I have given you a holistic idea, a broader idea, a comprehensive idea of all what is happening in this question, so that you have this clarity in mind that how do you deal with questions based on AP. And I hope you must have learned this particular silly mistake which I committed, that instead of taking n, here I'm supposed to take 2n because the number of terms is not n, it is 2n. So take care of such silly things. Out of your muscle memory, if you're just prone to write a plus n minus 1 into d and you end up getting the wrong result or wrong answer, then you should take care of such conclusions where you should take care of such minute details as well. Did you get that part? If you have understood this particular part, let us move to the next part of our video where we'll discuss few more things in a greater detailed format. Here, if you have understood sum of n terms of an AP, can I not bring some more conclusions? Now, what are those conclusions? Let's say if I write n natural numbers, 1, 2, 3, 4, 5, 6, 7, 8, 9 up to n, and I ask you the sum of these natural numbers, do you not think that this is an AP? And in this AP, this is the first term and the common difference is also plus 1. So I know the value of A, I know the value of D, I know the number of terms which are n basically. So can I conclude what will be the sum of these n natural numbers? I'll say n by 2, 2a plus n minus 1 into d. That formula when it completes, you get the result as n plus 1 by 2. So remember this as a result. Again, remember this as a result, that sum of first n natural numbers is n plus 1 by 2. You should have this at your fingertips. This is again a very crucial formula which you will keep using throughout your mathematics journey, right? Now, let us move to the next formula which you should have, second corollary of this summation of n terms of an AP, where I am asking you to write the sum of first n odd natural numbers. So sum of first n odd natural numbers, how do we add them up? So first n odd natural numbers, 1, 3, 5, 7, 9, right? This kind of numbers. So first of all, what you need to understand is that here, in this particular case, I'll be having an nth odd number. Here, the first term is still 1, but here, the common difference is plus 2. Can you notice that? So I have the number of terms which is n, I have the first term which is 1, I have the common difference 2. If I put these values into our formula, I'll get the result that sum of first n natural numbers is given by n square. I hope you will have this result with you in your mind and you will remember this also as a result. So sum of first n natural numbers, n plus 1 by 2. Sum of first n odd numbers, n square. Now, let us talk about another corollary, which is sum of first n terms is Sn. And if, let's bring one more thing into picture. Let me take you to one more thing here. Let's say if I were to ask you sum of first n even natural numbers. My question, let's say, is sum of first n even natural numbers. Now, what will be your response? Now, first of all, let's identify the sequence. The series is very simple. First natural number will be 2, then 4, then 6, and then 8, and so on. So here, if I apply the formula, the result remains very simple. What will be the result? Let's have a look at that conclusion here. I hope you can see a lot of things. So I'm sure some of you must have worked on it, that if the first term is 2, second term is 4, the common difference is pretty simple. It is going to be plus 2, right? So how do you write the sum of n terms? It is given by n by 2. So I'm writing the sum of n terms. It is given by n by 2 times 2a. What is 2a? Double of first term. So double of first term is 4 plus n minus 1 into d. What is n? N is n, number of terms, minus 1 into d. What is d? That is 2, common difference, right? If I push this 2 inside, what will I get as a result? I'll be getting this as a result as I am writing this part separately here. So I'm using a separator here. So Sn here is going to be this 2 when pushed inside, n remains outside. This becomes 2, then this 2 becomes 1, and this leaves you with n minus 1. So here 2 minus 1 gives you 1. That gives you the final conclusion, which is n times n plus 1. I will request you all to remember this also as a result when you are asked to add first n even natural numbers. Then their sum is going to be n times n plus 1. First n natural numbers, n plus 1 by 2. So if you are talking about first n even natural numbers, it will be n plus 1. Logically also you must be able to digest it. Now, If this conclusion comes into picture, I'll talk about another conclusion, another important observation which you must notice, that if sum of first n terms is Sn and the sum of next m terms will be, I hope you're realizing the part remains very simple. I'll demonstrate it with an example here. Let me just show it with this particular example here. Let's say I'm having certain number of terms t1, then you're having t2, then you're having t3, up to, let's say, n terms are there, right? And then further some more terms are there. For example, tn plus 1 up to, right, next m number of terms are or more there, which means tm plus n term is also there. Now, if I were to ask you, let's say the requirement says that find the sum of those next m terms. Now, I hope you're realizing, if by some means I could find the sum of these m plus n terms. So if I could find the sum of these m plus n terms, and out of this sum, if I could subtract the sum of these n terms, will I not be left with this sum here? I hope you're realizing. Then I'll be left with sum of next m terms, which is exactly I'm trying to make you understand. I'll make you understand this with this particular part. What is Sm plus n? This particular part, Sm plus n. This particular part is nothing but this whole summation. So from t1 to tm plus n, if I add all these terms, I'll have Sm plus n. I hope you got it. From this, if I could subtract Sn. So if I want to subtract Sn, now what is the meaning of Sn here? Sn means sum of first n terms. So Sn means sum of these first n terms. So I hope you're realizing, if from this entire terms sum, if I'm subtracting this sum which I'm confining in this white box, do you not think I'll now be left with this particular portion which says sum of next m terms? And what are those sum of next m terms? These terms. So out of n terms, if I'm having additionally m terms more further after this nth term, and if I want to take the sum of these next m terms after the nth term, so I'll have the sum of m plus nth term, out of which I'll subtract the sum of n terms so that I could get the sum of next m terms. Are you able to understand this statement? I hope this is very much clear to you all. If even it is confusing you all, I'll take an example to make you understand it more clearly. Let's say there are 7 terms, t1, t2, t3 up till, let's say, t7, right? And let's say after t3, I'm asking you the sum of next 4 terms. So after t3, I'm asking you the sum of next 4 terms. How do you find it out? So my approach will remain very simple. I'll say, sir, let us find the sum of 7 terms first. I hope logically it sounds very simple. And then I'll subtract the sum of first 3 terms then. So out of the sum of first 7 terms, if I could subtract the sum of first 3 terms, will I not have the sum of the next 4 terms? Which next 4 terms, students? Mind you, students, next 4 terms means the 4 terms after the third term, which means t4, t5, t6 and t7. This is that sum. So from t4 to t7, if I were to bring that sum into picture, that sum has its own algorithm, that sum has its own approach, that sum has its own method. That's exactly what I have tried discussing here, which we have given you with this simple fact: Sm plus n minus Sn will give you the sum of next m terms after the nth term. Did you get that part? If we are clear on that, let us move to the next part of our video where we'll discuss few more things. Here comes another very crucial conclusion. What is it? I hope you must have remembered, we had a discussion that, let's say, if I were to describe the nth term of an AP as an plus b. So we can do that. We are allowed to do that because whenever nth term of an AP is given as an plus b, a linear expression in n, then it always gives us the idea that this is going to be a sequence which is an AP, arithmetic progression. The same logic, if I bring here into picture, then we all know that if there is an expression whose nth term is given, then of course we are told that this is an AP. Then if its nth term is given as an plus b, so from nth term, if I could subtract the n minus 1th term, do you not think I'll get the common difference? I hope you are very much clear on it. Along with this, let's say I am given the sum of n terms as well. What is it? We'll discuss or talk about that later, but let's say I am told sum of n terms as well. So I'm given the generalized expression in n, of course, which gives us the idea that this represents sum of n terms. So do you not think if from sum of n terms, if I subtract the sum of n minus 1 terms, I'll get the nth term? I'm trying to tell you a very simple observation that, let's say here, I have t1, then I have t2, then I have t3, up till, let's say, tn minus 1 plus tn. Now from here, if I were to highlight this particular part, what do you understand by this? This box. This box represents sum of n terms. What is sum of n terms? This pink box is representing sum of n terms, right? Now from this box, if I were to subtract this region from t1 to tn minus 1, if I were to subtract this region, what is this region representing? This region is representing sum of n minus 1 terms. So I hope you're realizing from this pink box, if I'm able to subtract this blue box, I'll be left with this nth term. That's exactly what I'm trying to say, that nth term of an AP is always given by sum of n terms minus sum of n minus 1 terms. Do you not think that this is not always true for only an AP? This is true for any sequence. If you are having sum of n terms, and if you are subtracting sum of n minus 1 terms, then you will always get the nth term. This will be true for any sequence or summation. And this plays a very crucial role in a lot of places. You'll understand it while I'll be using the concept of method of differences or AGP, or in a lot of places. Then you'll see this concept being used. So always remember that nth term, if sum of n terms is given, then I'll subtract sum of n minus 1 terms, and nth term of that sequence can very easily be predicted. Did you get that conclusion? Now, let us come back to this part. That's exactly what I was trying to say here. So what I have is here, a very simple conclusion is brought into picture, which I am not asking you to remember or memorize. Simply forget that. All I'm asking you to memorize or remember is two results. Those two results are pretty simple. First conclusion was the common difference will be nth term minus n minus 1th term, as we have already discussed it. And the next thing is nth term can also be written as sum of n terms minus sum of n minus 1 terms. This is not an ordinary result. This is a result which we will use at a lot of places, and I'm emphasizing that you should have this thing in mind. I hope you will remember it. Now, let us get back to the discussion we are having. Now let us explore a few more things. This is the proof which we have already discovered. You need not worry about it. There is another result which you should remember. Now what is that result? Let's have a look at that. Here, a sequence is an AP if and only if the sum of n terms is of the form an square plus bn. Sir, why are you complicating things? Trust me, I'm not complicating things. I am simplifying things. I am giving you a lot of general results with the help of which you can solve a lot of questions in seconds. This is exactly one of those results. How? Let's look at that. This result will actually help you in answering a particular question by looking at that question only, if this concept is learnt in an appropriate manner. So what is this concept? How is it used? And how can you answer questions within seconds? That's exactly what we'll discuss in this particular part of the video. Pay attention to it. I'll come back with my discussion here that so far we have learned that if you are having an expression whose nth term is given by an plus b, a linear expression is in n, then we always say or claim that this sequence is going to be an AP. Yes, that's right. That is what we have already learned. Why are you repeating it again, sir? No, I am taking you to the next level. What is that next level? That next level is if you are having a sequence whose sum of n terms is given by an square plus bn. So I am given a sequence Sn and sum of n terms of this sequence is given by an square plus bn. Then I am telling you with my experience that this sequence whose sum of n terms is given by an square plus bn, this will also represent an AP. How and why, I'll explain that part. Don't worry about it. But did you get this particular reason that this will also be an AP? How? Let's come to that part. See, if I have Sn, let's say this is a sequence. We haven't proved it an AP, but let's try to prove it. So we are given a sequence whose sum of n terms is given by an square plus bn. So if I have sum of n terms, can I have sum of n minus 1 terms? All I need to do is replace n by n minus 1. So if I replace n by n minus 1, I will have sum of n minus 1 terms. So I had sum of n terms, which is an square plus bn. I can have sum of n minus 1 terms, which will be a times n minus 1 whole square plus bn minus 1. Now, pay attention to this part, students. Nth term here will be given by Sn minus 1. We have already discussed. If from sum of n terms, I could subtract sum of n minus 1 terms, I'll be having the nth term. So here, what I'm trying to make you understand is that from Sn, if I subtract Sn minus 1, I'll have Tn, which is worked out as a times 2n minus 1. When you do this entire calculation, you'll come to this particular conclusion. What does it mean? It gives me the idea that I have gotten an expression in a and b where n happens to be the variable which is linear. I repeat my statement. We have already learned that if there is a sequence whose nth term is given as a linear expression in n, then we can say that such expression, such result, such sequence is always going to be an AP. Do you not think that is exactly what we are doing here? That is exactly what is happening here. I am having a sequence whose nth term is given by an expression which is a linear expression in n. And if it happens to be a linear expression in n, do I need to say it further that this is going to be an AP? But now, let's say if I were to find out the common difference and the first term, how will I do it? I hope you know. If I have Tn, can I not work out Tn minus 1? By replacing n by n minus 1, I can have Tn minus 1. And from Tn, if I could subtract Tn minus 1, I will have the common difference, because we know common difference is nth term minus n minus 1th term. So from nth term, if I'm subtracting n minus 1th term, I will now have the common difference. And we already know a and b were constants, so the common difference turns out to be as 2a. So here what I'm trying to make you understand is a very simple, a very straightforward conclusion, that remember it as a result again. The conclusion is very simple, students, that if you are given a sequence whose sum of n terms is given by an square plus bn. Mind you everyone, if sum of n terms is given by an square plus bn, then there are certain conclusions which you can bring under consideration. First of all, you can come up with a conclusion that this sequence is going to be an AP. That is for sure. Don't hesitate in saying that. If sum of n terms of a sequence is given by an square plus bn, always feel free to claim that this is going to be an AP. Second conclusion, if it is an AP, it will have a common difference. So if it is an AP, its common difference will be double of A. So n square must be having a coefficient. You should simply double it. So that double of this coefficient n square, which is A, will be the common difference. What about the first term here? If I were to ask you the first term, this is what? This is common difference. What if I were to ask you the first term? I'm using the conventions. So D is representing the common difference, A is representing the first term. So if I use this thing, that how do we find the first term? So do you not think if I could crack the value of S1, I'm writing this part here, what will be S1, students? S1 will be replace n by 1. So S1 will be A plus B. What is S1, student? S1 is sum of first terms. So sum of first term is T1, which is S1. And what is T1? First term. So first term is A. So what is A? A is turning out to be A plus B. Will you remember these two results, students? That we have gotten two results. Which two results we have received so far? First result we have received is that, just give me a second, I need to turn this AC on. Yes, first result was a very simple conclusion that the common difference is going to be double of A, and the first term is going to be A plus B. From this conclusion, that if you are given a sequence whose sum of n terms is given by an square plus bn, so it will be an AP, and these two conclusions can be drawn. Trust me, this is going to play a very crucial role in your sequence and series particular chapter. How? Let's say I give you an example where I say that sum of n terms is given by 3n square minus 2. 3n square minus 2n. I'm really sorry. So if it is 3n square minus 2n, what can you say? Sir, if it is 3n square minus 2n category kind of an expression, then yes, it is going to be an AP. So first conclusion, it is going to be an AP. Sir, what about its common difference? Don't hesitate in saying, sir, double the coefficient of n square. So double of the coefficient of n square, 3 doubled, when double gives you 6. So the common difference is going to be 6. Sir, what about the first term? Just add the coefficients of n square and n, which is 3 and minus 2. When you add them up, you get the first term, which is going to be 1. And I hope if you have A and D, you can say anything about this AP. You can find out anything related to this AP. A lot is already given, a lot you have already figured out. So I hope you have this conclusion. I am constantly repeating this. This is something which is going to be used at a lot of places. So remember this as a result. Remember this as a result. This will help you a lot at a lot of places. Through observation only, you can conclude a lot of things. Did you get that part? Let me move to the next part where we come to another conclusion. This is a little trickier. Just read the language first and then come to the conclusion. This says, if you are given Sn as an square plus bn. Sir, so far we have discussed if an square plus bn is given as sum of n terms, we can claim that this is an AP. What if it is given as a quadratic in n, a proper quadratic in n, an square plus bn plus c? What does it represent? Please understand, here if Sn denotes the sum of n terms of a series, then the whole series is not an AP, but it is an AP from the second term onwards. Are you able to understand what I'm saying here? Let's say, I hope you are able to digest this particular conclusion. I'm not proving it again. You can prove it by yourself. Sn is given. You can find Tn, Sn minus 1. From Tn, you can find D, Tn minus 1. And from D, you can find A as well. But here, there is a catch. What is that problem which students don't notice? That here, if this kind of an expression is given, which is S, which gives you an square, I'm really sorry, an square plus bn plus c. So what will I do? I'll put value of n as 1, I'll get s1, then s2, then s3. From s2, if I subtract s1, I'll get t2 basically. So this is how I'll keep evaluating things. But the problem here is, if you write the sequence here, t1, t2, t3, if you write all these terms, t1, t2, t3, see, if I put the values of n here, I'll not be getting t1, t2, t3, I'll be getting s1, s2, s3. And through s1, s2, s3, I can get the values of t1, t2, t3. The catch here is, if I start writing that sequence, the values here, t1, t2, t3, from S, I hope I can write all this entire sequence. So what you must understand and realize here is that this sequence will of course be an AP, but from the second term onward, which means first term will not fall into this AP. So you should take care of this thing, that you should remove this first term or simply discard this first term, and from the second term onward, this expression is going to give you an AP. I hope you will remember this also as a result. Now, let us proceed ahead and learn some more important conclusions or results. This is the proof which we are not discussing as of now. There are certain questions which are formed on this concept as well. JEE loves this formula. They actually use this concept. Now, if you learn these results, you can directly use them in your questions. What are these results? How are they proved? That is more important. What is more important is what are these results? How do you use them instead of their entire proof? Although I'll show you that how are they turning up. Now, let's begin with the first conclusion. Let's begin with the first result. First result says, if the ratio of sum of m and n terms of an AP is given. So forget this. Let's not learn this particular formula. Let's simply remove this. Rather, I'll make you solve a problem through which actually you can get more clarity on it. So there are two formulae which I wanted to discuss, but you are already dealing with a lot of formulae in physics and chemistry. And if maths at this stage becomes an additional burden, then I don't want it to happen. So here, let us take an example through which let us understand the algorithm, the method basically, so that you can learn how to solve such questions instead of learning these formulae. Because learning them, memorizing them, the way they are written verbatim will be really difficult. It is not just one formula, then there is another formula. So instead of asking you to memorize them, let us understand this particular concept with an example. What is it? Let's look at this particular part. It says that if you are given sum of n terms of two different APs. So first of all, you need to understand that there are two different APs and I take the sum of their n terms. So from the first AP, I take the sum of those n terms, and from the second AP also, I take the sum of those n terms. What is common in this case? The number of terms, which are n in both the cases. In the first AP also, the sum of n terms is same. I mean, the sum of terms are n. In the second AP also, the sum of terms is n. The sum is not same, the number of terms is same, which is n. But they are two different APs. And sum of n terms of those two APs, that ratio is what we are given. And what are we asked? We are asked the ratio of their nth terms. How can we find that out? Now, there is an algorithm, there is a standard formula as well, which I don't want to remember. I want you to memorize. Let's learn the approach, the method through which you can find out the answer. How do we do that? Let us focus on that. First of all, please help me with this. Can you find Sn in a better manner? Sir, if it was an AP, if in this question we are told that this is an AP, Sn and Sn dash, this is the sum of n terms of two different APs. Now, if I'm told that these are two APs, if I am asked the sum of n terms, I know it should be of the form an square plus bn. I hope you are getting this. You are able to recall this. We have already discussed this part. So if I bring that discussion into picture here, I am trying to make you understand something really simple, really easy, really straightforward, which is, let's say I'm given Sn as this, Sn dash as this. Can I write Sn as this 3n minus 13 times k? Because this is a ratio. So if I multiply it by some k or a lambda, I'll get their actual values. Similarly, what about Sn dash, students? Sn dash is going to be 5n plus 21 into k. I hope there is no problem on that. Now, sir, Sn looks good, great rather, but had there been n square and n, something like an square plus bn, I would have been more happy. Okay, if you want more happiness, how can we stop you from having that? So let's have that n. Mathematics give you that liberty. How? Let's say if I multiply this numerator and this denominator, which I was not given in the question, by n, then it does not get affected because this is a ratio. So instead of taking Sn and Sn dash like this, can I have n getting multiplied in the numerator and in the denominator? Why? Because of that, I'll be having Sn and Sn dash in the form of an square plus bn. And through that, I can bring a lot of conclusions. I hope you're getting this particular logic. So here, if I talk about this part where I'm trying to say this very simple thing, that Sn upon Sn dash, we are given something. And if I multiply both the sides, numerator and the denominator, by n, I'll have 3n square minus 13n in the numerator. And I will have 5n square plus 21n in the denominator. Okay, that's fine. Now can I have Sn and Sn dash in terms of k? Of course, because this is a ratio first of all. So if you are thinking, if somebody is thinking or believing that Sn will be 3n square minus 13n and Sn dash will be 5n square plus 21n, then you're wrong. I hope you're realizing what is the mistake here. So what you need to understand is that this is a ratio. So these are not the values of Sn and Sn dash. If you're thinking like that, then you're committing a mistake. So here you need to understand Sn will be a multiple of this and Sn dash will be a multiple of this. I hope you're getting this part clearly. Now let us forget all of this. Let us go to the part where we have discussed, if I'm given Sn, what conclusions can I draw? So if I'm given Sn as an square plus b, then we know that the common difference and the nth term of that AP are given by, common difference is given by, I hope you remember, we have already discussed this part here. I have already shown you the proof here. I hope you must have remembered it. This particular part, this is exactly what I'll be using here. So if I'm given Sn as an square plus bn, the common difference is given by 2a. The first term is given by a plus b. Not just that, the nth term is also given by a times 2n minus 1 plus b. Now that's another conclusion which I would want you all to remember from here. Even if you don't remember it, even if you forget it, what you need to understand is you have the first term, you have the common difference. Can you not find out the nth term? Not even that. If you have the nth terms sum of n terms, you can work out the sum of n minus 1 terms. So sum of n terms minus sum of n minus 1 terms will give you the nth term. That's exactly what I'm trying to make you understand here. I hope these are some simple observations through which you can crack the nth term. So if I use this result, a times 2n minus 1 plus b here, I repeat, where is the question? Here is it. So the conclusion we have brought here is that if I have Sn as given as an square plus bn, then we can always write the nth term as a times 2n minus 1 plus b. Sir, if we forget this, then derive it. You have it. You know it, right? So here, if I have Sn as Sn upon Sn dash as this, can I not write Sn as 3n square minus 13n into k? I hope that doesn't bother you all. Similarly, if I now wish to write Sn dash, will I not write that as 5n square plus 21n times k, right? I hope you have this now. So you have Sn 3kn square minus 13kn. You have Sn dash 5kn square plus 21kn. Now with that, can I not write their tn and tn dash respectively? We all can. So if I wish to write the value of tn and tn dash, I hope I am very much free and allowed to do that. How? Let's have a look at that part. So I'm using a separator here. Now I'll be writing tn and tn dash. How? Let's work on that. How will I write tn? I hope I have the result. I know the values of a and b. Now I can use that. So here for Sn, from Sn, if I wish to write tn, what would that be? That will be a times 2n minus 1. What is a? A is 3. That k is going to be there, so I'll keep it outside only. So a is 3. So it should be 3 times 2n minus 1. That is a times 2n minus 1 plus b. What is b here? B is minus 13, student. So that is b, which is minus 13. And this is going to be multiplied by k, because that k was also there, which was there with each of the terms. So I can keep it outside like this, rather than keeping it with all the terms, so that the confusion stays out. Now, how do I write tn dash? So tn dash is also going to be a very simple task. See, if I am having Sn dash like this, an square plus bn, can I write tn dash? It will be a times whole of 2n minus 1 plus b. So what is a here? A is 5k. So I'll write 5k, which I'm writing as this only 5, because k I'm keeping outside. So a times 2n minus 1 plus b. What is b? B is 21 here. So what is b here? B is 21 here. I hope there is no confusion on that. Any confusion so far, students? Now, when we proceed further, that also should be multiplied by k, because k was there with each of these terms, which I did not write with each of these terms, which I wrote separately as a common entity. I have tn, I have tn dash. Now, what were we asked? We were asked the ratio of tn and tn dash. Can I not find that? All I need to do is take this ratio. This ratio here is going to be the value of tn is to tn dash. That's exactly what I'm trying to say here. That if you know certain basics, if you know certain concepts, especially like these ones, you can directly get the answers. Even if you forget the formula, that from Sn or Sn dash, you can find tn or tn dash, or the ratio rather, I would say. If you're given the ratio of Sn is to Sn dash, and if you're asked to find the ratio of tn is to tn dash, you can use this direct approach. Instead of learning this particular formula, or rather even this particular formula. No, don't do that. I will rather say that use this particular result. So from here, if I'm asked, if I'm given Sn is to Sn dash in this manner, and if I'm asked the ratio of tn is to tn dash, it will be this. Even if I'm asked to simplify this, I'll write it as, okay, so let me write it in the next step. So here I'll be having tn is to tn dash, and what would that be? I hope we have the conclusion. This entire expression upon this expression, I hope I can see that this k and this k will get cancelled. That's exactly what was the motive of k. So even without putting k, you could have gotten the answer, but that would have been mathematically wrong. Some people may have raised questions on it that you cannot do it. So yes, but ultimately that k is bound to get cancelled, because we are again going to get that ratio only. So that's where that k is getting cancelled. So that does not make our problem confusing or complex. So here I take this upon this, which is 3 times 2n minus 1 minus 13. So here in the numerator, we have 3 times 2n minus 1 minus 13, I believe. Yes. And in the denominator, what do we have? What are we dealing with? In the denominator, we are dealing with 5 times 2n minus 1 plus 21. So this is 5 times 2n minus 1 plus, what was it? Plus 21. Okay, so that is. Now, even if you were to simplify this, you can get the final simplified result. What will that be? That final result will be 3 into 2, that is 6. So this should be 6n minus 3 minus 13, I think should be minus 16. I hope there is no confusion on that. So I repeat, 3 into 2, 6n, minus 3 minus 13 should be minus 16. Here, 5 into 2, that is 10n. And then you have this, which is minus 5 plus 21. What is minus 5 plus 21? So 21 minus 5 is again going to be plus 16, I believe. So this should be plus 16. I hope there is no confusion on that. I repeat my part. 5 into 2, that is 10n minus 5. So 21 minus 5 should be 16, right? Now, this is what we have gotten. Even if you want to take something common, you can, which I think is going to be nothing more than 2. So if I take 2 common, that 2 will get cancelled from the numerator and the denominator. Then in the numerator, I'll be left with 3n minus 8. And in the denominator, I'll be left with 5n plus 18. Sorry, 5, 8 plus 8. Yes. So this will be the ratio of their respective nth terms. So in this particular case, I hope you have gotten a lot of clarity. I was given 2 APs and some of their nth terms, that ratio was given, and I was asked the ratio of their nth terms. Sum was given, the ratio of sums was given, and the ratio of their nth term was asked. So by using this particular property, this particular result, which we have been discussing constantly on AP, can be utilized here. And through this, you can get the answer by using these simple concepts or learnings or methods. That's exactly what this formula suggests, which I don't want you to learn. If you have understood the approach we have discussed so far. Now, let us proceed ahead. There is another method. There is the vice versa approach as well. Let's say I'm given the ratio of n terms. If I'm given the ratio of n terms, so 2 APs are given and the ratio of nth terms is given. So first AP's nth term is given by, let's say, an plus b. Second AP's nth term is given by, let's say, cn plus d. This is what we have learnt already. So what if we are asked the sum of n terms is to sum of nth terms? So sum of nth terms of the first AP is to sum of n terms of the second AP. Then you have this formula. Again, I don't ask you to use this. Just understand the process, just understand the method, you will get the answer. You will have the answer. The answer remains very simple. Use the method we have discussed previously. You know how to write the sum of n terms. You know how to write the nth term. So sum of n terms of an AP is always given by an square plus bn. Nth term of an AP is always generalized as an plus b, although that a and b, which we have discussed in SN and TN, will be different. But I'm just giving you the idea. And from that, you can draw all these conclusions which are brought right there in front of you. There are some more concepts such as properties of arithmetic progression. Now, this is the part on which JEE loves asking questions. So they ask you questions, a lot of questions, and they merge concepts of AP. So these properties, one after another, we'll discuss, and they use these properties into the questions and ask questions on it. So AP is the topic which plays amazingly huge or a crucial role in your this sequence and series chapter, then summation of series, and then GP. These are the 3 most prominent topics which you should have clarity upon. Although there is some really important topics such as arithmetic AM, GM property, or some more basic details such as HM or VN method or something like that. But this all comes under summation of series as well. So now let's talk about properties of an AP. So the first property is pretty simple. If you pay attention to it, it says that there are certain terms in an AP, right? A1, A2, A3 up till AN. What is we are additionally told is that if I add or subtract a fixed number, so you are given an AP, and to all the terms of that AP, you add a fixed number or you subtract a fixed number from all those terms. Then also it will remain an AP with the same common difference D. So let's say you're given an AP, and you are adding a fixed number to all the terms of that AP. In that case also, it will remain an AP. And in that AP, the common difference will still remain that D only, which was the common difference of the previous AP. I hope you're understanding it why. Now, let's talk about the next part, the second part. The second part is again a very crucial part. It says that if again we are dealing with an AP, and if I multiply all the terms of an AP or divide all the terms of that AP by a fixed number, let's say k for a while. Then also it will remain in AP, but this time the common difference will get also multiplied or divided by that particular number respectively. What I'm trying to make you understand is that if you are given an AP and all the terms of that AP are getting multiplied by a number, let's say k should be a non-zero number here in this case. So now the newly formed sequence will also be an AP, and the common difference of that AP will be k into d. Now I can either multiply by k or divide it by k. All I need to ensure is that this k should not be 0. The next part. If I have two APs, A1, A2, A3 up till AN, and another AP B1, B2, B3 up till BN. Now what I do next is, of course, let's assume that their common differences are D1 and D2 respectively. So first AP has its common difference D1, second AP has its common difference D2. Now the property says if I add the terms respectively, for example, A1 with B1, A2 with B2, A3B with B3, and if a new sequence is formed, trust me, in that case also, it will still remain an AP. Not just when you add, but also when you subtract. So A1 minus B1, A2 minus B2, A3 minus B3 till AN minus BN. So if I'm subtracting also the consecutive terms, the corresponding terms, I'm really sorry. In that case also, the sequence will be an AP. And what is more interesting here? The more interesting part here is that common difference will also be either the sum or the difference of those common differences of the previous two APs. So if I'm adding the corresponding terms, the common difference will be D1 plus D2. If I'm subtracting the corresponding terms, the common difference will be D1 minus D2. So I hope these properties are making complete sense. Let us understand few more properties here. Let's say I am given again two APs, and this time I'm either multiplying them or dividing them. For example, I'm having this A1, B1, A2, B2, A3, B3, or A1 upon B1, A2 upon B2, A3 upon B3. In that case, please understand, this will not form an AP. Please understand this. In that case, when you multiply or divide two APs, then an AP is not formed. Please understand this and please remember this. Now, another conclusion is very simple. If you choose a term, and from that term, if you take equidistant terms from the left hand side and from the right hand side, and then you take their average, then their average is always the term which you have chosen. If you didn't understand this part, I'll explain it with an example. For example, let's say there is an AP which has the terms A1, A2, A3, A4, A5, A6, A7, let's say. So these are the 7 terms of an AP. Mind you everyone, we are limiting our instruction to arithmetic progression only so far. We are not discussing anything else, right? Now, when you talk about this property, this particular property, this property says that, let's say if you choose any term, let's say I have chosen a term A4. So this is what I have chosen. Now let's say I go forward and backward, a certain step ahead and a certain step back, and then I observe those two terms. Let's say I move 2 steps ahead. So A5 and A6 I skip and I choose A7. Similarly, I go 2 steps back. So I have skipped A3 and A2 and I choose A1. So if you were to take the average of A1 and A7, if you were to take the average of A1 and A7, well, that average is going to be this A4 only. I repeat, A1 and A7 will have the average as A4 only. Not just that, had you chosen, let's say had you chosen A2 and A6. See, A2 and A6 are equidistant from A4 because A6 is 2 steps away on the right hand side and A2 is 2 steps away on the left hand side. So even if you take the if you take the average of A2 and A6, then also it will give you the same term A4. On the basis of this, can you help me that what will be the average of A3 and A5? So I hope you're realizing the funda remains very simple. A3 and A5, all you need to calculate is the index. See, 1 plus 7, 8 divided by 2 is 4. 2 plus 6, 8 divided by 2 is 4. I hope you're realizing it. Similarly, can I not say 3 plus 5, 8 divided by 2 is again going to be 4. So I hope you'll remember this particular funda where we are saying that equidistant terms play a very crucial role in this symmetry or in this pattern when you're dealing with an AP. Similarly, if I talk about the next property says that if three numbers in an AP are to be chosen, always remember that there is this area which is the error prone area where students commit a lot of mistakes. Please remember this. Let's say if I were to choose three terms of an AP. Now, three terms of an AP can be chosen like this: A minus D, A, or A plus D as well. Of course, you have this liberty. Sir, can I not choose it like this? A plus D, and then A plus 2D. Can I not choose three terms in an AP like this? You are definitely and always allowed to. And I personally will advise that you should choose in this manner only. I'll tell you why. But of course, people suggest that three terms of an AP can be taken in this manner as well. They think or believe that this eases their calculation. This may ease their calculation, but this gives them some confusions, or this actually creates an error prone area where when you take this, the calculation remains as equal, as same, as efficient as this part only. But in that part, your chances of committing certain errors are less. Now, what are those errors? I'll talk about that. When you choose three terms, let's say in a question, I'm required to select three terms of an AP. So I can choose three terms of an AP and AP as A plus D, A plus 2D. Or rather, I could have chosen them as A minus D, A and A plus D. So let's say I have chosen them in this manner, A minus D, A and A plus D. Then you should always remember, here in this case, the first term is not A. The first term is A minus D. Usually students find A and then they say that A is their first term and they think that they have found the first term, and that's the problem they commit. Usually we are used to of thinking it in this manner that A should be our first term always. But if you have assumed it like this, where you have A minus D, A and A plus D as the three terms of this AP, then A minus D will be the first term of your sequence. Did you get that part? I hope you can very clearly see that D will be the common difference. So if three terms are to be chosen, you can choose them as A plus D, A plus 2D, which is what I'm recommending you. But if you choose it like this, then in that case, always remember A won't be the first term, A will be the middle term, A minus D will be the first term, and D will be the common difference. Now, let's say if I'm asked to choose four terms, well, in that case, you can choose it like A minus 3D, A minus D, A plus D, and A plus 3D. Sir, can I not choose it like A plus D, A plus 2D, A plus 3D? You are always allowed to. And this is exactly what I personally will always recommend and suggest. But if you are planning to go ahead with this, you're definitely allowed to do this, that if let's say four terms are to be chosen in an AP, they can be chosen like A minus 3D, A minus D, A plus D, and A plus 3D. But again, there is a catch. The catch is that here, the first term is not A, the first term is A minus 3D. The second part, here, mind you everyone, previously when three terms were considered, the common difference was D. In this case, the common difference isn't D, but the common difference is 2D. I hope you all can notice it very clearly. Some people believe or think that considering four terms of an AP in this manner may ease their calculation, may actually make them more efficient, but it is not. The amount of the calculation, the time which the calculation will consume in either way will be same. Trust me, have faith in my words. So either you choose this method or the other method, you can have the same amount of calculation. But yes, in this particular method, you need to change your basics then. What are the basics? The basic which we usually assume that A should be the first term. Here in this case, A minus 3D will be the first term. And what about the common difference? The common difference usually we take as D, but in this particular case, the common difference will be 2D. So these nuances you should be aware of if you're taking three terms or four terms in this particular manner of an AP. Now, if this part is understood by you all, I think let us proceed further. What do we have next in front of us? Let's have a look at that part. The next property is same if four numbers are to be taken and that generalization is given, which you need not bother about. So far, I think we had a good discussion on AP. let us move to the part where we'll discuss GP, the geometric progression. I hope there is no confusion on arithmetic progression. Whatever we have discussed so far, you have gotten a good clarity on AP. Now let's talk about GP, geometric progression. So we all know, we all understand that if I were to deal with the GP, previously in AP, we had a term, we kept on adding a fixed number and we kept on getting another term. And that's how we created a sequence which we called an AP. But when it comes to defining a GP, what do you have? So you again have a first term A, but this time instead of adding, you multiply. So let's say I multiply A with a number, let's call that number R. So I'll have another number AR. Then again I multiply AR by R, so I'll get another number AR square. Then again I multiply AR square by R, I get another number which is AR cube, and that's how I keep on forming certain numbers. Now, again, what you need to understand is that GP is that third most important topic which you need to understand, which you need to by heart, which you need to memorize. A lot of concept, a lot of formula are there, which with practice you will learn, of course, don't worry about that. But understand it with great clarity, because I have been constantly mentioning that this is one of those easy chapters where you can learn the concepts very easily and apply them and get the answers. So questions are also asked from this chapter. Standard, decent, simple, straightforward questions are asked. But of course, JEE knows it, that whenever a chapter is simple, they ask you a little moderate question. And whenever the chapter is tough, they ask you easy and moderate questions. What students think is that if this chapter is easy, let us master it and crack the question. Well, JEE is always one step ahead of you. So if you are thinking that some chapters are easy and you can master them easily, they will form some good category of questions from those easy chapters. And if you think that this is a heavyweight chapter, which takes a lot to understand, for example, complex numbers or something like that, in that case, they already know that this chapter is tough for students, then they might form easy, simple questions for you. So always study all the chapters. All the chapters are equally important, because you don't know, questions can be asked, easy questions can be asked from a tough chapter, or tough questions can be asked from an easy chapter. So study all the chapters. Study all the chapters. Everything is equally important. Now, let us get back to our discussion. I am trying to make you understand that if I observe the terms of this GP, what will I have? I'll begin with this first term. We are calling this term as the first term, so let's call it T1. What happened with the second term? We had AR. What happened with the third term? We had AR square. So I think I can generalize it. So what I'm noticing here is that if it is the third term, R had the power 2. Now if this is the fourth term, R had power 3, which is 4 minus 1. So if there is this power n minus 1, it is helping me in understanding that this must be the nth term. So nth term of a GP is given by AR to the power n minus 1. The way in an AP we used to have A plus n minus 1 times whole of D as the nth term of an AP. Similarly, nth term of a GP is given by this. I hope there is no confusion on it. Previously we were adding, this time we are multiplying. So the concept remains same. To get the next term, we multiply the previous term by the common ratio, because here this R is called, the number with which I'm multiplying is called the common ratio. Previously, it was common difference in terms of AP, when in the context of AP. This time this is the common ratio. Similarly, here we'll have the first term and so on. So we'll develop the formula for this sequence also. But first of all, let us get clarity on what is GP and what all is there as far as GP is considered. So first of all, I'll begin with this very simple observation where I say that if there is a GP, then you cannot have the first term or the common ratio to be 0. Because if the first term is 0, now with whichever number you multiply it with, you will always you'll always keep getting a 0. So 0, 0, 0, 0 can be called a sequence, but it cannot be said a GP, because in this GP, R could be anything. So R goes undefined, R goes not defined. So if the first term is 0, you cannot have it as a GP. Rather, in a GP, a term can never be a 0, because if a term is 0, that means its previous term and its next term should also be 0. I hope you're getting my language why. Similarly, the common ratio can also never be 0, because if the common ratio is 0, all the terms will become 0, and it will again take me towards the conclusion where all the terms are becoming 0. So in a GP, no term is 0. neither the first term nor the common ratio, none of the terms is 0. Now, if there is a GP and terms are alternatively positive and negative, so we have already understood in an AP, terms are never alternatively positive or negative, but in an GP, if there is a possibility that in a GP there are terms which are alternatively positive, negative, positive, negative, positive, negative, then you can always conclude that the common ratio must have been negative. Did you get my point, students? I'll explain it with a very simple example here. Let's say we are given a number 2, right? And the common ratio is -2. So 2 into -2 will give me -4. But -4 into -2 will give me +8. 8 into -2 will give me -16, but -16 into -2 will give me +32. Are you noticing the terms are alternatively positive and negative? Plus, minus, plus, minus, plus. Why is it happening? Because I hope you all must have noticed, because the common ratio was -2. Did you all get that part? Some simple observations are there, but through these simple observations, you can generate a lot of conclusions. Similarly, there is another observation which you must be aware of. What is the next observation here, students? That if we multiply the common ratio with any term of GP, we get the next term. This is something which is very well understood by you all. The common ratio of GP may be positive, negative, or imaginary. So yes, the way we used to have imaginary or complex arithmetic progression, similarly, we can have complex geometric progression as well. So the common ratio can be positive, negative, or imaginary, but it cannot be 0, as we have already discussed. Now, the next conclusion is the common ratio of a GP is equal to unity, then GP is known as constant GP. As we have discussed, if there is an AP and if the common difference is 0, it will be a constant AP. Similarly, in a GP, if the common ratio is 1, then I can call that if 1 is getting multiplied to each term, I'll not see any change in any term at all. Well, that will help me in understanding that this is a constant GP. So if the common difference is 0, constant AP. If the common ratio is 1, constant GP. Did you get that part? Now, proceeding ahead, what do we have next? What do we see next? Let us focus on that. As we have already discussed, if A is the first term, R is the common ratio, AR square, AR to the power n minus 1, this is how you keep on writing the terms. If I were to talk about the last term let's say is L. So if I divide L by R, I'll get the second last term. If I divide L by R, which means L by R square, that will be the second last term. One more observation I wish to highlight here, that in an AP, we were adding first and last term. We were adding second and second last term, third and third last term. Similarly, in a GP, if I multiply first and the last term, what will be the product? If I multiply A with AL, I think I'll get AL. If I multiply second and second last term, what is the second term, students? Second term is AR, second last term is L by R. Can you see R will get cancelled by R and I'll be left with AL. Can you now notice that if I multiply third term with the third last term, so AR square times L by R square, again R square gets cancelled by R square and I'm again left with A into L. So that phenomena, which was true for addition in an AP, will be true for product in a GP. The same logic. Always remember this as a result. This will help you a lot in solving a lot of questions. Now, let us move ahead with the next property. This is what we can generalize: nth term from the beginning, nth term from the ending. All I'm asking you to remember is this particular result, that whenever you're given or asked nth term of a GP, you always write it as A times R to the power n minus 1. This is how you can generalize the nth term from the end, which you need not worry about. This is also, we have discussed that if there is a n terms of a GP, then product of the kth term from the beginning and kth term from the end is independent of k, and it is always equal to the product of the first term and the last term, as we have just discussed in the previous slide. I hope there is no confusion on this particular part and we can move ahead. Now there comes a formula where you derive how to find the sum of n terms. Previously we have found the sum of n terms of an AP. What was it? N by 2 times whole of A plus L. Do you remember that? Similarly, there is a formula to find the sum of n terms of a GP. What is that formula? This is the entire derivation which I'm skipping in this one shot. I'm directly coming up with the conclusion that sum of n terms of a GP is given by Sn is equal to a times 1 minus r to the power n upon 1 minus r. Or if I take negative sign common from the numerator and denominator, then I'll have another variant of this formula, which is Sn is equal to a times r to the power n minus 1 upon r minus 1. Usually what students do is that if you have common ratio to be, basically when you have this common ratio to be less than 1, you can take this one, and if you have common ratio greater than 1, you can this formula. It doesn't matter, minus sign can be taken common from the numerator and the denominator, and both of these formulae remain same. I will always emphasize that you learn either of the formula and apply it, you will always get the same answer. They are not two distinct formulae, you need not learn them, they are same. So let's learn this one, where I say that sum of n terms of a GP is given by a times whole of r to the power n minus 1 upon r minus 1. Can you help me with these terms? What is a here? A we all know is the first term. What is n here? The number of terms which you are adding of a GP. What is r here? The common ratio. That exactly what you are having in the denominator. I hope it was easy, simple and understandable. So that's exactly what we have done in this particular case. I hope there is no confusion on this particular part. Whenever you are asked to find sum of n terms of a GP, it is always a times whole of r to the power n minus 1 upon r minus 1. I hope you will remember it. Now, let us proceed ahead towards another conclusion. Let's say I am given an infinite GP. Now, what does infinite GP means? First of all, what you need to understand is that this is an infinite GP which is converging. Now, what is the meaning of getting converged? Let's say the first term is 2. Common ratio is 1 by 2. So 2 into 1 by 2 will be 1. 1 into 1 by 2, 1 by 2. 1 by 2 into 1 by 2, 1 by 4. 1 by 4 into 1 by 2, 1 by 8. 1 by 8 into 1 by 2, 1 by 16, and so on. If you look at the pattern, if you look at the number 2, 1, 0.5, 0.25, 0.125, and so on, the numbers are constantly getting decreased. So it is like the number was 2 and then it became 1, then it became more smaller, and gradually your numbers kept on decreasing, and they kept on vanishing. They became so smaller that by using the concept of limits, I can find the sum of an infinite GP. So if you are able to find the sum of infinite GP, what you need to understand is that this can be done only when the common ratio is between -1 and 1. I repeat my statement. If there is a GP given to us and if its common ratio is between -1 and 1, then only we'll have the GP getting converged. Then only we'll have this GP diminishing. Then only we'll have the terms of GP vanishing or tending towards 0, becoming very small. So if it is a converging GP which has its terms getting smaller and smaller and smaller and almost negligible by the time you're increasing towards the higher number of terms, then in that particular case, the sum of an infinite GP can be found. I repeat, you cannot find the sum of infinite terms of a GP. You cannot always find. But what you can do is, if the common ratio lies between -1 and 1, in that case, you can find the sum of an infinite GP. I hope that part is concluded, understood by you all. So by using the concept of limits, we all know that this is what we know as the sum of n terms of a GP. Now, if I put n approaches infinity, this is the concept of limits, which we'll discuss when we'll understand the chapter limits, continuity, and differentiability. But as of now, if I use this concept that if n is approaching infinity, r being a very small number because r lies between -1 and 1, so r to the power n will vanish. So I'll be left with r becoming 0. I'll be left with a into 1 upon 1 minus r. So that is what we get as a formula, that sum of infinite terms of a GP is given by a upon 1 minus r. What is a here? A is again the first term. What is r here? The common ratio. So if there is a GP which is an infinite GP whose terms are vanishing, it is a converging GP. Or rather, in a very simple language, if it a GP which has the common ratio between -1 and 1, if there is a GP which has the common ratio between -1 and 1, in that case, you can find the sum of such GP. And sum of infinite terms of this kind of GP is given by a upon 1 minus r. Always remember that. Now, Let us go ahead, let us proceed further, let us find out the next set of properties or rules, or rather, let us solve a question asked by JEE Mains in 2025. What does the question say? Let's look at it. It says the sum of second, fourth and sixth term of a GP of positive terms is 21. So there is a GP and this GP contains positive terms. Okay. And I am told that the sum of its second, fourth and sixth term is 21. What else? The sum of its 8th, 10th and 12th term is 515309. Okay, I'll use that result. And then I am asked sum of its first 9 terms by JEE Mains in 2025. A decent question, just to make you understand the different concepts of a GP. How do we apply it? Let's have a look at that. See, I'll begin with this particular conclusion that what I know sum of second, fourth and sixth term. So can I write second, fourth and sixth term, students? I hope we can write the second term will be AR cube. Sorry, I'm really sorry, I took the fourth term. Second term will be AR because AR to the power 2 minus 1. Fourth term will be AR cube, which I wrote mistakenly here. And then sixth term will be AR to the power 5, 6 minus 1. I hope you are able to digest this part. And this sum is given as 21. Okay, so that's our first part. Second part says the sum of the 8th term. Can I write the 8th term? 8th term will be AR to the power 7. 10th term will be AR to the power 9 plus the 12th term. The 12th term will be AR to the power 11. Well, this is given as 15309. Okay. In short, can I not say that I'm given two equations in two variables? Can I solve them and find A and R so that I could possibly find the answer? Okay, let's try and do that. But before I begin solving this, let us look at this particular portion intuitively so that I can create something interesting here. For a while, let's say I take r to the power 6 common from this equation, the second equation. Why am I saying this? Because if I take r to the power 6 common, r to the power 6 when taken common, r to the power 7 minus 6 will leave me with r to the power 1. R to the power 9 minus 6 will leave me with r cube. R to the power 11 minus 6 will leave me with r to the power 5. So I think there is something very interesting happening over here if you take r to the power 6 common. So let's say I have taken r to the power 6 common. So when you take r to the power 6 common, what are you left with? I am left with AR here. From here, I am left with AR cube. And from here, I am left with AR, what is happening? AR to the power 5, right, is equal to 15309. Any confusions on that? I hope this part is very clearly understandable. Now, what is it? AR cube, AR to the power 5. AR cube, AR to the power 5 is 21. So can I substitute this part by 21? So what will I get? I'll get 21 times r to the power 6 is equal to 15309. Did you all get that part, students? I hope there is no confusion on it. Now, if I divide the both sides by 21, so I think the data they give you usually in AP, GP or HP is solvable. So even without checking, this number will be divisible by 21. And if you don't know the table of 21, let's begin with 7 because I think 21 is divisible by 7 and 3. So this number will also be divisible by 7 and 3. So let us divide it by 7 first. So if I divide it by 7, I'll be left with 3 here. And if I divide it by 7, I think 7 when doubled gives you 14. Remainder is 1. Then 13. So you divide it by 7 into 1, which is 7. 13 minus 7 is 6. Then 7 into 8 is 56. 7 into 8 is 56. This was 60. 60 minus 56 leaves you with 4. This gives you 49. So 7 into 7 is 49. I hope you must have seen it very clearly. Now, 2187 when divided by 3 gives you or leaves you with 3. 7 times 21. Then 3 2 times is 6. Remainder is again 2. So 3, 9 times is 27. I hope you have gotten it. So we got r to the power 6 as 729. Okay. So we have gotten a result as r to the power 6 as 729. I hope there is no confusion on it. Now, we all know 729 is the cube of 9, or we can write it as 3 to the power 6. So r to the power 6 is 3 to the power 6. From here, I can write as r square whole cube as 3 square whole cube. From here we can conclude that r square is equal to 3 square, and from here we can conclude that r will be plus minus 3. But there is a catch. What is the catch here, students? If you read the question properly, you must have read that this is a GP of positive terms. So this was a GP of positive terms. If this was a GP of positive terms, can I say its common ratio cannot be negative? Because we have understood and learnt that if the common ratio is negative, the terms are alternatively positive and negative. Do you remember that? And if it is a GP of all the positive terms, in that case, r needs to be positive. So r being minus 3 can be discarded. So yes, now I'm left with the one value of r, which is 3. So we have concluded the value of r. We have found the value of r. Once you have found the value of r, by putting that value here in this particular equation, can I crack the value of a? So ar means 3a plus, next is ar cube. 3 cube is 27, so this should be 27a. Then the next part is ar to the power 5. 3 to the power 5 is 243. You should learn these results. So 243a. So from here, I'll get 243a, which we are given as 21. Okay. So this is what we are given as 21. Now, if I add this up, so 243 plus 7 is 250. 250 plus 20 is 270, and that is 273. So this is 273a, which is 21. So a should be, I hope I need not tell you this, 21 when divides 27 gives you 1, remainder is 6. 63 is triple of 21. So a turns out to be 1 by 13. Now, you know a, you know r. What is a? The value of a is 1 by 13. What is r? R we have already evaluated is 3. What are we asked? In the question we are asked the sum of its first 9 terms. Okay, so sum of its first 9 terms. Can you help me with the sum of its first 9 terms, students? If I were to ask you sum of its first 9 terms, you will say a into r to the power 9 minus 1 divided by r minus 1. What was a? Here in this case, we know that a was 1 by 13. And what was r? R was 3. Now this part I leave up to you. This was a very simple question where they made it longer with the help of calculation. Because here now what you'll do, you will put the value of a, which is 1 by 13. You will put the value of r, which is 3. And then you need to do a little bit of calculation. So with that calculation, you will get the answer, which I leave up to you that you should do it by yourself. So a little bit of calculation is left, which I'm very sure you can do and get the answer. But the challenging part, the conceptual part, that how should you approach questions based on geometric progression, its sum, its n terms or whatever, how should you deal with that? That I hope is very well understood by you all. Let us look at the next part where we'll discuss the different properties of a GP, right? How do we deal with that? Let us look at that particular part. The first property is pretty simple. If you notice it, it again gives you the idea the way we have learned the properties of AP. What does it say? If A1, A2, A3 are in GP, so there are terms in GP, okay? Now, with common ratio R, and if I multiply all the terms by a certain fixed value, let's say K, so A1K, A2K, A3K, or even if I divide it by K, A1 upon K, A2 upon K, A3 upon K, then also it remains in a GP with the same common ratio R. I hope you're realizing why, because R is going to be that value through which you can keep getting the next terms. So I repeat, if there is a GP and if you multiply all of its terms by a fixed number, by a fixed value, then this new sequence formed will also be a GP with the same common ratio which was of the previous GP, original GP. Did you get that part? Let's move to the next property. It says, if there are terms in GP with common ratio, and if I add or subtract a fixed number to all the terms, then it will not form a GP. So remember this, if I'm adding or subtracting a fixed number to all these terms, then it will not form a GP. Always remember this. Talk about next. If there are certain terms in GP, again with the same common ratio R, then their reciprocals will also form a GP with the common ratio 1 by R. So if I have A1, A2, A3, R in a GP where R is the common ratio, so 1 upon A1, 1 upon A2, 1 upon A3, they will also form a GP, and this time the common ratio will be 1 upon R. Did you get that part? Now, If I raise all the terms to a certain power, let's say n. So a1 to the power n, b1 to the a2 to the power n, a3 to the power n, up till an to the power n. Let's say I square them or I cube them or I take the square root of all of them. So if I'm doing or if I'm raising all these terms to a certain power, in that case also, the terms will form a GP, and here the common ratio will become r to the power n. I hope you are understanding it very clearly. Now, here what you need to understand is that this power should be a rational number. It should not be an irrational number. You cannot say that sir power is under root 3. Then under root 3 in a power cannot have its significance here in that case. You should have a rational power here. Understand that. Now let's talk about the next part. This is a very crucial property. JEE loves it and they ask questions on it. This one. On this particular property, they ask you questions. So learn it, remember it, by heart and memorize it. What is the property? If you have log a, log a1, log a2, log a3 up till log an, these are the terms which are in AP. Let's say these are the terms which are in AP. In that case, this I think is not written properly. I think I should write it more properly. I think this is incorrect. I'll begin with this part that if you have A1, A2, A3 are in GP, I'll begin with the initial part first. I directly wrote the or came up with the conclusion here. The first part is that you have A1, A2, A3. These are the terms which are in GP with the common ratio R. And if I take logarithm of these terms of a GP, so log of A1, log of A2, log of A3. So if I'm taking logarithm of all of these terms, well, in that case, that GP A1, A2, A3, when logarithm is taken of all those terms, now newly formed sequence will be an AP. The converse is also true. What is the converse? If you are given certain terms in logarithm and if you take their anti-logs, so I am given log A1, log A2, log A3, log An, these are the terms in logarithm. These are the terms in AP. And if I take their anti-logs, so log A1, I'll basically take these values here. Instead of calling them the anti-logs, I'll take these A1, A2, A3. So these values here, whose logs I was taking, log A1, log A2, log A3. So this A1, A2, A3 will be in GP, will be in a GP. So I hope this conclusion remains with you. I'll help you in understanding this particular part with an example, because this is something important which you should understand, which you must memorize, which you should have with you. So what is the concept? What is the learning? It has two parts. The converse is also true. Let me begin with the first part. The first part was, let's say there are terms and these are the terms which are in a GP. So let's say the first term is A, second term is AR, third term is AR square, and so on. And if I'm taking logarithm of all these terms, so let's say first term becomes ln A when I take the logarithm, then the second term becomes ln A R, which can be written as ln A plus ln R log mn. Now, the third term will become ln AR square and so on, right? So what I'm trying to make you understand is that if this sequence was in a GP, and if I take logarithm of all the terms of this GP, then this newly formed sequence will be an AP. Did you get that part? Not just that, there is one more conclusion which you need to understand, that if you are given an AP in this particular format, let's say if you are given an AP, for example, somewhat like this only. Let's say I'm given an AP. I'm told that this is an AP. This is what I'm given, let's say. What am I given? That there is an AP which has terms, let's say ln A1, then the next term is ln A2, then the next term is ln A3, and so on. So I'm given that there is an AP, log of A1, log of A2, log of A3, and so on. And if I take these terms A1, A2, A3, whose logs we were taking, I'm not saying anti-log, mind you everyone, that was a mistake. So if I'm taking A1, A2, A3, if I take these values here, so if I take these values A1, A2, A3, and so on, and if I ask you something about them, then without hesitation, you should be able to deduce that if log A1, log A2, log A3, they were in an AP, then A1, A2, A3 will form a GP without any confusion. You should be able to state that. I hope both of the properties are understood by you. Remember this as a result. They ask questions based on this particular property. Now, let us move ahead. Let us proceed further. What do we have next? let's say I am given two different GPs. The way we were having two different APs and we were dealing with properties based on them. Similarly, let's say I have two GPs. What are these two GPs? A1, A2, A3 up till AN, B1, B2, B3 up till BN. So these are the two GPs I'm dealing with. Now what's next? The next is they have their common ratios, let's say R1 and R2 respectively. Now, if I am multiplying the corresponding terms of those two GPs, so A1, B1, A2, B2, A3, B3, and so on, then in that case, this will still remain a GP with the common ratio R1 into R2. Not just that, but even if you are dividing the corresponding terms, for example, A1 upon A2, A1 upon B1, A2 upon B2, A3 upon B3, like that. So if you are dividing the corresponding terms, in that case also, it remains a GP, and that GP will have the common ratio as R1 upon R2. I hope you are learning it from the perspective of the GPs, the way we have learned properties on AP. In the same fashion, we are learning certain properties on GP. And this one we have already discussed, that if you are adding or subtracting corresponding terms of two GPs, then it will not form a GP. That is something which you should understand and remember by yourself. I hope you will remember it. Now, proceeding ahead, what do we have next? Let us learn some more properties. This is again what we have already discussed. Now I'll explain it in the context of GP. Previously, what we learned was that if I choose a term, and if I choose equidistant terms from that term in an AP, equidistant means on the left hand side, on the right hand side, then their average remains same. Average here I'll call arithmetic mean. Now, similarly, there is a term which is called geometric mean. What do I mean by that? Please understand, let's say I choose certain terms. What do I mean by that? Let's say I have a GP, A1, A2, A3, A4, A5, A6, up till, let's say, let me write some more terms so that I can demonstrate it to you and you understand it properly. So these are, let's say, 9 terms of a GP. So these are 9 terms of a GP. All right, students. Now, what I'm trying to make you understand is, as we have already learned, that the product of first and last term will be same, second and second last term will be same, third and third last term will be same. Similarly, there is one more property based on this property only. What is that property? Let us learn that. Let's say that I choose a term A5. I have chosen a term A5. I have randomly chosen a term. You could have chosen any term. So let's take a term A5. Now, let's say I am moving 2 steps ahead of A5 and 2 steps back or reverse of A5. So if I go forward and backward, what will I say? That let's say I'm skipping 2 terms from A5 in the forward and backward manner. So if I skip these 2 terms, I'll get A8 if I skip these 2 terms, and similarly on the backward side, if I skip these 2 terms, I'll get A2. Now, what does the property say? The property says a very important formula that here, this one I hope you already know. First term, last term, second and second last term, third and third last term, they'll have their product same. The next property which I'm trying to make you understand here is a very crucial result, that here, if you take the product of A2 and A8, if you take the product of A2 and A8, and if you take the square root here, it will be A5. But here, the prerequisite is that this should be a GP. Previously in an AP, what did we see? That their average, A2 plus A8 divided by 2 will be A5. But here, if it is a GP, the square root of product of A2 and A8 will be A5. How do I remember it? 2 plus 8, 10, half, 5. What does it mean? Let's say if I'm choosing A9 on the right hand side. So if I'm choosing A9 on the right hand side. So I've skipped 3 steps forward. Let us skip 3 steps backward. So 1, 2, 3. I'll have A1 from the left hand side. So that case, I'll give me that even if you take A1 and A9 also, if you take their product and then they take the square root of that product, that will again give you A5. On the basis of it, can you not say, sir, in that case, can I not say that A3 and A7 will also give me the same result when such operation is performed? I hope you are learning it very clearly that, sir, even A4 and A6 will also give me the same result. So in that case, I will say that the product of A4 and A6, when square root is taken of that product, will give me A5 only. So are you understanding this particular property? It is true for a GP only. I'm not saying this is true for any random sequence. In the context of GP only, this will be true. Another very crucial property, questions are asked on it. Even if questions are not directly asked, there are concepts, there are questions where you can apply this particular concept and get the answers quickly. So this is the advantage of learning these nuances. Now, let's talk about the next part. Let's say I'm asked to assume 3 or 4 terms of a GP. Before I talk about that, let me talk about one more conclusion. There is a term which is called geometric mean, which we'll discuss, of course, later. But as of now, let me just give you a glimpse of it. Let's say I'm given that 3 terms are in a GP. So I'm told that A, B, C are in a GP. So if A, B, C are in a GP, we have already understood that A square, B square, C square will also be in a GP. A cube, B cube, C cube will be in a GP. That we already know by understanding the properties of a GP. Now, what I'm trying to make you understand here is that this 3 terms are in a GP. What does it mean? We know that if I divide B by A, I'll have the common ratio because the next term upon previous term. So B upon A will give me the common ratio. Can I say that same common ratio can be attained by dividing C by B? Because C upon B will also give me the same common ratio. Now, if I multiply these B and this A and C, will I get another very crucial result? Yes, I will. So from here, I can say that B square is equal to AC. Always remember this as a result. Another very crucial result, that vice versa. If A, B, C are in GP, then we will say that B square is equal to AC. Or if B square is equal to AC, I'll say that ABC are in GP. Always remember that. Will you? I hope this conclusion is very well understood by you all. So remember it. If 3 terms are in GP, the square of the middle term will be equal to the product of the other 2 extreme terms. Or if this is true, that the product of 2 terms is equal to the square of another third term, then this term, and this term will be in a GP. Did you get that part? I hope it makes complete sense. Now let me get back to the part where I'll be explaining you one more concept. I hope this part is very well understood by you all. Here, let's say I'm asked to assume 3 terms of a GP. The way we were asked to assume 3 terms of an AP, so it can be assumed as A minus D, A and A plus D, or A plus D, A plus 2D. Whatever you wish to do, you will get the answers. Always get the answer. Don't worry about that. Similarly, let's say in a question, the need arises and the need says that you need to assume 3 terms of a GP. So again, I will personally advise that if 3 terms of a GP are to be assumed, you should go ahead with A, AR and AR square. Because when you take them in this manner, there is no confusion on first term and the common ratio. Why? Because it is following our convention. The convention says first term is A and the common ratios are. Trust me, you will get the answers with the same amount of efforts if you use what is prescribed by others. What is prescribed here in this case, that books say that if you are asked to take or assume 3 terms of a GP, you should assume them as A upon R, A and AR. This is also a very fine result, which looks a more effective result, which it is simply not. It is equally efficient as what you could have done with the previous result. But here in this particular case, if I am taking 3 terms of a GP in this manner, AR, A upon R, A and AR, well, in that case, what you need to understand is that here the common ratio is clearly R. If I'm multiplying any term by R, I'm getting the next term. But what you need to understand very clearly here in this case is that A is not your first term. Your first term is A upon R. So again, students commit this mistake that somehow they find A by assuming terms in this manner and they say that A is the first term and they mark the answer incorrectly in a rush. And that's a problem. So muscle memory makes us do that. Don't do that. Avoid it. And to avoid it, I will always recommend assume them as A, AR and AR square. However, if you do it like this is what you should follow or abide by or stick to. Another crucial result which students must remember is that if I asked in a question to assume 4 terms of a GP, I'll personally choose them as A, AR, AR square and AR cube. But let's say if you are willing to choose them as a by r cube, then let's say a by r, then let's say AR, and then AR cube. Then this is also how you could have chosen 4 terms of a GP. In this particular case, what you need to understand is that here I am clearly seeing that the common ratio is r square. Because when this term is multiplied by r square, this is attained. When you multiply this term by r square, the next term is attained. And when you multiply this term by r square, the next term is attained. So first of all, in this case, if you are thinking or believing that r will be the common ratio, no, that is false. The common ratio is r square. Second conclusion, the first term is not a, the first term was a upon r cube. I hope you will remember this as a result. Now, let us talk more on this particular part in this topic where we will explore some more things related to a GP. This is exactly what we are given. You can take them like this. Now, let us talk about an HP, a harmonic progression. Questions are there waiting for you. We'll club these concepts together and then we'll discuss questions based on different concepts. But here, let us focus on HP. Trust me, you need not put any additional efforts on understanding an HP. Because if you know the AP, you can solve questions based on an HP. What do I mean by that? I'm trying to make you a very simple result that if you are given an HP. So HP is nothing but simply take the reciprocals of all the terms which you are given an HP, it will become an AP. I am trying to make you understand a very simple result, which is HP is nothing special. If you take terms of an AP and if you take their individual reciprocals, then the sequence now formed will be called an HP harmonic progression. So for harmonic progression, I will never ask you to remember any new formula. Rather, always convert the HP into an AP, think like an AP, and then come up with the answer. But there are some catches which you should take care of. But before we talk about those catches, let us understand what is an HP through more clarity. For example, if I have a sequence which is an AP, which has terms T1, T2, T3 and Tn. And if I take their reciprocals, for example, 1 upon T1, 1 upon T2, 1 upon T3 and 1 upon Tn. In that case, I will say 1 upon T1, 1 upon T2, 1 upon T3 will be an HP or vice versa. If this is what I'm given to be in HP, that means the reciprocals will be in AP. I hope you're understanding both are same. What I am trying to make you understand is a very simple result here. See, if I were to tell you that find the reciprocal of these terms. So 1 by 2, 1 by 5, 1 by 8. The reciprocals will be 2, 5, 8. 2 plus 3, 5, 5 plus 3, 8, 8 plus 3, 11. That's exactly what I'm saying. So if there was an AP which had terms as 2, 5, 8, 11 and so on, and if I take their individual reciprocals, which is 1 by 2, 1 by 5, 1 by 8, then I got an HP. Now, what if somebody asks you the nth term of this HP? Can you not find it? Sir, I will not find the nth term of this HP. Rather, first what I'll do is I'll take their reciprocals. So their reciprocals will be 2, 5, 8 and so on. So now if I've converted this HP into an AP, I will deal with its first term and common ratio because this is an AP now. And I can find the nth term of this AP. And after finding the nth term of that AP, I will take the reciprocal of the nth term, which is nothing but the nth term of the HP. So all I'm asking you to understand is that don't treat HP as a new concept. Rather, understand that HP is basically an extension of AP, or rather reciprocal of AP. Do you get my part? What is the problem here? The problem is that students commit an error. If I were to ask you the sum of n terms of an HP, which questions will never, then don't commit this mistake that you find the sum of an AP, sum of n terms of an AP, and then you take the reciprocal of it. I'll just try and make you understand with a very simple illustration. You'll get complete clarity on it. If there is an HP 1 by 2, then let's say 1 by 4, then let's say 1 by 6, then let's say 1 by 8, and so on. So this is an HP. Why am I calling it to be an HP? Because it's reciprocal. 2, 4, 6, 8, and so on are in AP. So let's say I'm asking you the sum of first 10 terms of this HP. Then don't do this, that you convert it into an AP. You find the sum of those 10 terms of that AP, and then you do the reciprocal of that sum. I hope that will be mathematically wrong. So when it comes to finding the sum of certain terms of an HP, you are supposed to individually or manually add them up. There is no formula for that. Although there won't be a question on it, but this is the catch which you should remember or learn or understand, that you cannot blindly convert the HP into AP and apply all the formulae just like that. You should have your own logic, you should have your own intelligence before doing anything. So I hope you're understanding. I hope you're understanding it very clearly. You cannot do this. You cannot say that, sir, 2 plus 4 plus 6 plus 8, I'll do all this up till 10 terms, and then I'll take its reciprocal, and then that reciprocal will be equal to sum of this. No, that is mathematically wrong. I hope you're understanding. This is not what you can do. So that's exactly what I'm saying, that not all the formulae of AP can be directly used in HP by after taking the reciprocal. But yes, when it comes to finding the nth term, we can do that. I hope there is no confusion on that front, that part. Let us move ahead. Let us understand some more nuances related to HP. First learning which you all must have understood is that HP cannot have any term as 0. Why, sir? Because if any term of an HP is 0, which means its reciprocal will be infinity, which means there must have been AP which must have had a term infinity. No, that's not possible. So if infinity is not possible in an AP, then how can 0 be possible in an HP? Did you get my part? Next conclusion. I hope you're understanding A plus D, A plus 2D, they form an AP. So in the same fashion, if I take their reciprocals, it will form an HP. So finding the nth term is not a tough task. I hope you're realizing why. Because if I'm given an HP, I'll take the reciprocals of each term and then I can find the AP. And with that AP, I can find the nth term and then I'll again take the reciprocal, which will give me the nth term of the HP. That's what I'm constantly repeating. I hope you're getting this result very clearly. Now, nth term from the beginning. So nth term of that AP and you take the reciprocal of it. How simple it is. I hope there is nothing new here. Now comes a very crucial concept which is called arithmetic mean. Then we'll discuss geometric mean and then we'll discuss harmonic mean. And there is an inequality based on these means on which questions are asked. Although questions on AM, GM and HM are asked, but more possibility is that you may be asked questions on inequality based on AM, GM, HM. What you need to understand is that those inequality based questions can be done only once you have understood what is AM, GM and HM. So before understanding that particular very crucial topic or concept, AM greater than equal to GM, which is the inequality on which a lot of questions on maxima minima can be done without using calculus, let us first of all understand what is AM, what is GM and what is HM. There are certain confusions as well regarding HM, which I'll clarify later in the part where we'll be discussing HM. But let us now first of all begin with AM, arithmetic mean. This has its own variations and meanings. Let us learn each of them one after another. I'll begin with the first part. Let's say I am given 3 terms in an AP. Let's say I am given 3 terms in an AP. Let's say those 3 terms of that AP, are A, B, C. So we always say that the middle term B is called the arithmetic mean of the other 2 terms A and C. That's what I'm saying. Or if I say that B is the arithmetic mean of A and C, then I'll say that A, B, C are in AP. Did you get my part? My part is very simple, that if A, B, C are in AP, then B is called the arithmetic mean of A and C, and vice versa. If B is said to be the arithmetic mean of A and C, then A, B, C are in AP. And how do we find the arithmetic mean of A and C? A plus C by 2. Just the way you find the average. I hope arithmetic mean is not a very heavy or a huge concept, but it is in a different sense. What is that different sense? Let us start exploring it. Let's say I am given n number of terms. I am given n observations, A1, A2, A3. Now they can be in AP, they cannot be in an AP, whatever they are. Let's say I'm given certain numbers, certain observations. So I'm given some numbers and I'm asked to find their arithmetic mean. So arithmetic mean in a general sense is basically an average. So let's say I'm given certain numbers. They necessarily are not to be in an AP. They are just some random n numbers. So I'm given A1, A2, A3 up till An. these are n numbers, and if I'm asked to find their arithmetic mean, it means you need to find their average. So a1 plus a2 plus a3 up till an divided by n will give me the arithmetic mean of these n observations. Did you get that part, students? It has nothing to do with a1, a2, a3, an being in an AP. That's what I'm saying. So if you are given, let's say, 5 observations, 1, 3, 5, 7, 9, and if you are asked the arithmetic mean of 1, 3, 5, 7, and 9. Now, in this case, luckily, 1, 3, 5, 7, and 9 are in an AP. But even if they are not in an AP, then also their arithmetic mean can be found, and that by taking the average of these 5 numbers. That's what I'm saying. So arithmetic mean of terms in an AP or of terms not in an AP can be found. The same is true for GP, HP as well, or GM or HM as well. But as of now, I'm trying to make you understand that arithmetic mean is simply average, which means if I'm given certain terms which necessarily are not in an AP, and if I'm asked their arithmetic mean, then what I'll do is I'll take the sum of all the observations, all those numbers, and I'll divide that by number of observations, and by doing so, I'll be finding the arithmetic mean of those numbers. Did you get that part? Now, if I'm given 2 numbers, then their arithmetic mean is given by a plus b by 2. For example, let's say these are 3 numbers, 3 random numbers, 2a, 3b, and 5c. So these are 3 random numbers, 2a, 3b, and 5c. And if I'm taking their arithmetic mean, it will be nothing but 2a plus 3b plus 5c divided by 3. What you need to understand is that it is not necessary that 2a, 3b, and 5c are in an AP. I hope you are getting this particular part. Now, let us move ahead. Let's say I give you certain observations and I tell you that insert arithmetic means between these observations. What do I mean by that? I'll explain it with an example so that you get more clarity on it. Let's say there is an AP, right? So there is an AP which has terms like 3, then let's say 3 plus, let's say any observation. Let's say what I do is 5, then you have 7, then you have 9, then you have 11, right? So these are the 5 observations, right? And I remove these 3 observations. So these 3 observations I remove and I call them arithmetic means. So I am saying that insert 3 arithmetic means between them. Between what? Between 3 and 11. So what does it mean? First of all, you need to understand this particular part. It means that there are these 5 terms. How did I get these 5 terms? Because I am asked to insert 3 arithmetic means between 3 and 11. So when you are asked to insert 3 arithmetic means between 3 and 11, it means 3 arithmetic mean number 1, arithmetic mean 2, arithmetic mean number 3 and 11, they should form an AP. So these 5 terms should now be in an AP. So if I'm asked to insert certain number of arithmetic means between 2 numbers, then including those 2 numbers, those AMs, those arithmetic means should form an AP like this in this manner. So what I know here is, I know a very basic observation here, sir, that 11 is my 5th term of this AP. So if 11 is the 5th term of this AP, what do I know? Can I not say that 11 is the 5th term of this AP? So 11 can be written as A, which is 3, plus 5th term, so 5 minus 1 into D. I hope you remember this. Tn is given by A plus n minus 1 into D, nth term of an AP. Now, by using this result, can I find the common difference? We already know how to find the common difference. A short formula also we have learned, but you might have gotten confused. That's why I have written this particular part, but I hope you know how to do it. So we already have learned this formula, that common difference of an AP is given by last term minus first term. So that is 11 minus 3. So that is 11 minus 3 divided by number of terms minus 1. So the number of terms are 1, 2, 3, 4, 5. This is the 5th term. So 5 minus 1. What do I get from here? 11 minus 3 is clearly nothing but 8. 5 minus 1 is 4 and 8 by 4 is 2. So the common difference is 2. Do you not think once you have found the common difference, you can very easily crack the terms? Because 3 plus 2 will give me 5, which is the first AM. This is your first AM, students. 5 plus 2 will be 7. That's your second AM, mind you, students. And 7 plus 2 is 9. That's your third AM. And we all know 9 plus 2 is 11, which is what we were given. So yes, between 3 and 11, I am able to insert 3 arithmetic means, which are 5, 7, and 9. That's exactly what this theory also suggests, which I don't want to learn, which I don't want you to learn. I want you to understand this process, this approach, that let's say I'm given two numbers, and between those two numbers, I'm asked to insert certain arithmetic means. So what is the meaning of this arithmetic means? So insertion of certain arithmetic means one means is arithmetic means, another means is meaning means. So here, I want to insert three arithmetic means between 3 and 11. It means these 5 elements, 3 arithmetic means, and these 2 elements, 3 and 11, these 5 elements should form an AP. Did you get that part, students? I hope there is no confusion on that. So I hope this part makes complete sense. How did I find the common difference? By using a simple logic, and by adding that common difference to the previous terms, I could get the next terms. And by having this, I could finally deduce what are these 3 arithmetic means going to be. Did you understand that part? Now, if this portion is understood by you all, there is one more conclusion. Rather, there are 2 more conclusions. The sum of n arithmetic means between 2 given quantities is equal to n times the arithmetic mean between them. I directly am going to tell you what does it mean. Let's say there are 2 observations. Let's say A and B. Okay. And let's say I have inserted n arithmetic means between them. What does it mean? Let's say first arithmetic mean is AM1, second arithmetic mean is AM2, and so on up till I insert the nth arithmetic mean, which is AMN. So let's say the way in the previous example, we have taken two numbers between which we had inserted 3 arithmetic means. Similarly, let's say I'm given 2 numbers A and B. And between A and B, I'm inserting an arithmetic means AM1, AM2, AM3, AM4 up till AMN. Now, what do you understand by this? By this, you must have this thing in mind that yes, sir, now we are able to deduce that A, AM1, AM2 till AMN dot comma B, all these numbers must be forming an AP. Are you able to digest this part? Now, if this is forming an AP, what you know here is that sum of n AMs. So this property says sum of these AMs, so AM1, AM2 up till this nth AM, sum of these n AMs is equal to n times the arithmetic mean between them. So arithmetic mean of A and B, I hope you already know. What is the arithmetic mean of A and B? 2 numbers. So arithmetic mean of A and B will be A plus B by 2. That's what I'm trying to say here. How can you prove it? You have the result right there in front of you. Because you know, if it is an AP, what you know here is that sum of first and last term, sum of second and second last, third and third last, fourth and fourth last will be same. And by having that property, you can very easily conclude that sum of all these arithmetic means will be equal to n times arithmetic mean of these 2 terms A and B. Did you get that part? Now, similarly, there is one more property. And remember this as well. Sum of m arithmetic means between any 2 numbers is to the sum of n arithmetic means between them is going to be m is to n. Why? Because if I'm adding m arithmetic means, then it will be m times A plus B by 2. If I'm adding n arithmetic means, it will be n times A plus B by 2. And if I'm taking the ratio of sum of m arithmetic means is to n arithmetic means, then both of those sums will have A plus B by 2 common. So that will get cancelled, and then I'll be left with m is to n. If you didn't get that part, I'll explain this part also. Don't worry about it. So let's say between A and B, there are 2 questions. Let's say in first question, I'm inserting m arithmetic means. And in the second question, I'm inserting n arithmetic means. So what will be the sum of those m arithmetic means? That will be A1, A2 up till let's say AM. So I'm denoting arithmetic means by A1, A2, AM, right? So these are the m arithmetic means. Similarly, what if I insert n arithmetic means? Let's denote those n arithmetic means as A1 dash, A2 dash up till AN dash, between the 2 same numbers A and B. So I hope you know that in this particular case, first case, I am inserting m arithmetic means. What does it mean? This sum will be m times A plus B by 2. But when I'm inserting n number of arithmetic means between the same 2 numbers A and B, well, that sum will be n times a plus b by 2, and that's exactly what I'm trying to say here, that this a plus b by 2, this a plus b by 2 is getting cancelled by a plus b by 2, and then the ratio you're left with is m is to n. That's exactly what they're trying to convey here. Did you get these two corollaries? Did you understand these two properties? They are some very crucial properties, are used in questions. I'll ask you to take the screenshot of this part and keep it with you as a cheat sheet so that you remember this particular portion. Now, let us focus on geometric mean. So after AIM, we'll talk about GM, then HM, then we'll solve certain questions based on them. Now, geometric mean is also same as arithmetic mean. So it has its own variants, it has its own meanings. First of all, we have already learned that if I'm given three terms, let's say A, B, C, and if I'm told that these three terms are forming a GP, if these three terms are forming a GP, in that case, what you should always understand is that the square of the middle term, is equal to the product of the first and the last term. Or rather, what you can also say is that the middle term is the square root of the product of first and last term. Or you can say that the middle term is the second root of the product of first and last term. So if this is so, then this will happen. And if this is so, this will happen. What I'm saying is that whenever you are able to interpret or comprehend or conclude or deduce that B is equal to A into C to the power 1 by 2, then you can say that A, B, C are in a GP. Vice versa. If A, B, C are in GP, then you can say that B will be equal to square root over A into C. Did you get that part? Now, geometric mean has its own meanings, it has its own applications. The first meaning, the first application is again, let's say I have certain number of observations. Now, please understand, these observations are not necessarily to be in a GP. They are some random general n observations. Observations means numbers. So I'm given some numbers. They can be just some random numbers. Let's say I'm given 5 numbers. And I'm asked to find the geometric mean of these 5 numbers. So I'm given 5 numbers. Let's say they are just random some 5 numbers. For example, 2, then I'm given 4, then I'm given, let's say 7, then I'm given 5, then I'm given, let's say 11. So these are 5 numbers. And if somebody asks me to find the geometric mean of these 5 numbers, what will I do? I'll take their product first. So the geometric mean of these 5 numbers will be their product n. How many numbers did I multiply here? 5. So take their fifth root. So raise it to the power 1 by 5. This is the geometric mean of 2, 4, 7, 5, 11. Here I'm trying to make you understand that it was not necessarily true that 2, 4, 5, 7, 11 to be in GP. They are some random 5 numbers, and if I'm asked to take their geometric mean, I'll take their product and raise them to the power 1 by 5. I'll take their fifth root, the product's fifth root. In AM, we were taking the average of those 5 numbers. In GM, we'll take the product and then we'll raise it to their 1 by 5th power. Basically, fifth root is what we'll take of their product. That is the meaning of GM. First meaning. Now, let me get back to the discussion we were having. Second discussion. If we are given A and B as 2 numbers, this is what we have already discussed. Now, if I'm given that A and B are 2 numbers and G is the geometric mean between them. So this geometric mean G is given by square root of AB. And A, comma, capital G, comma, B will be a GP, a geometric progression. Always. This will always be true. Here, what you need to understand is that this A and this B should be positive. Let me tell you this particular part through this particular example, if we have it. Yes. So let's say I am asked to find out the geometric mean of 4 and 9. So I'll say geometric mean of 4 and 9 will be 4 into 9. Square root of 4 into 9 is 36, square root of 36, which is 6. Let's say I'm asked to find out the geometric mean of -4 and -9. Then there is a catch. Geometric mean of -4 and -9 is not 6. Some of you might say, please first of all understand, some of you might say, sir, that the geometric mean of -4 and -4 and -9 will be what? -4 into -9, which is -36, and sorry, plus 36, and square root of plus 36 is 6. But no, that's not true. If both of the numbers were negative, in that case, let me just make a correction here. Just give me a second, students. Here, there is a small correction. Just give me a second, everyone. I'll write it here. G should be equal to negative of this. Why am I saying this? Why am I saying that the geometric mean of -4 and -9 should be -6? I'll explain it with a very simple observation which most of you must have made. See, if I'm saying that the geometric mean of -4 and -9 is -6, which means -4, -6 and -9 must be in a GP. Let us verify it. How do we verify it? If it is a GP, which means what? -6 upon -4 should be equal to -9 upon -6, which I can see it very clearly happening because this is 3 by 2. This is also 3 by 2. That's exactly what I'm trying to make you understand, that geometric mean of 4 and 9 will be 6, but geometric mean of -4 and -9 will be -6. Always remember this. It will not be 6. There is a small catch here, an observation here, which you should have in your mind. The next learning here. The geometric mean between -4 and 9 or 4 and -9 does not exist. Sir, can it not be 6? Can it not be -6? No. Even if you take 6, so think -4, 6, 9. Can it be a GP? Sir, it can be -6. -4, -6, 9. Can it be a GP? No. I hope you're understanding, because in that case, common ratio will not be same. And if the common ratio is not same, how can you call it a common ratio, which means it is not a GP? So, I hope you're understanding, geometric mean can be drawn in these two cases only. This particular third case cannot give you a geometric mean. That's exactly what I'm trying to convey here. Well, if this part is understood by you through this example, let us understand how do you insert n geometric means between some given numbers. Again, I'll take an example to make you understand it more clearly. Let's say I have a number 3, right? 3 into 2 is, let's say, 6. 6 into 2 is, let's say, 12. 12 into 2 is 24, and 24 into 2 is, let's say, 48. I hope I have taken it correctly. 3 into 2, 6, into 2, 12, into 2, 24, into 2 is 48. Now, what is given here is that remove this 6, 12, and 24. What they tell me is that we are given these two numbers, 3 and 48, and then we are asked to insert 3 geometric means between these two numbers, 3 and 48. Now, what is the meaning of 3 geometric means? This means that these 5 terms, 3, G1, G2, G3 and 48 should be a GP. It should form a GP. Again, I'll use this very simple logic that if it is forming a GP, what I know here is that this is the 5th term of the GP. How do I write the 5th term of a GP? 5th term as per them is 48, but as per us, 5th term should be A into R to the power 5 minus 1, which is 4. Did you get that part, students? Now, 48 when divided by 3, what does it give to you? It is clearly 3. 48, I think it is 16, so it should be 16, right? So it should be 16, which is R to the power 4. I hope there is no confusion on that, because 16 into 3 is 48. Now, 16 can be written as 2 to the power 4, which is R to the power 4. From here, I can say that R square whole square is equals to 2 square whole square. So from here, I can say that R square will be equal to 2 square. I need not use plus minus, because again, even if I wish to, then R square cannot be negative. So that's why I'll say that R square will be 2 square. So if R square is equal to 2 square, can I say R should be plus minus 2? Now, if I use plus 2 or minus 2, in both the cases, I'll be getting 2 answers. Let us work on those 2 answers. Let's say I have used plus 2. If I take the value of R as plus 2, what will be the answers? So if the common ratio is plus 2, it will be 3 into 2, 6 into 2, 12 into 2, 24 into 2, 48. So that could be a GB. What if I take R as minus 2? Is there a possibility? Yes, let's check it. If R is taken as minus 2, 3 into minus 2 is going to be minus 6. Minus 6 into minus 2 will be 12. 12 into minus 2 will be minus 24, and minus 24 into minus 2 will be minus 48. It is not violating any condition at all. So yes, we'll be getting two GPs, one from R being 2, second from R being minus 2. What you need to understand is that there are 2 answers in this particular case. If I'm asked the values of G1, G2, G3, so the values of G1, G2, G3, in the first case, this triplet would have been 6, 12 and 24. That is also a perfectly valid and acceptable answer. But the other triplet could have been minus 6, 12 and minus 24, which is also a perfectly acceptable answer. So did you get these two explanations? Why are we getting these two answers? And how should you take care of such nuances? This is something which you should remember, which you must remember, that if you are given, let's say, if I were to find under root over x square, what usually students do is that they write it as x, which is the mistake which they commit. It should be taken as mod x. Always remember this as a result. The problem here is that, let's say if I were to find out the square root of square of minus 2. If I am finding the square root of square of minus 2, then it should not be minus 2. That's mathematically wrong. It should be mod over minus 2, which is 2. I hope you're realizing the catch here. If you take the minus 2, in that case, you are having minus 2 is equal to 2, which is mathematically wrong. So I hope you're understanding. If somebody is saying, sir, can it not be plus minus 2? No, that is not true. If you are taking the square root of 4, it is always plus 2. But if you're solving a quadratic equation where x square is equal to 4, this is a quadratic, it should have two roots. In that case, x will be plus minus under root 4. And in that case, under root 4 will be 2, but x will be plus minus 2. So this is a different case. This is a different case. I hope you will remember these simple mathematical tools which you should have in your mind. Now, proceeding ahead, what next do we have? The way we had learned some corollaries regarding arithmetic means, similarly, we can learn some corollaries regarding geometric mean. What is that? The product of n geometric means between a and b is equal to the nth power of the geometric mean between a and b. What does it mean? Let's say I am given two numbers a and b, and I'm inserting certain geometric means. Let's say geometric mean number 1, geometric mean 2, geometric mean 3. Up till I have inserted nth geometric mean and then b. So what does it mean? I had given you two numbers a and b, and then we have inserted n geometric means. So a, g1, g2, g3 up till b is forming a geometric progression, right? Now what does it mean? It means they are trying to say that if you take the product of these geometric means, which means g1 into g2 into g3 up till gn. So if you are taking this product, previously with AMs we have done, what did we do? We had added them. Here when it comes to geometric means, I hope you're realizing we'll multiply them. So if I'm multiplying all these geometric mean, it is equal to the nth power of the geometric mean between a and b. Can you help me with the geometric mean of a and b? So geometric mean of a and b will be square root of a and b, which is ab raised to the power 1 by 2. Now what they are trying to say is that geometric mean of AB should be raised to the power n. So this should be raised to the power n. What is the proof behind it? The proof remains very simple, students. The proof is straightforward. We know that if it is a GP, can you help me that the product of first and last term, product of second and second last term, product of third and third last term, it will be same. And if that product is same, by having that conclusion, can I not say that it will be equal to AB to the power n by 2? Because n pairs will be formed, n terms are there, which means n by 2 pairs will be formed. That's exactly what we are doing here. Did you get my part? I hope you're able to understand it. The same way we have learnt it in the arithmetic mean as well, the corollary. Same way we are having a corollary here in GM as well. And this is one of those corollaries which can be used in a lot of questions and direct deductions, and the answers can be brought. So remember this as a corollary as a result, and keep it with you in your short notes if you are making any, so that you can revise it whenever needed. Now, let us move to the next part of our video where we'll be solving a particular question. First of all, let us read the question. What does it say? Some very simple things are given. Let us focus on them. It says three real numbers A, B, C in AP. Okay. And A plus 1, B, C plus 3 are in GP. Okay. So there are three set of numbers we are given. And then we are told that A is greater than 10. Okay. So we are told that A is greater than 10. We'll use that information. And arithmetic mean of A, B and C is 8. Okay. That is also something great. So arithmetic mean of A, B, C is 8. Then the cube of the geometric mean of ABC is. A lot of things are given. Let us club that entire data and let us use how can we find out the final answer. JEE Mains in 2024 has asked it. Let us work on this first information first of all. What does it say? It says three real numbers ABC are in AP. So if three numbers I'm given ABC which are in AP, I'll treat A as A. Can I treat B as A plus D? And can I treat C as A plus 2D? Where I'm told that ABC are in AP. So can I treat them as a plus d and a plus 2d? Yes, we all can. Along with this, I am told that a plus 1, b and c plus 3 are in GP. So here a plus 1, I repeat, a plus 1, b, I think, and c plus 3 are in GP. So a plus 1, b and c plus 3, these are in a GP. So if these three numbers are in GP, what do I know? Can I not say that I know something very clearly here, which means that if these three numbers are in GP, then this middle term will be the geometric mean of the extreme two terms. Do you know that? Before I use this information, I have one more clue, which is arithmetic mean of ABC is 8. Okay, so let us use this particular part. So arithmetic mean of ABC is 8. If I am told that arithmetic mean of ABC, can we find out the arithmetic mean? A plus B plus C divided by 3. This we are given to be 8. Now what is A? A is A, B is A plus D, C is A plus 2D. So A plus A, that is 3A. And then D plus 2D is 3D. Divided by 3, we are given to be as 8. So 3 when divides this 3 and this 3, A plus D is found to be 8. So I have gotten the value of B, which is 8. Any confusions on that, students? Along with this, I have the value of either D or A in terms of vice versa, A or D, right? So this is the conclusion I have drawn, that A plus D is 8, which I'll use accordingly as per the need. Now, let us proceed further. What else do we know? I am told that these three terms are in GP, A plus 1, B and C plus 3. So if these three terms are in GP, the square of the middle term will be equal to the product of the extreme two terms. So here I know that if these three terms are in GP, then I know that B square will be equal to A plus 1 times C plus 3. The question boils down to the simple fact that I need to find out the value of A, B and C. Then only I'll be able to find out what I'm asked finally. Okay. So I'll work on that, but let us first work here. What is B? I know the value of B. B is 8. So here B square should be 8 square, which is 64. Now, what is A plus 1? I'll keep A plus 1 as A plus 1 only. So let's keep it as A plus 1 here. But what about C plus 3? I know C is A plus 2D. I know C is A plus 2D. Here, if I simply replace D by 8 minus A, what I know from here is that D is 8 minus A. So if I replace D by 8 minus A, can I find out that the value of C can be written as A plus 2D? What is D? D is 8 minus A. If D is 8 minus A, the value of C turns out to be A and then minus 2A. I'll write it properly, A plus 16 minus 2A. So this gives you the value as 16 minus A. So the value of C is basically 16 minus A. So the value of C I write as 16 minus A plus 3. Any confusions on that? I hope you all are comfortable with that. That C we are able to write as 16 minus A plus 3. I hope there is no calculation error so far. If you have noticed anything, do write it in the comment box. Now, proceeding ahead, what do I know next? I think I need to simplify this. So I have 64 on the left hand side. On the right hand side, one of the factor is A plus 1. What about the next factor? It is 16 plus 3, which is 19. So it should be 19 minus A. Now, let us simplify this result. Well, let's see what do we get. So here I'll be getting 64 is equal to A into minus A. That leaves you with minus A square. Then 19A minus A. That leaves you with plus 18A, I think. And then what's next? I think 1 into 19. That is clearly 19. So this is what I get. So I think the question boils down to finding or solving this particular quadratic. So we are dealing with a quadratic now. The quadratic is, I'll bring everything on the left hand side. So minus A square when brought on the left hand side leaves you with A square. Then you have 18A, which when brought on the left hand side leaves you with minus 18A. And then the next difference, which is 64 minus 19. 64 minus 19. Let us subtract 20 from 64. So it is 54, 44. And 19, so plus 1, that is 45. So 64 minus 19 should be 45. I hope we are going great. Now, what I do next is I need two numbers which when multiplied gives me 45 and which when added give you minus 18. Can I have those numbers? So 45, right? 45 I get by what? 18, right? I think 15 and 3. Yes, we are great. 15 and 3 will help you with that. So splitting the middle term. So I am left with A square minus 15a minus 3a plus 45 is equal to 0. While discussing the quadratic chapter, we have already learned this particular part that you need not split and now solve it further. You can directly crack the values of a. So values of a are found to be, one of the values of a will be 15 and the other value of a will be 3. I need to eliminate one of the values. So I have a clue here that a is greater than 10. So if I am told that a is greater than 10, I am supposed to discard this particular value. So a is going to be 15 in that case. Once you have found a, I think I have a lot of values now. A is found to be 15, right? So a is 15. This is what we know. What about b? B is also we have already evaluated. B was 8. So I have b with me. Now can we say something else about the other part? C is 16 minus A. So if C is 16 minus A, 16 minus 15 should give you 1. So that is what you have, 15, 8 and 1. I hope you are comfortably understanding this particular part. Now we have A, B and C. What I am asked, the cube of the geometric mean of ABC. So let's say ABC. Can you help me with the geometric mean of ABC? 3 numbers are there. Their geometric mean will be the third root of their product. But we are asked the value of cube of their geometric mean. So I think all I'm asked is the product ABC. What we know is the values of ABC. We have cracked 15, 8 and 1. So I think the answer should be 15 into 8 into 1, which I think is very easily understood by you all, given in the option C, 120. Did you all understand this, how easy it was? Some of you might be wondering, sir, if we are told that A, B, C are in AP, why did you not take it as A minus D, A and A plus D? Then also you will have to do the same amount of calculation. That's exactly what I'm saying. Just keep things simple and straightforward. Not always you need to do a lot of fancy things to brag or boast about yourself. Remember this as a learning. It will help you a lot in life as well, that it is not necessary to show off. Keep things simple. It will actually help you in staying sorted. Minimalism, I hope you understand more clearly. Right? Now, let us focus on the next particular part here. Let us move to the next particular portion here. Here, when I move further, I am going to discuss something more important, something more crucial. Let us work on that. When I'm talking about minimalism, you need to understand that recently, while I'm recording this video, India is playing a cricket series with South Africa and Virat Kohli is scoring runs. What you need to understand is he is simply like a topper. He's simply like one of those disciplined students who work really hard. I hope you know that he avoids sugar, he eats a very good diet, he ensures that he is not eating anything which actually hampers his health so that he can score runs, and he believes in staying consistent, and that's where instead of going for boundaries, he runs a lot. That's how he ensures that he is able to score a lot of runs while keeping it safe, while keeping it defensive. So he has that aggression while maintaining his defensive approach that he doesn't get out easily. I hope you are understanding my motive. He is one of those topper students. He comes to the class earliest and ends the class in the end, which means for the net practice, he comes at the earliest. I mean, before 2-3 days prior to the team, he reaches to the nets, and then he keeps on practicing. He keeps on imbibing or inculcating or getting adjusted to the environment or the requirement of the pitch, and he actually reads this, he actually understands it, and that's how he understands the whole culture, the whole approach which is needed for that environment. And similarly, in that same fashion, he goes ahead with that. He actually understands the whole scenario, and that's how you actually get adjusted to the requirement. And that's what a good student does. He reads the exam, he understands the exam, he does a lot of research on the exam, and that's how you strategize, that's how you prepare, that's how you do your homework, right? That's exactly what I'm saying here. Now, let us work upon this particular concept, which says, this is again something very crucial. It says some very simple things regarding two terms. Let's say I am given a quadratic. Let's forget the quadratic. I am given two numbers, A and B. So let's say there are two numbers, A and B. What I know about A and B, I hope if I am given A and B, the sum of the roots is going to be minus B upon A, and I'm really sorry, minus B upon A is not going to be there because I have chosen A and B. So let's say I'm given two numbers. And these two numbers are the roots of a quadratic. I'm given A and B as two numbers, and let's say these are the two roots of a quadratic. So whatever the quadratic is, what I know about is that if it is a quadratic, Let's say there is a quadratic, right? Let's forget this particular part. Let me bring that part here. So let's say there is a quadratic ax square plus bx plus c is equal to 0, right? And this quadratic has two roots, alpha and beta. What I know is sum of the roots is always minus b upon a. And what is the product of the roots? What is the product of the roots, students? It is alpha beta, which is always c upon a. Now, even if I don't have it, can I write the quadratic with the sum of the roots and the product of the roots? Yes, we know that the quadratic can be written as x square minus sum of the roots times x plus product of the roots is equal to 0. Now, let us focus on this particular part. If the two numbers are alpha and beta, can you help me with their arithmetic mean? Let's say the arithmetic mean of alpha and beta is given by a. So what will be the arithmetic mean of alpha and beta? That will be alpha plus beta divided by 2. Can you help me with the geometric mean of alpha and beta? Let's denote it by capital G. So the geometric mean of alpha and beta will be given by second root of product of alpha beta. Why am I saying so? I hope you must have noticed a very important conclusion from here, which is if I were to find alpha plus beta, can I not conclude that alpha plus beta will be 2a? Similarly, if I were to ask you alpha beta, it will be g square. So I have the sum of the roots, I have the product of the roots. Can I write the quadratic as x square minus sum of the roots, which is 2ax plus product of the roots, which is g square, is equal to 0, which has two terms as its roots, which are alpha and beta. So let's say I am given two terms, a and b, or alpha and beta, let's say for a while, and I need to write a quadratic on it. I can write a quadratic on it even if I'm not aware of those two terms, but if I know their arithmetic mean and their geometric mean, because through arithmetic mean, sum of the roots can be found. Through geometric mean, product of the roots can be found. I hope you are getting this part very clearly. That's exactly what we tried explaining you here in this particular part. Now, one thing also you should remember from here is that learning is very simple. This is basically the root. By applying the Sridhar-Acharya formula here on this particular equation, you can find the terms a and b, or rather alpha and beta. That's the formula, but you need not remember or learn this formula. Rather, I'll say learn the quadratic formula, Sridhar-Acharya formula. Through that, you can apply that formula here and you can get this result. So don't memorize this one. But one thing which you all should remember by heart or memorize is that if I take certain numbers and if I take their arithmetic mean and geometric mean, let's say I have taken three numbers, a, b and c. What will be their arithmetic mean? Their arithmetic mean will be abc divided by 3. What will be their geometric mean? It will be the third root of their product. So always remember, arithmetic mean of certain numbers is always greater than geometric mean of those certain numbers. Sir, you are using an equality sign as well. When is it equal? Well, arithmetic mean and geometric mean are equal if the terms are same. So if, always remember this particular result. If A, B and C are same, if A, B, C, all the observations are same, then you will have arithmetic mean to be equal to geometric mean. Which means even if you find A plus B plus C by 3, or if you find ABC raised to the power 1 by 3, it will be same. I hope you are getting why. My point here is to make you understand that this particular property has its own application, has its own learnings, has its own important implementation in your JEE journey. Don't forget this particular result. There will be a lot of questions asked on this particular portion where you are asked to use the inequality AM-GM, where AM is always greater than equal to GM. A lot of questions where inequality is given, where maxima or minima is asked, you need not always use calculus. You can use this particular part as well. And it is not directly given or asked that in this question use AM greater than equal to GM. They very subtly give you this particular question, and there your mind should be able to crack that particular portion or read between the lines that yes, there AM greater than equal to GM might be very useful. And when does it become an equality? It becomes an equality if all the terms are equal. That's when you treat it as an equality. I hope this part is very well understood by you all. Going ahead, let's see what do we have next here. That's exactly what I'm trying to make you understand. If you have n observations and if you are taking their arithmetic mean, it will be greater than or equal to the geometric mean of the same n observations. That's exactly what I'm constantly mentioning, that don't forget this particular result. This is a very crucial result, and questions are asked on this particular conclusion directly, indirectly, subtly, a lot many times. How we'll understand it through questions, of course, but you should have this thing in mind that AM is always greater than equal to GM. Let's understand this particular part here. These are the corollaries of the result we are discussing here. Let's say I were to give you two numbers. If I were to give you two numbers, let's say x1 and x2, right? Let's say I were to give you two numbers x1 and x2, and here let's, instead of giving you two numbers x1 and x2, these two numbers are reciprocal of each other. So one of the numbers is x, other number is 1 by x. First of all, I'm saying is that either both of them will be positive or both of them will be negative, because if x is positive, 1 by x will be positive. If x is negative, 1 by x will be negative. So first case which I'm taking here is that if both of the numbers are positive, if both of the numbers are positive, mind you students. So if both of the numbers are positive, their aim, I hope you're understanding this. Let me show it to you here so that we can save some times, save some efforts in writing, and we can directly get the conclusion from here. Here we have this conclusion first, that when A and B are positive or A and B both are negative. Don't look at this part. Just understand this, that A by B and B by A are two numbers which are reciprocal of each other, the way we have written x and 1 by x. So that's exactly what I'm trying to give you, that if I have two numbers x and 1 by x which are reciprocal of each other, which are positive here in this case. So here we know that arithmetic mean of these two numbers, which lambda 1 a by b, lambda 2 b by a. I hope you are understanding this part very clearly. If not, I'll write it here. So we have this number here. First number is lambda 1 times a by b, and the second number is lambda 2 times b by a. So a by b and b by a are reciprocal of each other. So this will be their arithmetic mean. And we know that arithmetic mean is always greater than equal to their geometric mean. What will be the geometric mean? The second root of their product. I hope I need not tell you. The second root means under root of their product. So a by b when multiplies with b by a leaves you with 1. So finally you're left with lambda 1 times lambda 2. If I take this 2 on the right hand side, basically I'm multiplying this inequality by 2 on both the sides. What will I get? I will get this particular result, which is what I'm mentioning here. Which means a very important conclusion can be drawn. Remember this as a result, that if lambda 1 a by b plus lambda 2 b by a am given, if you are able to observe that something and something is given, which both of which are reciprocal to each other, in that case, the maxima and minima can be thought of. So here I can find its minimum value. I repeat my part here very clearly. Let's say for a while, lambda 1 and lambda 2 both become 1 and a by b is a positive entity. In that case, if a upon b, let's say, is treated as x. So what will be the arithmetic mean of x and 1 by x? It will be x plus 1 by x upon 2. What will be the geometric mean? It will be the second root of x into 1 by x, which will be 1. So x plus 1 by x upon 2 is greater than or equal to 1, which means x plus 1 by x is always greater than or equal to 2. This is one of the implications of the property arithmetic mean greater than or equal to geometric mean. Remember this as a result. But there is a catch. If a by b is negative, which means what I'm trying to make you understand is, if x is negative. So if x is negative, then if you add x with 1 by x, if you add x with 1 by x, you will get minus 2 as the geometric mean. You remember it, because if x is negative, I hope you remember minus 4 and minus 9, the example when we discussed the geometric mean. The geometric mean of 4 and 9 was 6, but the geometric mean of minus 4 and minus 9 was not 6, it was minus 6. That's exactly what I'm saying here, that here in this case, if both of these numbers are negative, a upon b and b upon a, in that case, you will see that x plus 1 by x is turning out to be less than or equal to minus 2. So basically, this should be remembered in a sense that AMGM will be used at a lot of places while finding the maxima or minima. We'll talk about that later. But something very crucial I am wanting and willing to discuss here, that result is this, that if you have a number and its reciprocal, then the sum will either be always greater than or equal to 2 or less than or equal to minus 2. There are questions use this particular concept, so remember it. If that number and its reciprocal are positive, then that sum will always be greater than or equal to 2. And if that number and its reciprocal is negative, then that sum will be less than or equal to minus 2. Remember it. But it can never lie between minus 2 and 2. That's what I'm saying. It will either be always greater than 2 or less than minus 2 or equal, but it can never lie between minus 2 and 2. I hope you're understanding it. Sir, when will they be equal to minus 2 or 2? Well, it is very simple. When equality becomes, when do you ensure equality between AM and GM? When the observations are same. So if x is equal to 1 by x, I repeat, if x is equal to 1 by x, if you have x is equal to 1 by x, which means you are having x square is equals to 1, which means you are having x is equal to plus minus 1. So whenever x becomes 1, so 1 plus 1 will be 2. Or if x becomes minus 1, minus 1 plus minus 1 will be minus 2. So if both the observations become same, then AM will be equal to GM. Otherwise AM will always be greater than GM. Remember this as a result, a number when added to its reciprocal is always greater than equal to 2. A number when added to its reciprocal is always less than equal to minus 2. Greater than equal to 2 when the number is positive, less than equal to minus 2 when the number is negative. JEE uses it. They use it a lot many times. Remember this identity, remember this inequality. They will ask questions based on it. Where did it come from? AM greater than equal to GM. So this particular conclusion along with that derivation should be understood so that you can apply these concepts as well whenever required. Not always this directly will be asked. Sometimes you have to deal with this. So you need to understand lambda 1 and lambda 2 will be positive, but A by B and B by A will be either positive or negative. So if they are positive, this will be greater. If they are negative, this will be lesser. I hope you are understanding why. Now, let us move to the next part. The next part is even more crucial. Let's talk about harmonic mean. Look at this particular part. That's the portion where students commit a lot of errors because they get confused with the concept of harmonic mean and they treat it as an arithmetic mean. Of course, it is the reciprocal of arithmetic mean, but in a different sense. Let's understand it first. Let's say I am given three terms. So what are these three terms? Let's say I'm given three terms which let's say are ABC. So let me take three terms and these three terms are in ABC. Three terms are in HP. Let's say ABC. So these three terms are in HP. This is what I'm told. Forget this. We don't know anything about harmonic progression. What are we told? Sir, we are told convert HP into an AP and then treat it as an AP. That's exactly what I'm saying. So if these three terms are in HP, what I know is, sir, 1 by A, 1 by B, and 1 by C will be in an AP. Yes. So that's what I know for sure, that 1 upon A, 1 upon B, 1 upon C will be forming an AP because ABC were HP, their reciprocals will be in AP. That's what I know for sure. Now, do I know something related to AP? Yes, I do. So apply those results. What do I mean by those results? Now, if these three terms are in AP, the middle term will be the arithmetic mean of the extreme two terms. So from here, can I not say that middle term, double of middle term will be equal to the sum of extreme two terms, which is 1 by A plus 1 by C. I hope you are getting it very clearly. From here, if I solve it further, what conclusion do I get? Here, if I solve it further, it will be A plus C upon AC. So 2 upon B will be A plus C upon AC. And if I take the reciprocal on both the sides, B by 2 will be equal to AC upon A plus C. And if I take the final part out here, if I take the 2 on the other side, can I write it directly here? B will be equal to 2AC upon A plus C. Now, what do I mean by this particular result here? This B is the harmonic mean of A and C. But how did I get this B as the harmonic mean of A and C? After converting ABC, which were in AP, into HP, where I took their reciprocals. So instead of dealing with an HP, let's deal with an AP. What you must understand is that B is not equal to A plus C by 2 because ABC are not in HP. Sorry, ABC are not in AP. ABC are in HP. What is in AP then? 1 by A, 1 by B, 1 by C are in AP. Well, in that case, I'm able to conclude that B is equal to 2AC upon A plus C. So that's where I'll say that B is the harmonic mean of A and C. Why am I saying that B is the harmonic mean of A and C? Because 1 upon B is the arithmetic mean of 1 upon A and 1 upon C. So I hope you are able to make a lot of sense out of this particular result, that how do you deal with an harmonic mean. Harmonic mean is a very simple concept. What you need to understand is, let's say I am given certain observations. Let's say I'm given certain observations A1, A2, A3, AN. They all are certain positive numbers, right? And I need to find their harmonic mean. The way we used to find arithmetic mean, the way we used to find geometric mean, in the same fashion, we'll be finding the harmonic mean. How do we find it? A very simple conclusion, students. Can I find the arithmetic mean of their reciprocals? And then that AM, when reciprocated, will give you the harmonic mean. Are you getting my part here? Very simply. See, please understand, A1, A2, A3 up till AN were some observations. I can take their reciprocals, which will be 1 by A, 1 by A2, 1 by A3, 1 by A4 up till 1 by An. Can I take their arithmetic mean? It will be 1 by A1 plus 1 by A2 plus 1 by A3 whole divided by N. But this is the arithmetic mean. Now I need to take its reciprocal, because first HP, then you come to AP, then again from AP you go back to HP. So here again, if I have found the arithmetic mean of these observations 1 upon A1, 1 upon A2 up till 1 upon AN, then I again need to find the HM, because this is the AM. So here, to find the HM, I'll take the reciprocal. So with the reciprocal, I'll have N in the numerator, on this in the denominator. That's exactly what we did here if you paid attention to. Let me show it to you again through this perspective. Say I have three terms A, B, C. Let's say I have three terms A and C. Let's say I have two terms A and B, right? So let's say I have two observations A and B. And I need to find the HM, harmonic mean of these two observations. So what I'll do is, I'll first of all take the reciprocals. So their reciprocals will be 1 by A and 1 by B. And then I'll take their AM, arithmetic mean. What is arithmetic mean? That is 1 by A plus 1 by B divided by 2. This is the arithmetic mean of 1 by A and 1 by B. Now I'll take the reciprocal of it. So reciprocal of it is going to be 2 upon 1 by A plus 1 by B. Now, even if you were to simplify this, you'll get the same result. What does it mean? It will be 2 upon, I hope you can see it, A plus B upon AB. When this AB goes above, it is 2AB upon A plus B. So this here, 2AB upon A plus B, 2AB upon A plus B is the harmonic mean of AB, A comma B. I hope you're understanding that exactly is the result which we have received here. Can you see it here? So I hope you're understanding it. Even with two terms or n terms, what you're supposed to do is to find the harmonic mean. Remember it, because students commit error here. They get confused here. So learn it very clearly. Learn it very cautiously. That's exactly what they have tried demonstrating here through this particular part. Now, if I'm given three terms ABC, so HM of ABC, please understand HM of ABC will be 3. There are three terms, so 3 upon. Reciprocal of ABC will be 1 upon A plus 1 upon B plus 1 upon C. That is it. Even if you wish to simplify it, this is what you'll get. But I am asking you to remember this as a result. Always remember this as a result. So if you have learned this particular part, I am asking you to take a note of this particular portion, because this is what will help you in remembering the HM. I'll tell you the part where students commit the error, where they get confused. Please understand. Let's say I'm given two numbers A and B. If I'm given two numbers A and B, what will be the AM? We all know the arithmetic mean will be, A plus B by 2. But that's where they get confused. If I were to ask you what will be the HM, they say 2 upon A plus B. No, that is wrong. That is absolutely wrong. Are you understanding why? So if I am asked the harmonic mean of A and B, it is not 2 upon A plus B. Rather it is, if I am asking you the harmonic mean of A and B, what will you say? Sir, it will be 2 upon 1 upon A plus 1 upon B, the way we have done it for three terms. I hope you're realizing it. That's exactly what they're trying to say, that the reciprocal of 1 upon A and reciprocal of arithmetic mean of 1 upon A and 1 upon B. So arithmetic mean of 1 upon A and 1 upon B will be 1 upon A plus 1 upon B divided by 2. Reciprocal of this will be 2AB upon A plus B. That's exactly what you receive from here. Are you able to understand the difference between arithmetic mean and harmonic mean? Especially the part where students commit the error. And if you have understood all of this very clearly, let us understand this part, which I'll not be explaining. I'll be skipping this part because this is something confusing. Don't treat it like this. Let me take an example to make you understand it more clearly. Let's say there was an AP. AP had terms 2, 4, 6, 8 and 10, right? Now, forget this AP. Let's say I say that there is this term 1 by 2 and there is this term 1 by 10, and between these two terms insert three harmonic means. Insert three harmonic means. Let's call them H1, let's call it H2, and let's call it H3. Again, I'm not explaining that theorem. Rather, I'm explaining it with an example. So what is the question? The question is, between 1 by 2 and 1 by 10, insert three harmonic means. What I'm trying to make you understand constantly is a very simple part that don't learn it. Rather, what you should understand is that treat it as a problem on arithmetic progression. How can we do that? This is a question on harmonic progression. We need to insert 3 harmonic means. What does it mean? That between 1 by 2 and 1 by 10, if I insert these 3 terms, that will become an HP. That is the meaning of inserting 3 harmonic means. Then why are we treating it as an HP? Why can't we take the reciprocals and treat it as a problem on AP? And that's where we can solve it easily. So here, if I take their reciprocals, I hope you're understanding the reciprocals will be 2, 1 by H1, 1 by H2, 1 by H3 and 10. Now here if I look at these 5 terms, do I know something very crucial here? That these terms, these 5 terms, if they were in HP, the reciprocals will be in AP. And if the reciprocals are in AP, I think I know a lot about it, because now I can say a lot about it. Can I find the common difference? We have learned the formula that the common difference is given by last term minus first term. So 10 minus 2 is 8 divided by number of terms minus 1. So number of terms 1, 2, 3, 4, 5 minus 1, which is 4. So 8 upon 4 is 2. So that's your common difference. So I'll add this common difference here. So 2 plus 2 is going to be 4, 4 plus 2 going to be 6, 6 plus 2 is going to be 8, 8 plus 2 is going to be 10. Now students commit this error that they mark 4, 6 and 8 as the harmonic means. But I hope you're realizing these are not the harmonic means, because these are the arithmetic means. Are you getting it? Now I need to take their reciprocals. So their reciprocals are going to be 1 by 2, 1 by 4, 1 by 6, 1 by 8 and 1 by 10. So these 3 observations, 1 by 4, 1 by 6 and 1 by 8, are going to be the 3 HMs we were trying to insert between 1 by 2 and 1 by 10. Did you understand the whole process? I did not treat it as a problem on harmonic progression. What we'll always do is we'll convert our problem on HP into an AP and then solve it according to the AP. And in the end, again, we'll take the reciprocals and mark the correct answers. But you should be a little more cautious, because after getting this, students rush in marking the answers and they don't realize the difference here. I hope you're getting this thing, that this should be these 3 terms should be the 3 HMs instead of 4, 6 and 8. And why did you get that part? Now, let us proceed further if you have understood this particular part, and let us solve a question based on AM, GM and HM. How? Have a look at this particular part. Read it first. JEE Mains 2023 has asked it. It says A1 and A2 are 2 AMs and G1, G2, G3 are 3 GMs of 2 distinct positive numbers. So 2 distinct positive numbers I am given, right? Now, I am asked the value of this expression, and even if you look at the options, they'll give you more clarity that A1 plus A2 and G1, G3 is playing a very crucial role. Okay, we'll talk about that later, but let us start working on it. What am I told? I am given that there are 2 distinct numbers. Can I take those 2 distinct numbers as A and B? So I am taking those 2 distinct numbers as A and B. So now, when I'm inserting A1 and A2 as 2 arithmetic means between A and B, I'll say that A, A1, A2 and B will be forming an AP. Can we say so? Similarly, what they did was they inserted G1, G2, G3 as 3 GMs between these 2 same numbers. So I'll say A, G1, G2 and G3 along with this B will be forming a GP. Can I say so? Now let us have more clarity here. Let us have more clarity here. Although you could have used a lot of things here, but I'll try to keep it as simple as can so that things can be understood with a lot of ease. What I'm trying to make you understand is that if it is an AP, what you know, sir, if this is A, let's keep it A. Can I call A1 to be A plus D? Can I call A2 to be A plus 2D? And I call B to be A plus 3D? Because it is an AP, let's say that AP has the first term as small a and its common difference is D. So its second term will be A plus D, third term will be A plus 2D, and the fourth term will be A plus 3D. We all know that. Similarly, if here these terms are in GP whose first term is small a, can I assume its common ratio to be small r? With that, I'll say first term is A, but the second term will be AR, the third term will be AR square, the fourth term will be AR cube, and the fifth term will be AR to the power 4. Did you get that part? It is very easy to understand, I believe so. This is all what I'm writing here to make you understand, but you can draw these conclusions with yourself as well, with your own understanding as well. This is not what you all need to write, but I'm just writing all this so that I can explain it all very clearly to you. But you need not write it during the examination hall. Of course, you understand this, but to make you understand it more clearly, I have given this broader, better explanation here. Now, the expression, let's work on this expression. G1 square, G2 square, G3, sorry, G1 to the power 4, G2 to the power 4 and G3 to the power 4. Okay, let us write this particular expression. What am I told? G1 to the power 4, G2 to the power 4 and then G3 to the power 4. Okay, this is what I'm dealing with. Plus G1 square, G3 square. So plus G1 square, G3 square. Let me just verify this expression, otherwise we may end up getting the wrong answer. So G1, G2, G3 all are raised to the power 4 individually, and then G1 and G3 are squared and multiplied. Okay, so this is what I'm dealing with. Do I know their values? I think we know the values. We know G1, G2, G3, all of them, because G1 is AR, G2 is AR squared, G3 is AR cubed. So I think I can replace these values. So G1 if I replace by AR, I will have AR to the power 4 from here. G2 if I replace by AR square, I'll have AR square raised to the power 4. G3 I think is AR cube, so I'll be replacing AR cube to the power 4. Then again I'll have G1, G3. So G1 was AR, but this is raised to the power 2 into G3. G3 was I think AR cube. This should be raised to the power 2 again. So this is the expression we are now dealing with. Now let us try and simplify this. Here, if I pay attention to this part, here I'm getting A to the power 4, R to the power 4. Plus here I'm getting A to the power 4, R to the power I think 8. You know this identity. This here A to the power 4, R to the power 12, and then A square into A square will give me A to the power 4, and then R square, R to the power 6. 6 plus 2 is 8. So this should be R to the power 8. Now I have noticed something very interesting. Did you notice that part? Are you able to notice that this and this can be added and written together? Along with this, A to the power 4, A to the power 4, A to the power 4, A to the power 4 is common everywhere. So can I use that result? Okay, so I'm using this particular result. So if I am taking A to the power 4 common, I'll take that later, but let me write it first. So I have A to the power 4, R to the power 4 here. So let's keep it here, or rather I'm taking A to the power 4 common. I'll see what is happening here. So here I am having R to the power 4 here. And then why can't I take R to the power 4 also common? So let's take let me write it first so that you don't get confused. So A to the power 4, R to the power 4. What is happening here? Plus. The next part is this, when added to this, gets doubled. So it should be 2 times. What's wrong with this? 2 to the power, 2 times A to the power 4, R to the power 8, plus A to the power 4 into R to the power 12. So this is what we have. My wife mocks me because when she watches my videos, she says that I speak very fast when I say that A to the power 4, R to the power 8. So she actually laughs at this part a lot because she thinks this, she finds it very funny basically. Let's get back to our work. So here we have this thing. Now, what I was mentioning here is that instead of keeping or making it complicated, let's take A to the power 4, R to the power 4 common from all these terms. Can I do so? So when you do that, I will take A to the power 4, R to the power 4 common, and then I'll be left with 1 from here. Then I'm writing this particular term. So if I'm taking R to the power 4 common, then I'll be left with R to the power 8, I believe. So there I'm left with R to the power 8 plus. From here, I think I'm left with A to the power 4, R to the power 4 is taken common. So I think 2 into R to the power 4. This is what I have taken common. Yes, we are going great. This R to the power 8, I am willing to write as R to the power 4 whole square. Can I do so? Why did I do that? Now this one I'm writing as 1 square. I hope we can do that. I hope you must be noticing here A square plus B square plus 2AB. Can you see that happening over here? So this is basically A plus B whole square. So if I convert this into that identity, here I'm getting this result as A to the power 4 into R to the power 4 times. This is A plus B whole square, which is 1 plus R to the power 4 whole square. Now, this is what we have received, but this is not what they want to see because A and R are R values. They want something in this sense. I think I might be able to create it because I think I have a result in terms of addition, I have a result in terms of product, but I need to create it the way they want it to be. So what I can clearly see through options is that A1 and A2 are to be added. I hope you're realizing that not always you need to solve the entire question through your own standard approach. Because this is a question where I need to create an expression and that expression is given in the option, so why not seek help from the options? So one similarity I can see clearly here is that A1 and A2 are to be added. So I'll try to create that sum here. What is A1 and A2? I know A1 is A plus D, A2 is A plus 2D. Okay. Let us work on A1 plus A2, right? Let us work on that particular part. Okay. So how do I do that? How do I do that? Let us start working on that particular part. See, what is B from here? That is something very crucial we didn't notice. So if I compare B, B is basically, what is B here, students? That is A r to the power 4. So from here, if I say what is r to the power 4, you will say r to the power 4 is B upon A. So that's a very important conclusion we are able to draw, which we didn't notice, right? I'll use this particular result. R to the power 4 is B upon A. I have r to the power 4, so I will treat it as B upon A. Okay. So I am writing r to the power 4 as B upon A. Okay. So if I do so, I will have A to the power 4 into r to the power 4 outside, which I'm keeping intact, which I'm not dealing with right now. But r to the power 4, I'm replacing by B upon A, which I can do. Yes. So this is going to be 1 plus B upon A whole square, right? What do I get next? I think when I simplify this, I'll be getting a result which is A plus B, and in the denominator I'll be getting A, which will become A square. So instead of writing it here, I'm writing it on the next page, or I may write it here as well. So let me write it here. Okay. So what is it? A to the power 4, r to the power 4. So it is A to the power 4 into r to the power 4 times. What is next? A plus B by A whole square. Okay. So the next part is A plus B divided by A whole square. Instead of writing this whole square, can I write it as, see, A to the power 4 gets cancelled by this A square. So I'm left with A square into r to the power 4 into A plus B whole square. Now, let us look at the options. See, in the options I'm given A1 plus A2. Now let us use a property. Which property? Do you remember I have been constantly telling you that the properties are very subtly used in the questions. I am having 4 terms to be given in an AP. So these 4 terms are given in an AP. If these 4 terms are given in an AP, do I know a property that first and last term and second last term, they'll have their sum to be same? Do you know that? So sum of the first and the last term, sum of the second and second last term is same, which helps us in concluding a very important result, which is that A1 plus A2, sum of second and second last term, should be equal to first and last term. I hope you remember it. If you remember it, I think we need this. We need it very desperately because A plus B is what we are dealing with. And I'm very strongly willing to replace A plus B by A1 plus A2 whole square. So I think I have gotten something very interesting here. And A1 plus A2 whole square is given in only one option. So as per that, I could have marked option A, but let us try on forming G1, G3 as well, because G1 and G3 is given. What is G1? What is G3? I think we have gotten that. G1 is AR, G3 is AR cube. I think I have gotten that. A square R to the power 4, can I write it as AR? A square R to the power 4, I'm breaking as AR into AR cube times A1 plus A2 whole square. And I think we know AR and AR cube are nothing but G1 and G3. So we have gotten the result G1 into G3 into A1 plus A2 whole square. And that's exactly what we are given in the option A. So did you understand through this question, how did we seek help from the options? And we could convert it into this. It could have been a little more cumbersome had I straight away kept on solving it and would not have looked at the options. So it is advised that you keep looking at the options as well so that they can assist you. So it's like finding a midway. Half of the question I solved through my own intuition, my own approach, but half of the question I solved with the help of the options. So you bring them together, you merge them from both the ends. It's like, living happily with a partner or getting to a common conclusion. So half of the portion was played by this person and half the portion was played by this other person. So that's how you came or ended up to a common conclusion. With that, let us move ahead. Let us learn few more things, because this chapter is amazingly interesting because the concepts are simple. All you need to do is learn them, apply them, and get the answers. Here, we know this particular part. Remember this as a result, a very important theorem, A, G, and H. I'm not going to prove it. Remember this. You can prove it by yourself. Take two terms, A and B. Take their AM, take their GM, take their HM. Put those values. You will find that G square is equal to AH. What I'm trying to make you understand is that if there are two real and positive numbers, if there are two real and positive numbers, let's say A, B, and C, unequal, of course, they have their AM as capital A, their GM as capital G, and their HM as capital H. So these two numbers AB, their AM is A plus B by 2, their GM under root over AB, their HM 2AB upon A plus B. These three numbers A, G, and H are going to form a GP. A, G, and H are always in a GP. And there you should remember that G square is equal to H. If A, G, and H are forming a GP, G should be the geometric mean of A and H. If you don't believe me, you can do it by yourself and test it. Put these values and you can get the same result. Then the third conclusion is, so far we have concluded that arithmetic mean is greater than geometric mean. The next addition to it will be geometric mean is greater than or equal to harmonic mean. And when the equality becomes, this inequality gets converted into an equality when all the terms are same. If A and B become equal, arithmetic mean, geometric mean, and harmonic mean will become equal. So I hope you're getting this particular part, that first thing, A, G, and H form an GP, where G is the geometric mean of A and H, which is G square is equal to AH. Remember this as a result. There was a question in JEE mains when they had given arithmetic mean and harmonic mean, and they asked the geometric mean. Students solved, found A and B, and then found the geometric mean. I am asking you to do a very simple thing, that if you are given arithmetic mean and harmonic mean, by taking their product's square root, can you not find G very easily? Did you get that part? So if you are given arithmetic mean and harmonic mean, you need not solve two equations and find A and B. Rather, what you should do is you should multiply them and take their square root. It will give you the geometric mean. Did you get this part? So this theorem has its own beauty. All the theorems have their own beauty. They can be used by IIT JEE very subtly. Now, it is your understanding that how you remember them and apply them at the right time. Success is all about applying the right thing at the right time, at the right place. So if you are able to do it, you will get success. You will get +4 marks. You will be able to score some really good marks and you will get a decent percentile and a good success further. I hope you are understanding. You should know these properties. Let us move ahead with the next learning we have. This is what we have been discussing a lot many times. I need not explain this part. This is another conclusion you have. If you have a cubic equation, let's say. So how do you write the cubic equation? I'll explain it with a different mindset. Don't remember this as a result, but rather remember three things. Let's say there are three terms, alpha, beta, and gamma. What will be their arithmetic mean? Can you help me with their arithmetic mean? Their arithmetic mean is, let's say, capital A, which is alpha plus beta plus gamma divided by 3. So can I say alpha plus beta plus gamma can be written as 3a? Similarly, what will be their geometric mean? Sir, their geometric mean will be alpha into beta into gamma raised to the power 1 by 3. That is going to be G. So can I not say G cube is going to be alpha, beta, gamma? What about their harmonic mean? Their harmonic mean is going to be 3 divided by 1 upon A plus 1 upon B plus 1 upon C, which is going to be, I hope you're realizing, if I just try and make you understand, harmonic mean of these three terms is going to be 3 upon 1 by alpha plus 1 by beta plus 1 by gamma. LCM is going to be alpha, beta, gamma. That goes in the numerator, and the denominator, you're left with alpha, beta plus beta, gamma plus gamma, alpha. So this harmonic mean can be written as 3 times alpha, beta, gamma divided by alpha, beta plus beta, gamma plus gamma, alpha. Now, let me take you through something really interesting. Alpha, beta, gamma is G cube. If this is brought here on the left hand side and if H is pushed here, can I conclude something more interesting? Here? Let me just look at this part. Yes. So it is going to be 3 G cube upon H, which is going to be equal to this. So here, I'm trying to make you understand something very simple. Let me write it first so that I don't confuse you all. So 3 g cube upon h is going to be the value of alpha beta plus beta gamma plus gamma alpha. Now, why did I find all these values? Can you help me with some of the roots taken one at a time? Sir, this is going to be this only. Can you help me with some of the roots taken two at a time? Sir, this is this only. Can you help me with some of the roots taken three at a time? Sir, this is this only. If I have some of the roots taken one at a time, two at a time, and three at a time, will I not be able to form a cubic which is having the roots as alpha, beta, and gamma? I hope you remember in the chapter Theory of Equations, we have learnt it. Some of the roots taken one at a time, some of the roots taken two at a time, some of the roots taken all three at a time. That's exactly what we are doing here. So my point is very simple. Even if you don't remember this equation, remember this. And with this, you'll be able to form it. How do they apply this concept in questions? Let me try and help you with that. Let's say what they give you is the arithmetic mean, geometric mean, and harmonic mean of three numbers alpha, beta, and gamma. What they are not giving you in the question is the value of alpha, beta, and gamma. So they are not giving you the value of alpha, beta, and gamma. They are giving you the arithmetic mean, geometric mean, and harmonic mean of alpha, beta, and gamma. So instead of giving you alpha, beta, and gamma, they are giving you AM, GM, and HM. So if I don't know alpha, beta, and gamma, I am still able to write alpha plus beta plus gamma, which will be 3 times of their arithmetic mean. If I don't know alpha, beta, and gamma, I can still write alpha into beta into gamma, which is their cube of their geometric mean. Even if I don't know alpha, beta, and gamma, I can still write alpha, beta plus gamma alpha, which is 3g cube by h, because I know A, G, and h. So if I know A, G, and H, I can write these three terms, which means I can write this, this, and this, and I can form a cubic which will have the roots alpha, beta, and gamma. My point is simple. Even if I don't know alpha, beta, and gamma, the roots of a cubic, I can still write the cubic if I'm given their arithmetic mean, geometric mean, and harmonic mean. So this particular concept will be used in those category of questions. So in this one shot, we may not be solving a question based on this particular theorem or some more theorems, but I'm trying to give you the idea that this is one of those important theorems which you should remember. Logically, you should be able to understand this theorem, and you should be able to apply these learnings whenever such situation arises in the real examination hall or solving the practice questions. Because of the limitation of time in this one shot, not everything can be covered, not everything can be discussed, not all the questions can be done. But we are trying to do one thing, that we are trying to show you all the varieties and the approaches that how can you deal with those varieties. I hope you are understanding this part. Let us move to the next part where we'll discuss arithmetic geometric series, AGP, arithmetico-geometric progression. Let us look at this part and understand it through a question. Basically, before we solve this question, I am trying to make you understand that we are moving towards that particular section of the video from this particular portion, from this particular moment towards till the end of the video. I am going to discuss the summation of series. So different types of special series are given in the questions, and you are supposed to solve them through different techniques, whether AGP or method of difference or VN method, which is called a telescopic sum, and some other techniques. All of these methods, when clubbed, become summation of series, which is the second most important topic from this chapter, sequences series. So the most important is arithmetic progression, second is summation of this series, and the third is geometric progression, and then comes means or inequalities. So now we'll be discussing summation of series. Pay a lot of attention on it, understand the different methods, and take notes. Now let us talk about this particular part. So if I'm given an AP and a GP, and if I merge both of them, how? By multiplying their corresponding terms. So I had an AP, let's say 1, 4, 7, 10. I had a GP, let's say 1, x square, x cube, and I multiplied their corresponding terms. So 1 into 1, then 4 into x, then 7 into x square. So I got a special sequence which was neither an AP nor a GP, but a combination of both. So if it is an AP and GP both, I'll be call it arithmetico-geometric progression, AGP. I hope first of all you are able to understand this, that this is something very crucial, very important, very understanding, very crucial, very vital, They ask questions on AGP, summation of series, method of differences, summation sign, sigma sign, and then VN method. A lot of techniques and methods are there. Questions are framed on this particular concept. This is a combination of a lot of concepts together. So pay a lot of attention to this particular portion of this particular video. So AGP is what I hope you're able to understand. You're merging two sequences, arithmetic progression and geometric progression. So when you're multiplying AP with GP, you get an AGP. Now, how do you deal with the questions on AGP? Let us take an example and understand it. First of all, by looking at this, am I able to digest or understand that is it an AGP? How? Let's have a look at that. First of all, if I just start paying attention, I will notice that 5, then 5 plus alpha, 5 plus 2 alpha, 5 plus 3 alpha. It is giving me an idea that yes, there is an AP. Now, when I look at this 1 by 7, 1 by 7 square, 1 by 7 cube, it is giving me the idea that this is a GP. The moment you see the product of an AP and GP, you should have this thing in mind that this is a question on AGP. There is a very standard method, a completely prescribed standard protocol you should follow. Don't use your mind, just follow these steps which are being told and you'll get the answers. The moment you crack that this is a question on AGP, use the steps which I am suggesting at this stage now. First of all, write this expression. What is the expression? Although it is already given, but for the sake of solving the question, I am told that 7 is equal to 5 plus 1 by 7, 5 plus alpha. Then we have 1 by 7 square, 5 plus 2 alpha. Then we have 1 by 7 cube, 5 plus 3 alpha, and so on up till infinity. Some books or some people may give you a formula for AGP. Don't try to memorize that formula. That formula need not be memorized. A simple process is there, a step-by-step process is there, and within 2-3 steps you will get the answer. So instead of investing a time in learning that formula, if you can, I'm really happy with you, for you, but you may end up committing some mistakes because the value should be treated very, very precisely there. So instead, learn this approach, because JEE asks you questions on this approach, whether you know this approach or not, because they'll merge a lot of concepts and then you will be asked to apply this approach, not that formula. So learn this approach. Whenever you are given a question on AGP, this is the method which you are supposed to apply. What is the method? Let us learn that. Now what I'll do is, what was the common ratio of the GP? Sir, the GP was 1, 1 by 7, 1 by 7 square, 1 by 7 cube. So the common ratio of the GP was 1 by 7. First step, find the common ratio of the GP. Did you find that? Sir, 1 by 7. Multiply 1 by 7 on both the sides. The common ratio of the GP should be multiplied to this expression on both the sides. So if I multiply this 7 by 1 by 7, I'll have 7 by 7 on the left hand side. Here I'll have 5 by 7. Shift the terms by one term on the right hand side. So when this 5 is multiplied by 1 by 7, I'll get 5 by 7. But instead of writing that 5 by 7 here, I'll write that here. So here I'll begin with writing 5 by 7 here. I hope you have understood this. Plus, this term will also get multiplied by 1 by 7. So 1 by 7 into 1 by 7 will give me 1 by 7 square, and I'll write that step here. So 1 by 7 when multiplied to this gives you 1 by 7 square times 5 plus alpha. What I do next is 1 by 7 should be multiplied to this step, this term. So 1 by 7 into this will give me 1 by 7 cube, and that I write here. So here I'll get 1 by 7 cube times 5 plus 3 alpha. Sorry. It is not 5 plus 3 alpha. It should be 5 plus 2 alpha up till infinity. Sir, what is the next step? From the original result, to which you have multiplied by 1 by 7 on both the sides, because 1 by 7 was the common ratio of the GP, subtract this result. This result from this result needs to be subtracted. One thing you can do before doing that, 7 by 7 was 1, so I'm writing that as 1. So I'm taking the difference here. So I am taking the difference here. I hope there is no confusion on this particular part. Now, how do I take the difference? I hope it is simple. 7 minus 1, we all know, is 6. Any confusions on that? I'll keep this 5 as it is, because here if I don't have anything, I think I have 0 here. So 5 minus 0 will be 5. I hope no confusions on that. Plus, what is next here? Can you see 1 by 7 if multiplied with 5 plus alpha will be 5 by 7 plus alpha by 7. So it will be 5 by 7 plus alpha by 7 here. I hope you can see. So from 5 by 7 plus alpha by 7, if I'm subtracting 5 by 7, 5 by 7, 5 by 7 is cancelled. I'll be left with alpha by 7. So from here, I'll be left with alpha by 7. Now, here again, please pay attention. 5 by 7 square, 5 by 7 square will get cancelled. I'll be left with 2 alpha by 7 square minus alpha by 7 square. I repeat, here it is 5 by 7 square plus 2 alpha by 7 square. It is 5 by 7 square plus 2 alpha by 7 square. And what is it? It is 5 by 7 square and alpha by 7 square. It is 5 by 7 square plus alpha by 7 square. So if I am subtracting this from this, I hope you can see 5 by 7 square, 5 by 7 square getting cancelled. 7 square, LCM is 7 square. 2 alpha minus alpha is alpha. So from here, I got alpha by 7 square. Now, without modifying this particular part, can I directly write the conclusion? 5 by 7 cube, 5 by 7 cube getting cancelled. 3 alpha by 7 cube minus 2 alpha by 7 cube. I'll be left with alpha by 7 cube. So this will give me alpha by 7 cube up till infinity. So what did you achieve by doing this? If some of you are observant enough, they must have cracked the answer. They must have cracked the answer. How? Let me tell you. Students, 6 minus 5, what is it going to be? Sir, 6 minus 5 will be 1 on the left hand side. So I'll have 1 on the left hand side. I hope I need not tell you. 5 when brought on the left hand side will make it 6 minus 5. This is alpha by 7 square, alpha by 7 cube up till infinity. So what do we have on the right hand side? Alpha by 7, then alpha by 7 square, then alpha by 7 cube, and so on up till infinity. Let us go back to the question. We are asked the value of alpha. We need to find the value of alpha. How do I find the value of alpha? I think I have an equation in alpha, but the problem is, sir, this is the sum of an infinite GP. Then why is it a problem? First of all, we need to understand this infinite GP has the common ratio 1 by 7. I hope you know how to find the sum of an infinite GP. The formula was A upon 1 minus R. What is A? First term. What is R? Common ratio. So can I not use that? So here it is 1. The first term is alpha by 7. I'll write it like this here. Upon 1 minus. What is common ratio? 1 by 7. Because if this is multiplied by 1 by 7, I'll get this. This into 1 by 7, I'll get this. So common ratio is 1 by 7. I hope we have the result right there in front of us. All I need to do is solve. So 1 is equal to alpha by 7 divided by 7 minus 1. That is 6 by 7. I hope there is no confusion on it. 7 gets cancelled by 7. I hope we are going great. So alpha upon 6 is 1. And if alpha upon 6 is 1, alpha will be 6, which I should be given in one of the options, which says option B. I hope very simple, straightforward and easy this question was. No confusion on this, I believe. With that, let us talk about the sigma notation now. Sigma is a very straightforward notation. AGP, I hope you are able to understand. The modus operandi, the standard operating procedure, the step-by-step solution. If you didn't, revise it, watch that part of the video again, which I don't think so. Solve some questions on AGP which are given on the DPPs. You will understand that process. I have explained it. You will be able to consolidate it if you solve a lot of questions. Some PYQs you should solve. Then you'll get the clarity on AGP or questions on AGP or on the method of dealing with the questions of AGP. Similarly, there is the next concept which is called this sigma notation. How do we deal with it? Let us talk about that now. So now let's talk about another important yet very effective tool of calculating the summation of a series. Here it is called sigma notation. It looks like a very simple operator, but it plays an amazingly crucial role in solving a lot of questions. Usually what you need to do is, if by some means, which of course we'll learn, if you are able to define the nth term or the rth term, let's say for a while, then by using this sigma operator, you can find the summation with some simple standard formulae. What is that? Let's have a look at this particular part. Questions are asked. The only tricky part is that in a question, you need to identify a pattern. And once you have identified the pattern, create its general term, write its general term. Once you are able to generalize the nth term or the rth term, then you will be able to find that summation by using this sigma operator. How? Let's learn that particular result. Again, one of the very crucial topics, a very important topic, because this comes under the category where you are asked summation of series. So whether it is VN method or summation through sigma or method of difference or AGP. So all these subtopics get clubbed and create summation of series, which is the second most important, as I have been constantly mentioning. So pay a lot of attention here, because this is something which will definitely give you minimum 4 marks from this particular chapter. How? Let's have a look at that. So here you need to understand that sigma, first of all, should be understood in a very simple language. Let's say if I'm writing sigma n from 1 to 9. So n is ranging from 1 to 9 and you need to put sigma over n. It means n begins with 1 and then you put this plus sign because of this sigma, and then you increase n by 1, then 1 becomes 2, then you again put plus sign because of this sigma, then you increase 2 by 1 which becomes 3, and then again you put plus sign, and this keeps on going until n becomes 9. I hope you are able to digest this particular part. Here, what you need to understand is, let's say if I were to write another expression, which expression? Let's say if I were to write sigma 2n plus 2. Now, what does it mean? So, sigma 2n plus 2 is a very simple operator, and if I were to write it here, let's say I'm taking n from 1 to, let's say, 4. So, here what you need to understand is that I'll begin with the value of n as 1. I'll pass it to this expression. I'll get a certain value, which will be, I think, 2 into 1, which is 2 plus 2, which is 4. Then I'll put plus operator. Because of this sigma, I'm supposed to use plus operator. Then this n, which was 1 previously, gets increased by 1. So now it becomes 2. So 2 into 2, 4. 4 plus 2 is 6. And again, I put plus sign until the last term. What is the last term here? And finally, in the end, becomes 4. So 4 into 2, 8. 8 plus 2 is 10. So this is how you add these 4 terms basically and get the final result. But this is not what we'll always do. But first of all, I'm trying to make you understand that how do you deal with the sigma operator. I hope there is no confusion on it and you are comfortably understanding how to expand the sigma operator. Now there are certain properties and rules which you should be aware of while dealing with the sigma operator. What are those properties? Let's learn it. The way we deal with derivatives operator or the integrations operator. Similarly, there is this operator sigma, summation. Now, how do you deal with it? Let's say, first of all, what you need to understand here is that if I am defining TR, where R is ranging from 1 to n, then what does it mean? Can you help me in generalizing it? We'll write it as TR. R should be 1 first, so I'll write T1, then plus R gets increased by 1, so it becomes 2, then plus T3, until this n is attained, which means Tn. So T1 plus T2 plus T3 plus T4 up till Tn in a shorter format can be written as summation TR, where R is from 1 to n. I hope everything is very well understood by you all. This expression is which gets expanded, but in this expression the variable R initiates or starts with 1 and reaches till this n, which is the boundary condition for it. I hope it makes a lot of sense now. You are able to understand how do you expand a sigma operator. Let's get more clarity on it. Sigma operator is distributive over addition or subtraction, which means if you are adding or subtracting two different terms on R, so I can, distribute this sigma individually to both of these terms. Let's say I'm having TR and TR dash. Here, let's say I have TR and TR dash for a while. So let's say this is TR and this is TR dash. And on TR plus TR dash or TR minus TR dash, I am given a summation sign. So this summation R from 1 to n is given on TR plus TR dash. Then I can, distribute this summation sign on this TR and TR dash individually. So I can use either plus or minus, whatever sign is given over here. And accordingly, on addition or subtraction, this summation can be distributed to each of the term individually. What does it mean? I'll try and give an example so that you understand it more clearly. Let's say I am given an expression where it says, R square plus, let's say, R plus, let's say, 2. And a summation sign is put over here where R is from, let's say, 1 to n. So what you can do here is that since r is ranging from 1 to n, you can put this summation on this, and this distinctly, because there is this addition or subtraction sign here. So over addition or subtraction, this can be distributed, which means I can write it as summation r square plus summation r plus summation 2. We'll understand what is the meaning of these. How do you understand summation r square? What is the meaning of summation r? How do you expand summation 2? That we'll discuss later. But first of all, please understand, over addition or subtraction, the summation can be distributed. Of course, in these cases, if I were to ask you about r, then r will be ranging from 1 to n. So in each of these cases, r will be ranging from 1 to n. And it should be understood, if I am not writing that r is ranging from 1 to n, then it is very well understood that the summation means that only, that whatever the variable is, that must have started with 1 and it should have reached till n. So even if it is not written that r starting with 1 and reaching n, then also it means this summation sign only. So usually, the way we take logarithm, and if we don't mention the base, then it is assumed that the base is 10. Similarly, if I am writing summation sign only, sigma sign only, then it is assumed that in this, the variable must be starting with 1 and going up till n. So that is what I'm trying to make you understand in this particular part. Let us get back to the properties we were discussing. The next property where students commit error is that you cannot split or distribute summation sign over product or division. So if I'm multiplying a TR and TR dash, and I'm supposed to put a summation over it, so you cannot use this summation individually on TR and TR dash and then take product. No, you cannot do that. This is false. I hope you will remember it. The same you cannot do over division. For example, there is an expression TR upon TR dash. So an expression in r in numerator and an expression in r in denominator. And this entire expression's summation is needed to be taken. Again, the problem is you cannot take summation individually in the numerator and individually in the denominator. That will be wrong. That will be false. So these are some basic things which cannot be done. So if we are learning something which can be done, what you should also learn that what cannot be done, because students usually commit such mistakes and get the wrong answers. And they don't hesitate in giving you the wrong options through these wrong methods, because they know you may commit such errors. I hope you're understanding it. Now, along with this, there are some more things. Let us explore them first of all. If there is an expression in r and there is a constant getting multiplied to it, so the way we do with differentiation and integration, we can take that constant term out and we can apply sigma on that r, TR basically. What I'm trying to make you understand is a very simple result here, students. The result is this, that let's say if you are given, let's say summation 2 times r square, where r is ranging from 1 to let's say 5. So here my variable is r. So this 2 behaving like a constant and getting multiplied. And that's why I can take this 2 common, which means I can write this 2 outside and summation r square can be done where r is ranging from 1 to 5. So this is also what you can do. I hope this part makes complete sense and it is very well understood by you all. There is no confusion on it. Now, coming back to the discussion, sir, here you are able to split summation. I'm able to split the summation because there is something very interesting which you all need to observe or pay attention to. What is that? Let's have a look at that particular part. Please understand. Here, let's say if I'm given this summation sign, where there is an expression on I and j, in I and j. So there is an expression in I, there is an expression in j, which is splitted. So for example, let's say I'm writing an expression over here to make you understand it more clearly. Let's say there is an expression, let's say I square plus 1, and there is another expression j plus 3. And then you are put 2 summations where one summation says that I is ranging from 1 to 3. And there is another summation on it where j is ranging from let's say 1 to 4. So one of the ways is that you apply nested loops. Now what does it mean? I'll begin with j being 1 and then I put the 3 values of I, 1, 2, 3. Then I'll get back to this and make j 2 and then use again 3 values of I. Then I'll take another value of j which is 3 and then correspondingly again I take 3 values of I, and then finally I take the final 4th value of j which is 4 and correspondingly I use 3 values of I. So this is how 4 into 3, 12 expressions will get created and then I can find the result. Or what I can do is, in this particular special case, because here what is happening here is that here this term I and this term j, they are independent and they are separated by this product sign. So they are individually independently written in a separated manner. So there is nothing there related to j is there in this I, and there is nothing related to I is given in this expression of j. So j is completely separated from I and I is separated from j. So terms or expression in I and terms or expression in j are completely separately written isolately, although there is this product sign. But if I'm able to create different factors, totally, where this I is separated completely and this j is also separated completely, and individually I need to apply summation on I and j, but summation on I is ranging from 1 to 3 independently, summation on j is ranging from 1 to 4 independently. Now there are two ways. First way we have already discussed previously. The other way is that I can apply the summation individually to these two terms. What I'm trying to make you understand here is a very simple formula here, students, that this particular expression can also be written as summation on j, let's say j plus 3, and then summation, of course, multiplied by summation on I square plus 1. Where what you need to understand here is very clearly that here, if I'm applying summation on j, then j had the range from 1 to 4. And if I'm applying summation on I, then I had the range from 1 to 3. And whatever result I get from this, and I can take their product. So that's what you're allowed to do if I and j can be written independently and separately. Did you get this part? So whenever this kind of scenario arises, you can use this particular kind of a result. Always remember this. But I hope you remember, sigma cannot always be distributed over product, but this is that special case where two sigmas were given and they were individually independent, and independently terms in I and j, expressions in I and j could also be separated, and that's why I could apply summation on I and j individually or separately or isolately. I hope you're able to understand this particular result. Both of the ways, either you use this way where you begin with j being 1 and use all the three ways of I, then j, then you make j2 and then you again use all the three ways of I. Even through that manner or through that process, even if you are getting the results, you will get the same answer. If you don't believe me, you can check it, test it by yourself and get the result, and you will realize that yes, both of the processes are exactly same. Algebraically also you can test it. Now, if you have understood this particular result, let us explore further and get more understanding, more clarity on this sigma sign. What is that? Here that is something very crucial, what you need to understand. And between sigma, I am bringing this particular part because this part is of course based on sigma, but it lays the foundation of the VN method, or what you call the telescopic sum. What is it? We'll understand it when we discuss the VN method. But since we are discussing sigma, let me explain this particular part as well. What is it? Let's have a look at it. Let's say there is an expression in f, there is a function in f. Basically, there is a variable r. So function is in r, the variable is r, let's say. But here, I am able to write that expression, whatever expression I'm given, let's say in a question, in terms of fr plus 1 and fr. So I'm able to write it as fr plus 1 minus fr. How? I'll explain it through a question. But let's say if I'm able to do so, let's say this is the expression we are dealing with. Which expression, students? That summation over fr plus 1 minus, of course, fr, where r is ranging from 1 to n. Let's say this is what I'm given in a question. In a question, let's say I get this kind of an expression. So I'm trying to give you the idea that how does it get applied in VN method. Let's have a look at this particular part. Now, it says that if I begin with r as 1, so I'm putting the value of r as 1. So if I put r as 1 here, what will I get? I'll get f of 2. If I put the value of r as 1 here, I'll get f of 1. This is my first expression. Then what I get next is, I'll put the value of r as 2. So when you put r as 2, you will get f3, and from here I'll get f2. When I put r as 3, I'll get f4 from here, and I'll get f3 from here, and so on. This will keep on happening. And then finally, with let's say the last term, when r becomes n, it becomes f of n plus 1. And the last term here will be minus f of n. Now I want you to pay attention to it and understand a pattern. Can you not see that this f2 cancels this f2, this f3 cancels this f3, this f4 cancels that next f4, and similarly the second last term will have fn, that will be cancelling this fn. And then finally, do you not think that I'll be left with these two terms only? Which two terms? Fn plus 1 and f1. So can I not say that this result can simply be written as f of n plus 1 minus f of 1. So that's exactly is said to be the Vn method. So I'm laying the foundation of Vn method here. I'm proving it here that how do you use this particular result. So let's say in a question I'm given an expression, and by some means, by some calculation, by some intuition, I'm able to break that expression into something like this, f of r plus 1 minus f of r. Then do you not think by having this particular result, I can directly get the answer in 1 second? Did you get that part? So that is the importance of Vn method. Not just this result, there is one more conclusion which you need to understand. If ever you encounter this kind of an expression, not always you will be able to break it into fr plus 1 minus fr. Sometimes you break it into fr plus 2 minus fr. Well, in that case, there will be a certain gap. What is that gap? Let us look at that particular part. So fr plus 2 and fr. Let's say I need to put summation on fr plus 2 and fr, of course, where again I'm putting this summation sign here where r is ranging from 1 to n. Now, if you don't understand this part, just expand it. Just start putting the values of r, you will realize what is happening here. I'll begin with r as 1. So if I put the value of r as 1, I hope you can see if r is 1, it will be 3. If r is 1, it will be f of 1. When r becomes 2, it becomes f of 4 and it becomes f of 2. Now you might start noticing when r becomes 3, it becomes f of 5 and there it becomes f of 3. When r becomes 4, it becomes f of 6. I hope you are seeing it very clearly and it becomes f of 4. I hope now most of you must have started noticing what I'm trying to convey. Similarly, when you attain the last term or the second last term, let's say for a while, let me write the last term in the second last term here. So when you reach to the second last term, what do you get when with the second last term? It will be, instead of r, I'll be putting n minus 1. So n minus 1 plus 2, that will be f n plus 1. I hope you get it. You got it. N minus 1 plus 2, that will be n plus 1. And here it will be minus f of n minus 1. And finally, when you replace r by n here, it should be f of n plus 2 minus f of n. So this is the final expression. But again, if you look at it closely, if you pay attention to it, you will get a very good observation. Now, what is that observation? Please pay attention to this part. Here, this first term got cancelled by this term. So I repeat, one term, one expression in between gets skipped or escaped, and this first term of first term gets cancelled by the second term of the third term. Are you understanding my language? Here, I'll make you understand it more clearly. F4 cancels this F4. I hope you are understanding it. So whatever F5 is there, that F5 will get cancelled by this particular portion here. Similarly, F6 will also get cancelled by the next here. And here also what you need to understand is that in this particular case, when I talk about this Fn plus 1, will it get cancelled? Because to cancel this Fn plus 1, there should have been Fn plus 1, which I'm not receiving. Similarly, Fn plus 2 will not get cancelled. But this Fn minus 1 will get cancelled by something here, Fn minus 1 of course. This Fn also will get cancelled by this Fn here. So all of these terms will get cancelled, but in this particular case, I'll be left with two terms. Which two terms? F1 and F2 here. Fn plus 1 and Fn plus 2 here. And that's why we are concluding that if this kind of an expression comes into picture, you write it as Fn plus 2, Fn plus 2, and there is this correction, I believe. There is this correction because it should be Fn plus 1 plus. So I'm making that correction here. Just give me a second, everyone. This should be plus Fn plus 1 minus F2 minus F1. I hope you are understanding these two results. I repeat, these two results are very, 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 very important because they are laying the foundation of Vn method or the Vn formula. So please understand, this is nothing but the Vn method, or some people call it telescopic sum. So whenever you are asked to deal with questions on telescopic sum, an expression will be given to us, summation basically. I'll try to generalize its rth term in such a manner that I should be able to write it either like this or like this. And I hope you know, once you're able to break your expression into something like this, you can finally deduce your answer either like this or this. So I hope you're able to understand and digest what I'm trying to say here when I'm claiming that this is exactly nothing but the telescoping sum. Did you get that part? Although we'll understand telescoping sum differently here in this particular video only with some examples, but here since summation sigma sign was being discussed and this is the property of sigma, so I have brought sigma with Vn together. But we'll discuss it, don't worry about it, but I hope sigma and its beauty you are able to understand. With sigma, how easy questions can become if you are able to do some things with your expression. Let's get more clarity on it. Let's go ahead further and let's see what else can we do with this sigma sign. Here, there are some more things related to sigma. Let's explore them also here. If I am asking you 1 plus 2 plus 3 up till n, as we have already discussed, there you need to memorize this as a result, that whenever I'm asking you sigma n, now sigma n means 1 plus 2 plus 3 plus 4 up till n, it means sum of first and natural numbers. You should have this formula at your fingertips, n plus 1 by 2, because we'll use it. So the next time onward, if I'm seeing summation n, sigma n, I'll not hesitate in replacing it by n plus 1 by 2. Do you all get that? Similarly, the next result will be if I'm having 1 plus 3 plus 5. That means if I'm having first n odd natural numbers, I will not hesitate in replacing it by n square. So whenever I'm having sigma 2n minus 1, 2n minus 1 means first n odd numbers 1, 3, 5, 7, 9 and all. So whenever you are having sigma over 2n minus 1, you should not hesitate in replacing it by n square. These are the results I'm not mentioning for the sake of mentioning. You should remember them. You should learn them. You should memorize them. You should by heart them. Please. Now, here, if I go ahead further, the next result is sum of squares of first n natural numbers. Students usually forget it. Please learn these results. They can directly help you in questions and you can directly get the answers through these results. So this result, another result is sigma n square. Sigma n square means sum of squares of first n natural numbers, which means 1 square plus 2 square plus 3 square plus 4 square up till n square. Well, it is nothing but n plus 1 2n plus 1 divided by 6. Another formula which you're supposed to remember. Most of you must getting this deja vu that yes, this is what they might have studied and this is what we'll keep using whenever we are dealing with questions based on summation. So whenever I see summation, yani sigma on n square, I'll replace it by n plus 1 2n plus 1 whole divided by 6. Do you all get that? Now, there is another result which is sum of the cubes of first n natural numbers. What does it mean? It means 1 cube plus 2 cube plus 3 cube up till n cube. So summation over n cube. Summation over n cube is nothing but the square of the sum of first n natural numbers. What was the sum of first n natural numbers? It was n plus 1 by 2. Square it. So if you are squaring n plus 1 by 2, then you will get sum of cubes of first n natural numbers. I hope you are understanding. So summation n cube can also be written as square of summation n, because algebraically they are same. I hope you are able to digest this result. Now, if I move ahead, if I proceed ahead, do we have some more? I think we have a question on sigma. I think we have a question on summation. So very beautiful, very amazing question. This was way back, was asked by JEE Advanced previously, a few years back, and now JEE Mains has used that same question. So please understand, JEE Mains sometimes, or rather a lot many times, uses the questions of JEE Advanced as it is. So if you look at the JEE Advanced previous year's questions, you will find this question there. And that same question, as it is, without any change, is brought by JEE Mains. And you will realize how simple these questions are if you know the basics. So I constantly keep on saying this particular thing, that nothing is tough in this world. Nothing is hard or difficult in this world. It is simply that you need to understand it. Once things are understood, you need not fear them. Please understand this. You should not fear anything in life. You should simply invest your efforts in understanding things. Because once it is understood, it will be understood and you will not fear it anymore. Now, let us focus on this particular question. How do we do it? A very interesting, a very good question asked by JEE Advanced as well previously. Now, how does JEE Mains is asking it? How is JEE Mains asking it? Let's work on that particular result. So I am given an expression. Which says that 1 by 1 to the power 4 1 by 2 to the power 4, 1 by 3 to the power 4, summation of all these terms up till infinity is pi to the power 4 by 90. Now that's a fact. This is what we are given. Along with this, we are given one more fact, that this expression, when I take the odd terms out of it, so instead of this expression which had even and odd terms 1, 2, 3, 4 all, if I simply took the odd terms 1, 3, 5, then I'll have an expression which they are denoting by alpha. Okay, that's fine. Similarly, in the next expression, what they did was they broke it, they separated it from the odd terms, and they took the even terms only. So 1 by 2 to the power 4, 1 by 4 to the power 4, 1 by 6 to the power 4 up till infinity. And this sum they are denoting by beta. And now JEE Mains in 2025 is asking you to find the value of alpha upon beta. I'll be really happy if some of you could solve it by yourself. So here at this stage, pause this video and attempt it by yourself. It is not as tough as it looks. In 3 steps, you can get the answer. Although to demonstrate it, to make you understand, I might have to write more steps. But yes, technically, it is a question of not more than 3 steps. How? Let's look at this part. Can I begin my solution, students? I hope most of you must have tried it. So let's have a look at this particular part. I will look at this result. Can I focus on this result here? Whenever infinity comes into picture, you have a lot of liberty in that case. How? Let's work on this result. See, first of all, do you all agree that this expression I'm given is nothing but alpha plus beta? Why? Because this expression contains all the odd terms 1, 3, 5. This expression contains all the even terms 2, 4, 6. So if I club the odd and even terms, then I'll get this. So if I add alpha with beta, I will get pi to the power 4 by 90. Are you understanding what I'm trying to say here? So my first conclusion is very simple. With the observation, I can say that alpha plus beta is pi to the power 4 by 90. Do you all agree with this? What I'm trying to make you understand is, by observation only, by looking at this and this only, you can conclude that if this and this are added, see, 1 by 1 to the power 4 plus 1 by 2 to the power 4 plus 1 by 3 to the power 4 plus 1 by 4 to the power 4. If you add it up till infinity, will you not get this? And if you are getting this, this means what is it? It is pi to the power 4 by 90. But what is pi to the power 4 by 90? Sir, pi to the power 4 by 90 is alpha plus beta. Can I say this through observation only? Did you get this part? Now, let me rewrite this particular result. Why? I'll tell you later, but let me rewrite this beta, this expression in beta. So I am having this expression 1 by 2 to the power 4 plus 1 by 4 to the power 4. Okay. Then we have plus 1 by 6 to the power 4 up till infinity, and this is said to be beta. Okay. From this expression, let's say I am taking 2 to the power 4 common. So if I am willing to take 2 to the power 4 common, I hope you must have noticed here that if I am taking 2 to the power 4 common, I'll be left with 1 here. Can I write that 1 as 1 upon 1 to the power 4? I hope you won't hesitate in saying so. If I am taking 2 to the power 4 common from here, do you not think I'm left with 2 to the power 4 here? So I'll be writing it as 1 upon 2 to the power 4 here. If I have taken 2 to the power 4 from here, do you not think 3 to the power 4 is left here? So I'll be writing it as 1 upon 3 to the power 4 here up till infinity. Until infinity, right? This is also given as beta. The question is done. How? If anyone is paying attention, then most of you must have realized that this expression over here, this expression over here, this expression over here, 1 upon 1 to the power 4 plus 1 upon 2 to the power 4 plus 1 upon 3 to the power 4 plus 1 upon 4 to the power 4 up till infinity is nothing but this. So what I'm trying to make you understand is that this expression over here, this particular part over here is nothing but pi to the power 4 by 90. So can I not write this result as 1 by 2 to the power 4, which is 1 by 16? I'm really sorry. This is 1 by 2 to the power 4, which means it should be 1 by, what is happening here? This is 1 by 16 into, what is it, students? This result is nothing but what? This result is pi to the power 4 by 90. So I'll be writing pi to the power 4 by 90 here. What is the next result? That is nothing but what? We have beta on the right hand side. So I'll be using beta on the right hand side. So this is the value of beta we have received. Now this value of beta, if I'm using here, I think I'll get the value of alpha upon beta. How? Let's work on it. Even if I don't get that, I think all I need to do is, if I'm dividing, let's call it equation 1. Instead of using this, let's call it equation 1 and let's call it equation 2, right? If I wish to avoid some confusion, can I say, instead of writing beta on the other side, can I write beta on the left hand side to make you understand it more clearly? Now, equation 1, I'm dividing by equation 2 so that I can crack alpha upon beta. So I'm dividing equation 1 by equation 2. So on the left hand side, we have alpha plus beta. Here we have beta. So on the left hand side, I'll have alpha. What is happening here? I have alpha. What's wrong with this? Alpha plus beta divided by beta. And what do we have on the right hand side? So alpha plus beta is pi to the power 4 by 90 divided by, what do we have here? Pi to the power 4 by 90 into 1 by 16. So this is, what's wrong with this? Pi to the power 4 by 90 whole times 1 by 16. I hope you are comfortably getting this particular portion. Now what do we have next? I hope nobody must be feeling confused that this factor cancels this factor. On the left hand side, I'm left with alpha upon beta plus beta upon beta, which becomes 1. And here it is 1 upon 16, which is nothing but 16. So from here, if I take this one on the right hand side, I'll be left with alpha upon beta, which is going to be 16 minus 1, which is going to be 15. And that, I believe, is exactly what we were looking for. So that, I think, is option C. Did you realize, notice and understand that on Sigma, how simple this question was? If I could observe few things, if I could understand few things, I could do this question within seconds. Did you understand this entire question, students? I hope you are comfortably able to digest everything which is being said to you here. Now, let us proceed ahead. Let us get more clarity on some more concepts. This is called method of difference. Rather than making you understand the theory, let me take an example to make you understand method of difference with this particular example. The way we have understood AGP, arithmetic geometric progression, if I could tell you the theory and give you the formula, you would have gotten confused. So instead of giving you the complete theory, instead of telling you the standard operating procedure theoretically, I'll make you understand this modus operandi through this example, because through this illustration, you will understand it more clearly with more insightfully. So what is that? Again, we have taken a question asked by JEE Mains in 2025. Now, what was the question and how does it use the concept of method of difference? That's exactly what we'll discuss in this particular question. The question says this is the summation 1 plus 3 plus 11 plus 25 plus 45 plus 71 up to 20 terms. Okay. So let us denote this summation by S. What is this summation? This summation is given as 1 plus 3 plus 5, then, sorry, it is not 5. 1 plus 3 plus 11, then you have 25, then the next is 45, then you have 71 up till 20 terms. Let's say I'm not interested in 20 terms. Let's say I'm writing Tn here. Why did I do so? I will explain that part later. Forget this part here. Let's say I am doing it here. How do we select? Let me check this particular part because I want to select something. I think this will erase it, all right. Yes, it has erased it. Because I need to shift it on the other side. So how do we do that? No, this is not happening because of this. Okay, skip this part. So this is what I have, right? I need to shift it on the other side. How do we do that? I think I'll have a tool from here. No, we don't have a tool from here. Okay, skip it. So this is what we have. Forget it. Okay. Can this help us in doing that? No, this is not helping us. Okay, so this is what we have, right? 1 plus 3 plus, because I needed some space on the right hand side. So I wanted to shift on a little leftward side, but okay, let's skip this part. So this is what we have. Okay. Now, pay attention to the part when I say that if you could see something very interesting here. Now, what is that interesting part? What is 1 and 3? What is the difference between 1 and 3? The difference between 1 and 3 is 2. So let me write that difference here. Okay. So if I could write that difference here, the difference between 1 and 3 is 2. What is the difference between 3 and 11? The difference between 3 and 11 is clearly 8. I hope you can notice it here. So difference between 3 and 11 is 8. What is the difference between 11 and 25? So I hope I need not tell this. This is 14. So this difference here is 14. Let us delve further. What is the difference between 25 and 45? Sir, this difference is 20. What is the difference between 45? Although this is sufficient, but let's delve further. What is difference between 45 and 71? This I think is 51, 20, so 26. So this difference is also 20. Yes, this difference is 26. Now, why am I using this? Why am I observing this? I am trying to make you notice something very interesting here, that if you could see that the difference between these terms is a sequence which is nothing but an AP. It is nothing but an AP. How did I see that? 1, 3, 2, 3, 11, difference is 8, 11, 25, difference is 40, 25, 45, difference is 20, 45, 71, difference is 26. So I could notice the difference here. Yes, that is what we could all observe. Now, what do we have next? If I look at this particular pattern, 2, 8, 14, 20, 26, and so on, can you not see that this particular pattern, 2, 8, 14, 20, and 26, this is forming an AP? Now you will be given a sequence whose sum is what you will be asked to find out. Now there are two possibilities. You will find the difference between the terms and it will form either an AP or a GP. So I can see that 2 plus 6 is 8, 8 plus 6 is 14, 14 plus 6 is 20, 20 plus 6 is 26. So I am noticing that the sequence which we were given was not an AP, perfectly fine. But what I should observe is that if I took the difference between these terms, so that difference formed an AP. What you need to observe is, if this difference is forming either an AP or a GP, then also there is a method through which you can get the answer. What is that method? That's exactly what we'll discuss here. Again, there is a standard approach which you need to abide by, stick to it, and you'll get the answers. Don't use your brain, just stick to that method. There is a shortcut as well. You can generalize the nth term, but there are again some set of different formulae, and then you'll ask to remember those formulae, which I'm not discussing right now at this stage. I'm directly giving you the method. So instead of remembering again a lot of formulae for different cases and getting confused, I am rather telling you to understand the method, which is unique, which is common, which is same for whatever the case is, and that's how you'll get the answers more easily. So what is that method? Let's have a discussion on that method here. The method says, like AGP, here also what you need to do is, instead of multiplying it by anything, just write the same sequence but shift it by one step, one term. What do I mean by that? I'll write the same as here, but 1 I'll write below 3, 3 I'll write below 11, 11 I'll write below 25, 25 I'll write below 45, and so on. And I hope you're realizing n minus 1th term will come here, and here I'll have the last term, nth term, which also gets shifted here, gets shifted. I hope you're realizing why, and there is no confusion on that part. So first of all, I hope most of you must have noticed, why am I able to do so? The observation was simple. The difference was either in AP or GP. That's when you are allowed to do it. Sometimes the difference may not be in, but then difference of difference could be in AP or GP. Then also you can use this method. That's what you do with this particular approach, method of differences. So first we discussed AGP, then sigma. Now we are discussing method of differences. Then we'll discuss VN method, summation of series, right? Now let us work on this particular part. How do we proceed further? What I'll do is, from this first term, I'll subtract the second term. Rather, from this first equation, I'll subtract the second equation. Most of you must be wondering, they are the same terms. The difference should be 0 is equal to 0. But if I do it a little differently, I'll get something more important. How? Let's have a look at that. So from this above expression, I am subtracting this expression below. And then I'll be getting something very useful by doing so. What is that? Let's work on this particular result here. So here, I think s minus s is going to be 0. But here, I hope nothing is written over here, it means 0 is written over here. So 1 minus 0 is 1. Then you have 3 minus 1, which is 2. Then you have 11 minus 3, which is 8. Then you have 25 minus 11, which was 14. Then you have 45 minus 25, which is 20, I believe, and so on up till this term. And here, this plus this, I think, is 0. So 0 minus Tn will be minus Tn. So here, I'll be having minus Tn. Did you all get this part? I hope there is no confusion on it. So this plus sign and this plus sign is also there. Now, I am taking this Tn on the left hand side. So when that Tn is brought on the left hand side, what are you left with? Now I am left with 1 plus 2 plus 8. So this is 1. Then you have this plus 2. Then you have this plus 8. Then you have this plus 14. Then you have this plus 20. Up till this term here. Up till this term here. Only question I have here is, can you help me with the number of terms? Can you help me with the number of terms here? Please understand, let's discard this one, let's forget this one, or let's keep this one aside. After this one, if I pay attention to this sequence, 2 plus 6 is 8, 8 plus 6 is 14, 14 plus 6 is 20, 20 plus 6 will be 26, which would have been the next difference, and so on. Can you help me with the number of terms? Please understand. From this up till this, there were n terms. Are you all able to notice that these are n terms? Out of these n terms, if I'm removing this one, out of these n terms, if I'm discarding this one, do you not think that from this term to this term, these are total n minus 1 terms? Do you all agree on this with me? That from 2 to this last term, they are n minus 1 terms. So what I'm trying to make you understand is that here, these n minus 1 terms are forming an AP. They are forming an arithmetic progression. What I know is that this arithmetic progression has n minus 1 number of terms. It has 2 as its first term and 6 as its common difference. By having so, by doing so, I will be able to generate or write its nth term. How? I will be writing Tn on the left hand side. I'll be writing Tn on the left hand side, and on the right hand side, I'll keep this one aside. Plus, now what I have is NAP. I now have basically NAP, which has n minus 1 number of terms. I hope you all can notice it very clearly that this is basically nothing but what? This is an AP which has first term as 2, which has the common difference as 6, and it has number of terms n minus 1. So this is an AP. This is what I know. Can I not find the sum of these n minus 1 terms? I know the formula to find the sum of n minus 1 terms of an AP. What is that formula? N by 2. But the n here is n minus 1. So n minus 1 by 2 times 2a. What is a? A is, I think, 2. So 2a should be 4. Plus n minus 1. But n is n minus 1. So it should be n minus 1, which is n minus 2 into d. The common difference is 6. So this is going to be the Tn. This is going to be the Tn or Tr or whatever you wish to call it. So if I wish to write Tn, it should be 1 plus. This is n minus 1 over here. This 2 goes inside. So this leaves you here with a 2 here and here with a 3. This 3 when multiplies here, it should be 3n minus 3 into 6. I hope there is no confusion on it. What I have done here is I have pushed this 2 inside. So 4 by 2 became 2, 6 by 2 became 3. But that 3 when I multiplied with n minus 2, 3n minus 6. I hope you are comfortably understanding this. Now, proceeding ahead, the Tn can be written as 1 plus. What is n minus 1? It is n minus 1 only. But what is this? This is 3n. 2 minus 6 should be minus 4. So 3n minus 4. Now when I multiply this, Tn now becomes 1 plus n into 3n is 3n square. Minus 3n minus 4n is, I think, what's wrong here? 3n square minus 3n minus 4n is minus 7n, I believe. Correct me if I'm wrong. Minus 3n minus, yes. And this is plus 4. So if I now wish to write Tn, Tn will be written as 3n square minus 7n plus 5. Do you think this is the answer? No, this is not the answer. This is the nth term I have received so far. So by applying that method of difference, I could generalize the nth term. Now what? Now I'll use the concept of sigma, summation, the sigma notation. Why? Please understand, if I could generalize the nth term, if I replace n by 1, I'll get the first term of the sequence I was given. If I replace n by 2, I'll get the second term. If I replace n by 3, I'll get the third term. So this is t1, t2, t3, t4 up till tn. What was the question? The question was to find the sum up till 20 terms. So how do you write the sum up till 20 terms? I'll say if I'm asked to find the sum up till 20 terms, it will be t1 plus t2 plus t3 up till t20. Can we generalize this? This is what we are asked. So I'll generalize it as that it should be written as summation tn, where n is ranging from 1 to 20. I hope you remember it. So summation n is ranging from 1 to 20. And what is tn? Tn we have already discovered is 3n square minus 7n plus 5. So it should be 3n square minus 7n plus 5, right students? Now what do we do next? I think we are going to distribute this summation, because we have learned a property that summation can be distributed over addition or subtraction. So here I can write this summation as summation 3n square. So if I'm writing summation 3n square, 3 being constant can be taken outside. So this will be summation 3 times summation n square. This will be 7 times summation n, and this will be 5 times summation of 1. I hope you are getting it very clearly. Where if I'm writing, then I should write that n is from 1 to 20. N is ranging from 1 to 20. N is ranging from 1 to 20. Now, can you help me with summation n square? We had learned this formula. Can you help me with that, students? I hope you must have this thing in mind, that summation n square is given by, I hope you remember, n plus 1, 2n plus 1 divided by 6. Do you remember this result? So that result I'm using here, summation n square. So this is going to be 3 times n plus 1, 2n plus 1 divided by 6. Although what you need to understand is this would have been the summation of n square. But here instead of n, what do I have? Here instead of n, I have 20. So what I'll do is I'll replace that n by 20. So to avoid the confusion, I have replaced it by n here. So I'm writing this summation up to nth term. Then I'll write the summation up to 20 terms. First of all, I'm writing the summation up to n terms. Summation n is given by n plus 1 divided by 2, where I have minus 7 over here. So I'll use this minus 7. And then summation up till n terms, it is given by n plus 1 divided by 2. What is next, students? The next part is summation 1. So 1 is being added n times. Forget 20 for a while. So 1 is being added n times. So 1 if is added n times, it should be n. So this should be plus 5n. So this should be plus 5n. What you need to understand is I have additionally introduced this step, because this step is giving you summation of n terms of the expression, summation of n terms of the expression you are given in the question. But we are asked summation up till 20 terms. So all I need to do is replace this n by 20 and you will get the answer. I hope this is the part which involves or requires calculation only, which you should be able to do. All you need to do is 3, 20, 21, 41 by 6. 7 by 2, 20 into 21 plus 5 into 20. That calculation is needed to be done, and I'm sure with that you will be able to mark the appropriate answer. So yes, sometimes they deal with calculation, they ask you questions which require calculation, but the question conceptually was simple. You need to observe that what is happening with the difference. It could have been either an AP or a GP. So whenever it is an AP or a GP, this is the standard operating procedure you are supposed to follow. You write it like this, you find the difference, you generalize the nth term. Once you are able to generalize the nth term through this particular observation, you need to apply summation on the nth term. Once you have applied the summation on nth term, you will get something related to n cube, n square, n or constant term. And I think with that, you know how to expand that summation on n square, n and constant term. And that's how, by replacing the value of n up to whichever term your sum is asked, you can get the final answer. So I hope you have understood this particular result, this particular operation as well. Now let us move further and go ahead and talk about VN method. As we have already discussed, VN method is all about being able to generalize the nth term or rth term. Once you're able to generalize the nth term or rth term, the way we have done previously by using method of difference, here also we'll use a technique. Once you're able to generalize the nth term or rth term, you should be able to write that expression as f of r plus 1 minus f of r, or something like that, which we have discussed while discussing the summation or sigma notation. I hope you must have remembered that. I had given you the glimpse of Wien method there. That's exactly what we do. So if we are able to generalize the nth term or the rth term through some means, and if we are able to write it like this, fr plus 1 minus fr, then our job is done. If theoretically you're not able to understand my words, don't worry, I will explain it with this example. Let us focus on this question. I am asked sum of first 20 terms of a particular series. This question is also asked by JEE Mains in 2025. A very good, a very excellent and amazing example of Wien method. And how intuition plays a crucial role, that is what you will understand here. Some of you might get stuck and will ask this question, sir, how are we going to think like this? When I'll be solving this question, at one particular step, most of you might be thinking that this is something for which you require a lot of intuition. I totally accept that. I could develop that intuition with practicing a lot of questions, with a category of questions. So once you start solving previous year's questions, you will also be able to develop that intuition. That how am I able to think like this? You will also be able to think like that. How do you bring that intuition? Let's work on that. First of all, focus on the pattern. Look at the pattern. If some of you are thinking that this is 4.1, 4.2, 4.3, 4.4, no, it is not. It is multiplication. So it is 4 into 1, 4 into 2, 4 into 3, 4 into 4 in the numerator. Similarly, in the denominator also, if you pay attention, this is 3 into 1 square, 3 into 3 square, 3 into 4 square, and so on. My job, first of all, is limited to describing its rth term. If by some means I'm able to do so, I will have my job done. How? Let's work on defining its rth term. Let's work on generalizing its rth term. So if I have started working on generalizing its rth term, how do I do that? See, what I can see is 4, 4, 4, 4 is there in the numerator. So 4 is going to be there in the numerator. Okay, that's the best part. Now, if I look at the first term had 1, second term had 2, third term had 3, fourth term had 4. So I think, sir, rth term will have r. So numerator will be 4r category. 4 into 1, 4 into 2, 4 into 3, 4 into 4. So similarly, rth term will be 4r type of numerator. Rth term will have a numerator of 4r category. I hope you're getting this particular part. Now let's talk about the denominator. What you must be noticing is, sir, 4, 4, 4, 4. So this 4 is there with each term. So let me write that 4 first of all. Then, sir, 3, 3, 3, 3 is there. Okay, so I have this 3 there. But into 1 square, there is a correction here. This should not be 1 square because with that you won't be able to do it. So this should have been 2 square over here. So this should have been 2 square. So 1 square, 2 square, 3 square, 4 square and something like that. So this I'll be writing as, I hope you are realizing, 1 square into here 2 square into 3 square. So 3 into 4 square. That means 3 into r square. I hope there is no confusion on that. The next part, 1 to the power 4, 2 to the power 4, 3 to the power 4, 4 to the power 4, which means r to the power 4. So I need r to the power 4 here. So this is how I am able to generalize the rth term. Let me write this rth term separately here and I'll start working on it. So what have I achieved? Rth term as 4r divided by 4 plus 3r square plus, I think, r to the power 4. So this is how I am able to write the rth term. Now the challenge begins. Now you require a lot of intuition, a lot of observation, a lot of imagination to break it into two terms, of course, as a difference of two terms, so that you can apply the telescoping sum or Wien method. How? Let's work on that. Let me use some basic identities which we all are aware of. Let me use some basic identities. What are those identities? Let's start working on them. So I am seeing r to the power 4 here. Yes, I am seeing 4 here. Okay. So if I use it like this, let me work on the denominator first. Okay. So I'm working on the denominator. R to the power 4, can I write as r square whole square? I hope there is no problem with that. I hope you're getting it. This 4 can I write as 2 square? I hope I can do so. I am writing this 4 as 2 square. Now, in the next step, here we have this 3 square. Here we have this 3 square. So what I'm trying to do is I'm trying to create an a plus b whole square kind of an identity. So I'm having a square plus b square. So what do I need? I need 2ab. So what is 2ab? 2ab will be 2 into r square into 2, which is 4r square. So let us introduce it. So what I have written is 4r square. Do I have 4r square in the denominator? No, sir. I have 3r square in the denominator. But mistakenly, what I have done is I have written 4r square. So to balance it, should I not subtract r square from the denominator? So this is the balanced expression. This denominator is same as this denominator only. This has no change at all, but I am able to write it as per my wish. How and why, you will realize it later, and you will also develop such intuition with some amount of practice. Now, what I did was r to the power 4 I could write as r square square. Then this 4 I could write as 2 square, and this 3r square I'm writing as 4r square minus r square. Now, keep the numerator as it is, which is 4r. I am not making any changes to that. But in the denominator, if you pay attention to this part, are you noticing something interesting? I hope most of you must have noticed. It is a square plus b square plus 2ab, which is a plus b whole square. So this tr, now I am able to write as, this tr, we are able to write as 4r in the numerator, which I'll write later. But in the denominator, this is a plus b whole square. What is a? A is r square. What is b? B is 2. So r square plus 2 whole square minus r square. Right? This is what I'm able to do. Now, okay, that's brilliant. That's great. And what do we have in the numerator? So in the numerator, we have 4r. Okay, fine. Now, again, I'll be using one more step where I'll be writing, see, r square plus 2, if I assume to be a, so can I not treat it as a square minus b square kind of an identity? I hope you all are noticing here that b is r. What is b? B is r. So we have a square minus b square kind of an identity here. So we know a square minus b square is a plus b into a minus b. So what will be a plus b? A plus b will be r square plus 2 plus r, which I am writing as r square plus r plus 2. What will be a minus b? A minus will be r square plus 2 minus r, which I'm writing as r square minus r plus 2. I hope there is no confusion on it. Now, to make an expression like fr plus 1 minus fr, can I write the numerator as a difference of these two factors? If I am able to do so, I would have gotten the step where I'm close to what I want to get. How? Let's work on writing the numerator. So let's say I am writing the numerator as a difference of this and this. What do I get? So in the numerator, I'm writing as r square plus r plus 2 minus r square minus r plus 2. What do I get if I do so? I think I have made a mistake. What is that mistake? Let's work on that. R square minus r square cancelled, brilliant. R minus minus r, which means r plus r, 2r. 2 minus 2, that is 0. So in the numerator, I'm getting 2r. The problem is, in the numerator, I did not have 2r, I had 4r. So to get 2r, should I not multiply this entire expression by 2? I am very close to getting what I should by this effort, finally, by splitting this factor, these two factors, to this minus this divided by this. What I'm saying here is that now I'll be writing TR as 2 times whole of this r square plus r plus 2 divided by this. I hope you are noticing that r square plus r plus 2 will get cancelled by this and be left with this only here. So the first term turns out to be as 1 divided by, I'm really sorry, the first term turns out to be as 1 divided by r square minus r plus 2 minus. The next term, I hope you all must be noticing, when I write this divided by this and this are cancelled and I'm left with 1 by r square plus r plus 2. I hope no confusion on that. So the next term will be 1 divided by 1 divided by r square plus r plus 2. Now the job is done. Why am I saying that the job is done? Let's look at the question now. The question asked us the sum of the first 20 terms of the series. The sum of the first 20 terms of the series. What is it? This is TR. It means if I replace R by 1, I'll get T1. That will be the first term. First term means I'll get this. If I replace R by 2, I'll get T2. What will be T2? That will be this. So basically, which was given to me in a very complicated manner, I could write in this simpler format. Sir, how are you able to claim that this is a simpler format? Trust me, this is a very simple format. How? Because of VN method, because of telescopic sum. Why am I saying so? Because here what you all need to understand is a very simple result, that if I were to ask you sum of first 20 terms, you would say, sir, it should be TR, where R is ranging from 1 to 20. It means it should be T1 plus T2 plus T3 up till T20. So that is what I'm willing to ask. That is what I'm willing to find out. So let us write sum of first 20 terms. So I'm denoting it by, let's say, S20. So let us write that sum of first 20 terms. Let us work on that. So first of all, let us write T1. Do you not think T1, T2, T3, T4 up till T20, all of these terms will have this 2 common? So I'm writing this 2 common outside. So I'm keeping this 2 aside, and here with S20, I'm keeping this 2 aside. Now, what I get if I replace R by 1. So I'm writing T1. I have kept this 2 aside. So I'm beginning with T1. T1 will be 1 upon 1 minus 1 plus 2. So it should be 1 by 2. Okay, so it should be 1 by 2 minus 1 upon 1 plus 2. This is 4. So 1 by 4. So this becomes 1 by 4. I hope there is no confusion on that. Then T2. So T2 will also have this 2 which I have written outside. Then T2. So 2 square minus 2 plus 2. Minus 2 plus 2 is 0. So 1 by 2 square, which is 1 by 4. So this is 1 by 4. Some of you might have noticed what I am going to do next. Here, if you pay attention to this part, this is going to be 1 upon 2 square. You need not calculate it actually, but still I'm doing it. So 2 square is 4 plus 2 plus 2. So 4 plus 2 plus 2 is, I think, 8. So which should be minus 1 by 8. So this is T2. Then we'll get T3, T4, T5 up till T20. So what is the 20th term? Let's work on it. 20th term will have 1 upon 20 square minus 20 plus 2. So 20 square is 400. 400 minus 20 is 380. And 380 plus 2 is 382. This also you need not evaluate, but still I'm writing it as 1 upon 382. You will understand all of this with some amount of practice, that what you need to evaluate and what you need not evaluate. And here, if I'm replacing R by 20, this should be 400 plus 20 plus 2. So it should be 400 plus 20 plus 2. I think 422. So this should be 422. So this is 1 upon 422. Now what I'm saying next is, pay attention to a very simple observation. What is it? Can you not see? 1 by 4, 1 by 4, 1 by 8, 1 by 8, and so on. So the last term of the first term is getting cancelled by the first term of the next term, and that's how all of these will get cancelled. So what will I be left with? 1 by 2 and 1 by 422. Did you understand the beauty of this VN method? So finally, if I were to write the sum of these 20 terms, this boils down to the simple fact 2 times 1 by 2 minus 1 by 422, right? So if I push this 2 inside, I'll be left with 1 minus 1 by 211, I think. I hope I'm sure this is 211. Let me just cross check it. 211, yes. So 211 minus 1. So S20 turns out to be 211 minus 1, which is 210 divided by 211. Correct me if I'm wrong. It is 210 upon 211. I think after this is simply a calculation. It is saying that the sum is in the form of m upon n, which is 211 upon 210. I think this is what we got, or I think opposite, 210 upon 211. Yes, 210 upon 211. So we have the m and n. We are told that m and n are co-prime. So we need to check whether 211 and 210 are co-prime or not. They should not have any factor common except for 1. Their HCF should be 1. That is the meaning of being co-prime. And then you can find the value of m plus n, which I am thinking that you have gotten the value, because 211 and 210 don't have anything common. Because if I look at the factors of 210, let me just solve this remaining part as well, so that you finally get the answer. So let's work on 210. 210 is I think 3 into 7, 21. So 3 into 7 is 21. And we have 10. 10 means 2 into, what is wrong with this board? 10 is 2 into 5. So this is what I have gotten as 210. When I look at 211, so 211, right? 211 is not divisible by 3, 4, 5, 6, 7. No, it is not divisible by 7. So if let's check it whether it is divisible by 2, 3, 5 or 7 or not. So 2 it is not, 3 no, no 5, no 7. So if it is not divisible by 2, 3, 7, 5, it could be divisible by some other number or even it could be prime, I don't know that. But at least it is not divisible by 2, 3, 5 or 7, which means 211 does not have any of these factors. So they don't have any factor common. If they don't have any factor common, S20 I am able to write in the form of m upon n, where m and n are co-prime because m and n don't have anything common in terms of factors, which means my answer will be 210 plus 211. And I think 210 plus 211 is nothing but 421, which is your option C. I think you have gotten the answer very easily, very clearly, without any confusion or hesitation. Now, let us move to the final part where we'll use this inequality arithmetic mean greater than equal to geometric mean. And how are questions formed? Let's work on that. Questions are asked on this particular topic as well and plays a very crucial role. And how should you deal with questions based on this topic? Let us look at that. We know the identity arithmetic mean is greater than equal to geometric mean and will apply in this particular question to crack a question asked by JEE Mains in 2022. So how does it get applied? First of all, we are given a question. We are given a question, or rather an expression, which is said to be f of x, which is 5x square divided by 2 plus alpha upon x to the power 5. We are given x is positive. That's the best part. X is positive, which means this and this term are positive, at least so far, if alpha is not decided yet. Then the value of alpha, because the minimum value of this expression is 14. So minima of this is given. Whenever such questions are asked, since we already are dealing with a variable alpha, so let us try to get rid of this x. How? I need to write these two expressions, this term and this term, in such a manner that when I take the geometric mean, this x square and x to the power 5 are cancelled. Now, all of you must be wondering, sir, how can you cancel x square by x to the power 5? But I can if I use some intuition. How? Can you help me with a number? Can you help me with a number which is divisible by 2 and 5 both? So if I'm asking for a number which is divisible by 2 and 5 both, which means I'm asking for the LCM of 2 and 5, which is 10. So here I am writing it as this x square by 2s. Can I write it as x square by 2 plus 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 x square by 2? My intuition, my motive, you will realize once I write the inequality AM greater than equal to GM. And that intuition you will also be able to develop with certain amount of practice. So here I'm trying to tell you that 5 times x square by 2 I have written as x square by 2 5 times. Let me just make this correction here. X square by 2 5 times. I hope you're getting it. Here, why did I do this? Because now when I multiply x square by 2, 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 I'll be getting x to the power 10. I'll be getting x to the power 10 in the numerator. Now, to get x to the power 10 in the denominator, can I write this also in a little different manner? Yes, this particular result, alpha upon x to the power 5, I'm writing as alpha upon 2 times x to the power 5 plus alpha upon 2 times x to the power 5. So I have split it into 2 terms. So while I'm multiplying these 2 terms, I'll be getting alpha square upon 2 into 2. That doesn't matter. Alpha to the power 5 into alpha to the power 5, that will again become alpha to the power 10. So numerator and denominator both will have a term in alpha to the power 10, which will nullify, numerator and denominator both will have a term in x to the power 10, which will nullify the impact of x to the power 10, and I'll be left with alpha only, so that I could get the final answer. That is my motive, that is my intent. So whenever AM greater than equal to GM needs to be applied, such splitting you need to be aware of. This kind of splitting you should think of. You should be able to think of. Now, how do I do it? So this is nothing but what fx only. I haven't made any changes to the fx. This is fx only. Because 5 times of this I could write as, summation of this expression 5 times. And this I have broken into 2 parts. Half. So if this was alpha by x to the power 5, I halved it. I hope you can see 1 by 2, 1 by 2. What is the advantage of it? Now, on the left hand side, I'll take the arithmetic of these 7 terms. How am I saying 7 terms? Because these are 5 and these are 2. So I'll be taking the AM of these 7 terms. I hope you can see. So this is fx only. So if I am taking the arithmetic mean of these 7 terms, so these 7 terms when added will make fx only, because sum of these 7 terms divided by 7. And sum of these 7 terms is nothing but what? Fx. So if I'm using this identity AM greater than equal to GM, so I hope you know what is AM. AM means sum of all the observations divided by number of observations, which is 7 observations are there, and if I take their sum, it will be Fx. So on the left hand side, I have AM, which is Fx upon 7. Did you get that part? Should be greater than equal to its geometric mean. Now, what is its geometric mean? Its geometric mean should be 7th root of the product of these 7 observations. I hope you must have remembered, if I am taking the arithmetic mean of 3 observations, it should be a plus b plus c by 3. If I am taking the geometric mean of 3 observations, it will be a plus b plus c. Sorry. In the flow, I wrote it as plus. It should be a into b into c whole raised to the power 1 by 3. That's the geometric mean. So if I'm having 7 observations here, their geometric mean will be 7th root of the product of these 7 observations. So let me take the product. So imagine a multiplication sign is given here. I'm doing it directly here. So x to the power 2 into 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 x to the power 2. So the numerator will have x to the power 10. So here I'll be having a power 1 by 7 and the numerator will have x to the power 10 into what else do I have? In the numerator, I'll be having alpha square as well. So let me write alpha square as well. Now, what do we have in the denominator? So the denominator will have 2 into 2 into 2 into 2 into 2 into 2. So 2 is appearing 7 times as product, which means 2 to the power 7. So I'll have 2 to the power 7. And then I have x to the power 5 into x to the power 5. That will make it x to the power 10. So did you get this part? That I could nullify this x to the power 10 with this x to the power 10. So how am I able to think like this? Are you getting this part? That is a part where you need to use your intuition, your approach, your brain, your imagination. That is the part where you'll have to use your intellect. Now, intelligence, right? So here, if I begin with this part, can I say, sir, this x to the power 10 is cancelled by this x to the power 10. When 7 is taken on the other side, you are left with fx greater than equal to 7 times alpha square by 2 to the power 7 whole raised to the power 1 by 7. I think I am not making any mistakes. Yes, we are going right. So let's go back to the question and read what were we given. We were told that the minimum value of fx is 14. The minimum value of fx is 14. But what we know is, by using this calculation, that fx is always greater than or equal to this. So if I'm saying fx is always greater than equal to this, means this is the minimum value of f of x, because fx is always greater than this, which means fx can never be less than this, which means fx has this as its minimum value. So according to us, fx minimum value will be this. Can I not say here that the minimum value of f of x is this only? But according to the question, the minimum value of f of x is given as 14. So here, if this value is treated as 14, which is 7 times alpha square by 2 to the power 7 raised to the power 1 by 7, we are told that this is 14, right? Now, what I'll do is 7 is taken to the other side. So 14 upon 7 is becoming 2, right? So this is becoming 2. If I raise both the sides to the power 7 on the left hand side, I'll be left with alpha square upon 2 to the power 7. And here, I think we are going great. On the other side, we'll get 2 to the power 7. Now, when you simplify this further, I'm writing the next step here. I hope you don't mind. So 2 to the power 7 into 2 to the power 7, which means alpha square is equal to 2 to the power 7 whole square. So alpha will be plus minus 2 to the power 7. What I'm doing here? plus minus 2 to the power 7. But here, let's check this part here. So alpha should be equal to only 2 to the power 7 is what we are given, and it should be a positive value because we are applying arithmetic mean greater than equal to geometric mean. So both of the observations should be positive. So if x was positive, this and this should be positive. This will be positive only when alpha is positive. So I'll discard the value of alpha, which is negative of 2 to the power 7. So I will accept the value of alpha, which is 2 to the power 7. So I have received the value of alpha, which is 2 to the power 7. And 2 to the power 7, we all know 2 to the power 5 is 32. 32 into 2 is 64. 64 into 2 is 128, which we are given in the option C. So this is how we have covered summation of the series and this final part where we discussed inequalities based on means, arithmetic mean greater than equal to geometric mean. Questions on minima and maxima are usually done with calculus, but here there are certain category of questions which can be done with the help of AM greater than equal to GM greater than equal to HM. And how do you think based, questions based on maxima and minima using AM greater than equal to GM inequality? This is the approach. Are we clear on this part, students? Do you have any confusions on that? With that, finally, we are able to conclude sequence and series. Focus on AP, focus on summation of series, then focus on GP, and then finally solve questions on means. Solve the previous year's questions, revise these notes which we are giving you at absolutely no cost. You are also given practice sheets, the DPPs. All of this is available on our PW app, from where a lot of students are already preparing for different competitive exams and getting the desired success. So I think with that we can call it a day. A complete theory in this one shot was discussed thoroughly and comprehensively. If you watch it, everything is revised. Everything is revised. You need not focus anywhere else. Even if you want to keep notes, you have this PDF provided to you. You need to click on the link given in the description. So I think this is sufficient for it, sufficient for the day as well. Let's call it a day here. Thank you so much. You have been a great audience. Take a good care of yourself.